Ever wonder how companies like Netflix recommend your next favorite show, or how your phone knows what you're going to type before you actually do? Well, that's the magic of data science. Data scientists are like wizards behind the scenes, using fancy maths and computer skills to make sense of all the information buzzing around us. They help businesses make smart decisions and predict trends and basically turn raw data into valuable insights. So, if you're curious about the digital world and want to be a part of the team shaping our future, data scientists might be your calling. On that note, hello everyone and welcome to this video on Data Scientist Full Course by Edureka. Well, before we get started, let's take a moment to outline today's agenda. Firstly, we'll cover the basics of data science and understand what it's all about. Then, we'll learn the role of a data scientist and the technologies they use. We'll then explore the data science roadmap and discuss the salary expectations. Moving on, we'll dive into key concepts like statistics and probability, along with the tools like confusion matrix and Bayes theorem. We'll also compare data science and data analytics to gain a clear understanding of their distinctions and similarities. Next, we'll introduce machine learning, including logistic regression and decision trees. We'll get the hands on random forest and KNN algorithms. We'll then explore machine learning techniques such as naive-Bayes classifier, along with support vector machine and reinforcement learning. As we wrap up, we'll touch on the deep learning and the TensorFlow concept. Finally, we'll assist you in preparing for the data science interview, discussing most frequently asked questions and answers. But before we begin, please consider subscribing to our YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also visit the Edureka website for Data Science Training Master Program, the link to which is given in the description box below.
Every day, we create 2.5 quintillion bytes of data. That's enough to fill 500 billion DVDs. Do you know? YouTube uses data science to personalize ads and recommend videos, making it more engaging and profitable. If I want to see cooking videos, I'll get it. On the other hand, Netflix. Do you know how Netflix makes money from data science? Netflix uses data science to recommend movies and TV shows to its customers, personalize its user interface, and create new content. Want to watch horror movies? Netflix has it all. This strategy has been very successful for Netflix. In 2022, Netflix generated over $30 billion in revenue and $6 billion in profit. Just like that, we have Starbucks. Do you know how Starbucks uses data science to make money? Starbucks uses data science to personalize the customer experience and make better business decisions by giving us different offers or coupons to keep us awaited. Data science is the process of extracting knowledge from data. It involves using a variety of techniques such as statistics, machine learning, and data mining to analyze data and identify patterns and trends. Improving products and services, example Netflix recommendations, making better business decisions, example Amazon personalization, reducing costs, example Starbucks fraud detection, are some of the main goals of a data science problem. Now we will be moving to the headline of this video, which is data science. First, we will start with what exactly is data science. Data science is like a magical toolbox brimming with diverse instruments of mathematics, statistics, and computer science, all intertwined to extract valuable treasures of knowledge from the vast seas of data. Data science is a field that gives insights from structured and unstructured data using different scientific methods and algorithms, and consequently helps in generating insight, making predictions, and devising data-driven solutions. So, why do we need data science anyway? Here are a few reasons why we need it. The answer is, we need data science to turn abundant, complex data into insights, enabling informed decisions, innovations, and solutions to challenges across various fields like healthcare, finance, and environmental conservation. Let me tell you it individually and how. We will start with data science for predictions. Data science is pivotal for predictions as it discerns patterns within data, enabling the forecasting of future events. For instance, it aids meteorologists in predicting weather patterns, saving lives during severe conditions, and assists financial analysts in forecasting stock prices and optimizing investment strategies, ultimately driving innovation and informed decision-making in diverse domains. Moving on to data science for business. Data science is indispensable in business for driving optimal strategies and outcomes. It enables retailers to forecast demand, ensuring stock availability and reducing surplus. Through customer segmentation and predictive analytics, businesses can tailor marketing efforts, enhancing engagement and conversion rates. It's the backbone for informed decisions, risk management, and operational efficiency. Moving on to data science for health. Data science is crucial in healthcare, especially for heart disease, as it enables the analysis of vast medical data to predict and diagnose conditions early. For example, by analyzing patient data, lifestyle, and genetic information, predictive models can foresee the likelihood of heart ailments, enabling timely intervention and personalized treatment plans. Now, I will be explaining to you the life cycle of data science, or you can say the things that go into the formation of data science. As you can see, we have the following steps. The first phase consists of defining the business problem, because a well-defined business statement defines a specific goal and is the key to the success of the project. What is the goal of the business? Or what should be the outcome of the business problem? The next step is to collect the data. Once the business understanding of the problem is obtained and the problem statement is defined, the next step would be to collect the data. This is also commonly referred to as data acquisition in machine learning. Data collection is an essential step in data science because data needs to be relevant to solve the business problem correctly. Data preparation is a crucial step in a data science project as it helps clean and bring the data into shape, which is required for further analysis and modeling. This may also be referred to as data cleaning. As part of the data preparation, we treat issues like missing values, outliers, and also transform the data into the required format. As part of exploratory data analysis, data is analyzed using summary statistics and graphically to understand key patterns. This is a relatively simpler step but highly effective in unearthing some useful patterns, and that may prove to be highly actionable. Once the data is prepared and all the hidden insights and hidden patterns from the data are understood, the next step is to build the model. There are two types of data modeling: descriptive analytics, which involves insights based on historical data, and predictive modeling, which involves future predictions. Once the model is built, it is ready to deploy in the real world. The deployment can occur offline, on the web, on the cloud, or any Android or iOS app. Generally, there is some variation in the accuracy of the model built and the model deployed. This is because the model is built on a certain amount of data and is deployed on different data. So, do you want to become a data scientist? The main role of a data scientist involves playing with data, which includes data collection from various sources, performing data cleaning, and transforming the raw data into business insights. Data cleaning and preparation are very important parts of a data scientist's job, and for this, a data scientist needs to be an expert in statistics, mathematics, machine learning, and programming languages. Data scientists should also use visualization techniques to obtain visual insights after data cleaning. This stage is crucial since the right patterns assist in developing an accurate model. After creating the models, model testing and deployment follow. Alright, budding data scientists, that's a wrap on the basics. Keep exploring and delving deeper into statistics, machine learning, and programming languages like Python and R. Remember, the journey in data science is filled with learning. So embrace curiosity, seek knowledge, and unlock the infinite possibilities of the data universe.
Data science is about asking the right questions, not just having the right answers. But is data science the right choice for a successful profession? Let's find out in today's video. According to LinkedIn.com, there are about 250,000 job opportunities in India related to data science. According to Indeed, 8 lakh per annum is the average salary of a data scientist in India, and it may go up to 40 lakh with experience. According to US Bureau of Labor Statistics, there will be approximately 11.9 million job openings for data scientists in India by 2026. So, a huge number of opportunities, a great salary, and an amazing career growth make data science an excellent career path. So, without any further delay, let's get started. Introduction to data science. So, starting with an introduction, what comes to your head when you hear this term called data science or data scientist? Is it something like a scientist doing some random experiments with data? But what are these experiments? What is he exactly doing? Let's understand by checking this example. Let's meet Alex. And Alex loves to watch movies. Alex often spends a lot of time scrolling through the movie streaming platforms, trying to find something interesting to watch. To make Alex's movie choices more enjoyable, the streaming platform used a technique. The platform analyzed Alex's past movie preferences, the genres they frequently chose, and the movies they have rated highly. Using this information, the platform suggests personalized movie recommendations to Alex. As a result, Alex spends less time in searching and more time enjoying the movies tailored to his taste. Now, what technique did it use? What technique did the platform use? How does it analyze everything? What is it called? Right? You might be wondering about that. Now, this technique is called as data science. From the above example, we can derive the definition of data science. Data science is the study of extracting insights and knowledge from data through methods like data analysis and machine learning, aiming to make informed decisions and solve complex problems. Now, you might be curious about this thing called machine learning. Don't worry, we'll dive into machine learning later in this video. So stick around until the end. For now, you can imagine it as teaching computers to learn and make decisions. Like when you learn to recognize things by looking at a lot of examples. It's similar to that. Since we have talked about examples, let's see some real-life examples of data science. In the screen, you can see some of the apps that use data science, like Amazon, Netflix, Instagram, YouTube. Now, let's discuss this one by one. Coming to Amazon, sometime or another, you must have shopped from Amazon. Imagine scrolling through Amazon and feeling like it knows you so well. That's data science at play. When Amazon suggests products, it's not magic. It's analyzing what you have liked and bought before, using data science to guess what might catch your eye. Coming to Instagram, I guess most of you have an Instagram account. And over on Instagram, when you find that perfect post on the Explore page, it's not luck. It's data science analyzing your interest and suggesting content that suits your vibe. Coming to Netflix, now think about Netflix cozying up with you on a lazy day. How does it know just exactly what shows to recommend? Yup, you guessed it right. Again, it's data science. By looking at what you have watched and liked, it predicts what you might want to binge watch next. Coming to YouTube, when you dive into that endless seas of YouTube videos, those recommendations aren't random. It's data science analyzing your watching habits to suggest videos that might fit your taste. So next time, whenever you're enjoying your favorite online sports, just remember data science as behind the scenes wizard, making your experience feel personalized and magical. Now, let's dive into the most trending hot topics of today's world, which is the relationship between AI, ML, DL, and data science. Artificial intelligence, machine learning, deep learning, and data science are connected fields that collaborate to harness the power of data for intelligent decision making. At the core, data science involves extracting insights from data and utilizing statistical methods and algorithms. Machine learning is a subset of AI where system learns from data to improve their performance without explicit programming. Deep learning, another subset of machine learning, focuses on neural networks with multiple layers, mimicking the human brain structure to handle complex tasks. AI serves as an overarching concept encompassing ML and DL, while data science acts as the foundation by providing the raw material, which is data, for analysis and learning. In essence, AI leverages machine learning and deep learning techniques, and both are fueled by the principles of data science, collectively shaping the landscape for intelligent technology and decision making. Now, once we understand what data science is, let's discuss the roles and responsibilities of a data scientist. The first step for a data scientist is to identify relevant data sources, both internal and external. that can provide valuable information for analysis. They can acquire the necessary data using methods such as web scraping, APIs database queries, or integrating with various data storage systems. The next step involves data cleaning, also known as data pre-processing. This consists of handling missing or inconsistent data, addressing outliers, and ensuring data quality. Data cleaning is crucial to ensure that the data used for analysis is accurate and reliable. The third step is exploratory data analysis. Data scientists perform exploratory data analysis to understand the characteristics and patterns within the data using statistical methods and visualizations. This involves selecting, modifying, or creating features that are most relevant to the analysis or predictive modeling. Then we have model development. Data scientists choose appropriate machine learning algorithms based on the nature of the problem and data. They train the selected models on historical data to learn patterns and relationships. The fifth step is model evaluation. After model development, the data scientists evaluate the performance of the trained model using metrics like accuracy, precision, recall, or F1 score. Based on the evaluation, model may be fine-tuned or adjusted to improve their predictive capabilities. The next step is deployment and modeling. It includes deploying the model into productive environment for real-world applications. It involves continuous monitoring of model performance to ensure it remains effective over time. This consists of handling drift, adapting to changing patterns, and updating models as needed. Lastly, we have communication of results. Data scientists communicate their findings and insight to non-technical stakeholders through reports and dashboards. Now, let's understand what is the difference between data and information. Throughout this video, we have used the term data a lot of times. Now, let's understand what exactly defines data. Imagine you have a list of numbers, 5, 10, 15, 20, 25. These are just isolated figures of raw data. They need more context and meaning on their own. These numbers represent the score of a student in 5 different subjects. Suddenly, you have context and meaning attached to the numbers, transforming them into information. For instance, you can understand that the student scored 5 in the first subject, 10 in the second, 15 in the third, and so on. This organized and interpreted set of data becomes information, providing insights and a more comprehensive understanding of students' academic performance. In simple terms, data is like puzzle pieces, and information is the complete picture that emerges when those pieces are arranged and interpreted in a meaningful way. Now, let's get into model building. In the field of data science and machine learning, model building is a pivot step where data scientists construct predictive or descriptive models to extract insights and make informed decisions. Model building includes machine learning algorithms. So, in order to understand that, we need to first understand what machine learning is. So, coming to the definition of machine learning is the process of building a model using a set of algorithms that train on a data set to make predictions or take actions in order to optimize their system. There are basically 3 types of machine learning algorithms: supervised learning algorithm, unsupervised learning algorithm, and reinforcement learning algorithm. Coming to supervised learning algorithm, when we deal with labeled data sets, we use supervised learning algorithm. In supervised learning algorithm, we use algorithms such as linear regression, logistic regression, SVM, etc. Over here in the figure, you can see these user ID, gender, age, salary, purchase. These are the features of a data set. Okay, and you can see this works as a labels. So whenever we are dealing with a labeled data set, we use the supervised learning algorithm. But we do know that data sets are always not labeled. So what to do when we have unlabeled data sets? Whenever we are dealing with the unlabeled data sets, we use unsupervised learning algorithm. Algorithms such as K-means clustering, hierarchical clustering, Apriori algorithm are some of the unsupervised learning algorithms. In the figure, you can see we don't have labeled data, we have different shapes. By using this unsupervised learning algorithm, we are finding patterns in the shapes. We are finding a relationship between the patterns that have a relationship within itself, right? Now, moving forward, we have reinforcement learning algorithm. Reinforcement learning is a type of machine learning paradigm where an agent learns to make decisions by interacting with an environment. The agent receives feedback in the form of rewards or punishments based on the action it takes, and its objective is to learn a strategy or policy that maximizes the cumulative reward over time. Algorithms such as Q-learning and deep Q networks are some types of reinforcement learning algorithms. In order to study these algorithms in detail, you can go through our Data Science with Python certification course, the link to which is in the description box below. So, by now, I expect that all of you have become clear about the theoretical concepts. And now, let's finally move to practical demo where we will be building an end-to-end hands-on model. Now, previously in the model building section, we explored supervised learning. And over there, we came across a learning algorithm called linear regression. So firstly, let's understand the working of linear regression and then we will be building a linear regression model. So, to understand linear regression, let's take an example. Do you remember Alex, a movie-loving kid? Imagine it's been 20 years and guess what? Alex is now a successful data scientist who is looking to buy a property. Alex examined many properties, each with unique features and prices, giving him an understanding of how these features influence the property's value. So now, when he encounters a new property, he uses his knowledge of these features to estimate its price. But how does he do that? How is Alex able to predict the price of a new property just by examining its features? He is able to do that with the use of linear regression. How? Let's understand. Let's take the previous properties as P1, P2, P3 and P4 and P5 be the property whose price we need to evaluate. Now, let's start by plotting it on a graph where the dotted line is considered to be the hypothesis to evaluate the price of P5. In this example, in order to get this hypothesis, we took the average of the prices. The point that you can see on the graphs are the data points, and the red line represents the error by showing the distance of these data points from the hypothesis. The overall magnitude sum of this error is called as sum of squared error, which is calculated by L1 square plus L2 square plus L3 square plus L4 square. Now, can you guys tell me why we took the squared sum? We could have taken it without a square also, right? Like L1 plus L2 plus L3 plus L4. Think about it. One hint that I can give is consider the directions of the data points. Think more and kindly put your answers in the comment section. Now, in the last example, we took one feature which was price and we were getting one error value. But what if we take other features like area, bedrooms and house age into consideration? Will our error value decrease in this case? Let's find out by building a linear regression model. But before that, we need to install the Jupyter Notebook where we will be writing our codes. So, moving forward, let's get into the installation part of Jupyter Notebook. Now, very firstly, we will be installing Anaconda, which is a popular distribution of Python and R for scientific computing. It basically simplifies the management of packages and environment. In order to install Anaconda, you can visit this website and I'll be putting this website link in the description box. You can directly access it from there. After coming to this website, you can scroll down and here you can select the installer based on your system configuration. Since Anaconda is a heavy software, so it might take time to install based on your system configurations. In my system, I have already installed Anaconda. Over here, in the downloads, you can see Anaconda. After installing the Anaconda successfully, go to the search box and type Anaconda Navigator. Again, since Anaconda is a heavy software, it might take a bit more time to open. Now, once it opens, you can see the Jupyter Notebook over here. Click on Launch. And now, the Jupyter Notebook opens in a default browser. So over here, click on New, click on Python 3. And now, finally, we can start our coding. So, let's start by importing some libraries. So, we'll go with import matplotlib.pyplot plot as PLT. Then let's import NumPy. So, import NumPy as NP. Then from scikit-learn, we will be importing datasets and linear model. Now, from scikit-learn dot matrix. We will be importing mean squared error. Then we will be assigning it to diabetes. So how to do that? Datasets dot load diabetes. Shift plus enter. So here it comes 1, means we are done with the importing of our libraries. Now what we did, okay, why are these modules are necessary to build a model? Let's understand them one by one. At first we have matplotlib.pyplot and I gave an alias for it as PLT. This library basically creates visualizations. We will be using this library to plot graphs to understand our data and the results of our model. Next, we have NumPy as NP, which helps us to work with multidimensional arrays. After that, we imported our most important library, scikit-learn, and from that library, we imported these two modules, datasets and linear model. Since we are building a linear model, so we imported this linear model module. Now, for linear regression, we also need the mean squared error. Therefore, I imported this mean squared error library. Diabetes equal to datasets.load diabetes. Here, we load the diabetes datasets from sklearn.datasets and assign it to the variable diabetes. Now, let's check the description of the dataset that we imported. So, for that, we'll be having print diabetes.dscr, which means the description of diabetes. Okay, so over here you can see the description. Okay, we have 442 instances. The first 10 columns are numeric predictive values, and column 11 is a target column, that is a quantitative measure of disease progression 1 year after baseline. Over here we have 10 attributes, which are age, sex, BMI, BP, S1, S2, S3, S4, S5, S6, and the last 11 feature is our target feature. Here is the source URL from where we got the dataset. Now, moving forward, let's check the keys of the dataset. Print diabetes.keys. Shift plus enter. Over here, you can see the keys of the dataset. That is data, target, frame, description, feature names, data file name, target file name, and data module. After that, let's print the data that we imported. So, diabetes.data. Now, over here, you can see the data that we imported. It's the data that is present in the diabetes dataset. Now, if you guys remember, during the slideshow, in the example that we took for linear regression, we took only one feature, that was price. Okay, so over here also, we'll start by taking only one feature into consideration. And that one feature, let's take as body mass index. So it is 0, 1, 2. It's in the second index. Okay, so how to take that? Let's check. So let's first assign a variable diabetes.x, and then from diabetes.data, I only need the second one. So np.new access. Over here, np means numpy that we already imported. So 2, because we need the second index, and then we need to print. So print diabetes_x. Shift plus enter. Yes. So over here, you can check this data set, and you can also see that it's in multidimensional array. We have a whole array. Inside that, we have small arrays, right? Yeah. So NP helps us to work with the multidimensional arrays. That's why I imported that. Now, since we got our one feature data set, let's split it into training and testing data set. How to do that? So initially we'll be having diabetes x train. Now I'm splitting this data set into two parts, the ratio of 70 and 30. For training, I'm taking the first 70%, and for testing, I'm taking the last 30%. So moving on, diabetes x, let's take first 30%. So we'll take it by using slicing. Then diabetes x test part, we need diabetes x, and over here we need the last 30. Y train, we have diabetes X. Again, we need last 30. Sorry, first 70. Over here, minus 30 means we are excluding the last 30 elements. Then diabetes Y test equal to diabetes X last 30% we need. So from minus 30 till the end of the data set. Shift plus enter. Now the splitting is done. For training, we took the first 70%. Okay, it means we excluded the last 30%. And that last 30% over here, we took it for the testing data set. Again, for Y train, we took the first 70%. It means from starting till excluding last 30. And again, last 30 we took as Y test. Now, let's work on a model now. So, model equal to linear model, and from that linear model, we need linear regression. Then, we need to fit this model with training data set, right? And diabetes Y train. Shift plus enter. Over here, you can see the linear regression. Now, moving forward, let's make a variable which is actually going to store the predicted target value. And for that, diabetes Y predicted equal to model dot predict. And what we want him to predict, it's the diabetes X test. The testing value we need him to predict. Then we will be also printing the mean squared error. So mean squared error. We will be using the mean squared library that we imported. Mean squared error, and over here we need diabetes X test and diabetes Y predicted. Shift plus enter. Yes. So over here you can see the mean squared error as 3035. Now let's also check the weight and intercepts. So print weights, and in order to check the weight, we need to put model dot coefficient. So coefficient COEF underscore, and then moving on to intercepts, we need model dot intercept underscore. Shift plus enter. Yes. So over here you can see the weight as 941 and the intercept as 153. Now let's bring all these points into a graph. Let's plot our data points. So in order to plotting it in a graph, we'll be using the matplotlib. So if you guys remember, we put it plt as an alias for matplotlib. plt.scatter, what we want diabetes X test and diabetes Y test. So we have diabetes X test over here, Control C, Control V, comma, and diabetes Y test we need. Okay, Control C and Control V. Then we also need to plot the hypothesis. So for that, plt.plot. How are we going to plot the hypothesis? We'll be needing diabetes X test and the predicted value. Control V, comma, diabetes Y predicted. Now in order to show the graph, we need plt.show function. Let's check, shift plus enter. Yes. So over here, you can see the graph. Okay. This plt.plot is going to give you the hypothesis, and plt.scatter are the data points. Okay. Now, if you guys remember, again, we took only one feature, which was body mass index, right? And by taking only one feature, the mean squared error is 3035. Let's copy this and let's put it over here. Okay, mean squared error Let's comment it out. Now, mean squared error is 3035 after taking only one feature. Now, what was the question that we were having at the end of the slide? Will our mean squared error will decrease if we take more number of features? Let's find out that. So, over here, we took only one feature. Now, instead of one feature, I'm going to take the entire data set, right? So, I took the entire data set. For now, I'm going to comment all this out. Then I want kernel and I want to run all cells. It might take a bit time. Okay. So here you can check that the mean squared error is 1826. It reduced. Initially it was 3035 after taking only one feature, and it went to 1826 when we took all the features. So that is the core concept that we used in linear regression. Okay, I guess all of you now understood the core concept of linear regression. In simple words, the more number of features we have, the model is going to be that accurate, right? Now, since you guys understood everything into the linear regression, you guys understood the core thing of the linear regression, core concept of the linear regression. Now, moving forward, we are going to build a house predictive model. We'll be using California housing dataset in order to train that model. And then we're going to check what are the usual prices of the model. Cool. So we'll move forward. We will be building a California house price prediction model. In this project, we'll work on developing an end-to-end machine learning project using linear regression. We will be doing extensive data visualization. We perform data feature engineering. We will also see how we can select features based on the correlation of the features. So, very firstly, we'll start by importing the libraries. So, import numpy as np, import pandas as pd. Then we will be importing our visualization libraries. So, plotly.express as px, import plotly.graph objects as geo graph objects. Then import plotly.io as pio, and we will be using templates for pio. Then we will be also importing cburn as SNS, import matplotlib.pyplot as PLT. We will be using an inline for matplotlib. Shift plus enter. We'll wait for some time. Okay, so we are done with importing the following libraries. Then we need to import our dataset. So from sklearn.datasets, we will be importing fetch housing. Yes, so from sklearn.datasets, we'll be importing California housing dataset, and we'll be making a variable and we'll assign this dataset to that variable. California housing. Okay. Then x as housing.data and y equal to housing.target. Then data equal to, we are using pandas over here and making it a data frame, x comma columns equal to housing dot feature names, and then data of sales price. The sales price is the name of a target column, which is y data dot head. Let's check. So shift plus enter. Okay. So here you can see a data set in a table format. Okay. We use pd.data frame to achieve this format. Now let's also check the description of the data. So housing dot DSCR. Shift plus enter. Over here you can check the California housing dataset. California housing dataset, we have number of instances as 20640 or 20,640. Number of attributes as 8 numeric. Predictive attributes are the target. So the 8 attributes are medical insurance, house age, average rooms, average bedrooms, population, average occupation, latitude and longitude. Here is the URL in order to fetch this data set. Now let's also check the shape of the data set. So print data dot shape. Over here you can see 20640 rows and 9 columns. Now let's also check the info of the data. So data dot info. Over here you can check the memory usage that our data set is taking, and if there are any null values in the columns, like medical insurance, it's no null value. Okay, the data type you can check, the no null count you can check over here. So in our data set we have 20640 not null values. Now let's also describe the data. So data dot describe. Now what this describe function is going to give, it's going to give count, mean, standard deviation, minimum 25%, 50%, maximum of particular columns, of particular features. In medical insurance, what is a count? We know 20640, we have the number of rows. So 20640 is the count of medical insurance, house age, average rooms, average bedrooms and every feature. And you can see the sales price, it's our target feature. We have mean, standard deviation, mean and everything. Now one more method to check whether our data set is containing any null value or not. So we have data dot is null over here dot sum. So over here you can see the sum of the null values, and since we don't have any null values in our data set, it's 0. Let's play with the graphs. Okay, so SNS like Seaman library we are going to use. So pay plot data height, let's give 2.5. Then we have PLT layout. Okay, shift plus enter. Now this might take some more time, so let's wait. Here we use tight layout, so we might see some warnings, but I don't think we will see an error over here. Okay, we are getting the warnings, but let's wait and let's check if we get any error. Okay, so here you can see the graph, but I'm sure you're not able to understand any of the relations. So basically what it gives or it shows a correlation between every features that we have. If I zoom in, okay, that's too much. Yeah, over here if you can see, it's medical insurance for sales price, for longitude, for latitude, for average rooms and so on. And the x-axis also you have medical insurance, house age, average rooms, average bedrooms. But it's very evident that this representation is not understandable by many persons. So let's make it easy. Let's make it more understandable. So for that we use SNS dot plot, and let's take our target into consideration. So sales price. Okay. Yes. Over here you can see it shows a graph for sales price and the density, which is more relevant than the previous one. Now we can also see there is some skewness and kurtosis. So let's measure skewness and kurtosis. So print, we want the skewness over here, data, okay, anything of the sales price, and we also need 𝐷𝐸 method for this, very important. Same thing, Control V, but we need kurtosis, and over here we need 𝐷𝐸 for kurtosis. Let's check. Yes, so skewness is 0.97 and our kurtosis is 0.32. Okay, so moving on, let's play with the graphs and let's create a scatter plot. How to do it? So firstly, figure AX equal to PLT dot subplots. Okay, then AX dot scatter, and over here we need X equal to data, and that data X, let's take medical insurance, Control V, and Y will be our target variable, like sales price. Then sales price, comma, font size, let's say 30. Then X label as medical insurance. Over here also, font size, let's keep it to 13, and then PLT dot show. Yes. So over here, the first line creates a figure Fig and set a set of subplot Ex. In this case, since no arguments are provided to the subplots, therefore it will create a single subplot. Moving on, the second line plots a scatter plot on the axis Ax. The X and Y parameters are set to the medical insurance and sales price columns of the data frame respectively. This means that the plot will have medical insurance value on the x-axis and sales price value on the y-axis. This PLT.y label sets the label of the y-axis to sales price and adjusts the font size to 13. Similarly, the next line sets the label of the x-axis to medical insurance and sets the font size to 13. This last line, PLT.show, basically displays the plot. Over here, you can see the relationship between medical insurance and the sales price. So now, let's write a code that analyzes the sales price data to see how well it conforms to a normal distribution. So, from SciPy, import stats. This line imports a stats module from the SciPy library, which contains a large number of probability distributions as well as a growing library of statistical functions. Then, from SciPy.stats, import normal and skewness. Here, specific functions like norm for the normal distribution and skew for calculating the skewness of a distributions are imported from SciPy.stats. Then, SNS distribution plot, data, and fit equal to norm. Okay, so this line creates a histogram using Seaborn's displot function with the data taken from the sales price column of the data frame. The fit equal to normal argument fits a normal distribution to the data and overlays this on the histogram. Then we have mu, comma, sigma, equal to normal dot fit data series price. This line calculates the parameters of the normal distribution that best fit the sales price data. Mu is the mean and sigma is the standard deviation. Run. And sigma dot format sigma. Okay. This prints the calculated mean and standard deviation to the console, formatting them to 2 decimal places. Then we have PLT dot normal distribution and here also 2 decimal dot mu and sigma. Okay, so this adds a legend to the plot describing the normal distribution with the calculated mean and standard deviation. Then it sets the title of the plot. Let's make it more clear. Okay, so PLT.figure creates a new matplotlib figure. This is the preparation for the next plot. Sales price, comma. Okay, this generates a probability plot which is used to determine if the sales price data follows a normal distribution. The data points are plotted against the theoretical quantities of the normal distribution. And then PLT.show. This displays the plot. Okay, so we should press enter. Yeah. So as you can see, this code analyzes the sales price data to see how well it conforms to a normal distribution, both through a histogram and a QQ plot. It is a common step in data analysis to check the distribution of variables, as many statistical tests and models assumes normality. Over here, you can check mu equal to 2.07 and sigma equal to 1.15. Now, let's write the same code but with a twist. So over here, I'm going to put data sales price equal to np dot log 1p. Then from here, let's copy paste the same code. Control C. Ignore the warning. Now over here you can see mu equal to 1.06 and sigma equal to 0.36. It reduced as compared to the previous one. So as you can see, this code is similar to the previous one, but with a key difference. It first applies a logarithmic transformation to the sales price data before analyzing and visualizing its distribution. This code snippet is used to access whether the log transformation of the sales price data results in a distribution that more closely resembles a normal distribution, which is often a desirable property in statistical modeling and analysis. Now, let's move to data correlation. So, PLT figure, we need fixed size equal to 10,10 COR to data dot CORR SNS dot heat map we are going to use. Comments as COR rotation true. Then okay, so this code snippet is creating a heat map to visualize the correlational matrix of the data frame using matplotlib and Seaborn Python. The heat map is a useful tool in exploratory data analysis to visually inspect the pairwise relationship between variables, helping to identify variables that might be highly correlated or uncorrelated with each other. Now, let's also check the relevant features. Firstly, we have target equal to yes sales price. Now, this line creates a series containing the absolute values of correlational coefficient between sales price and all the other columns in the correlational data frame. Taking the absolute value means we consider both strong positive and strong negative correlation as significant. Relevant features. Target, and over here we want code target greater than 0.2. So this filters correlational target to only keep entries which are correlational coefficient is greater than 0.2. The choice of 0.2 as a threshold is arbitrary and can be adjusted depending on the context or domain knowledge. It's a way to select features that have at least a moderate relation with sales price. Then names equal to index value in relevant features. This list comprehension iterates over the relevant features and collects the index labels into the list names. We want to remove sales price. Now, it removes sales price from the list as it is a target variable itself and not a feature to be used for prediction or analysis with respect to sales price. Then, names. It prints a list of feature names that have a significant correlation with sales price, which we wanted. And then we'll write the length. How many are there? So shift press enter. So over here, medical insurance you can see as a relevant feature. Now, with this, let's finally move into the model building. So, starting with model building, first thing is the importing of the data sets. So, sklearn dot model selection, import, train, test, split, and then drop. We are gonna drop sales price because we wanted it in Y. Let's check access. So, what are we doing over here? We are again splitting the data set into the training data set and the testing data set. Okay. Over here, X contains all the features and we excluding the sales price because we need it for the target variable Y. So, Y equal to data. And what we need over here is the sales price. Over train, comma, test, Y train, comma, Y test, equal to train, test, split, X, comma, Y, comma, test size which we wanted to keep is 0.2. And we want the random state as 42. Let's make it look a bit proper. Okay, so training and testing data set splitting is done. After that, we're gonna print it. So print x underscore train dot shape. By shape, we will be getting the number of rows and columns. So print similarly x underscore test dot shape. Similarly, print y underscore train dot shape and dot shape. So here you can see the training and testing splitting of the dataset. Now, since our model will be a linear regression model, so let's import that. So from sklearn dot linear model, import linear regression. So let's give it LR equal to linear regression. Then we will fit the training data sets. So X underscore train and Y underscore train. With this, we will be training our model with the training data sets. Shift press enter. Okay, over here it's form. Let's see here. Shift press enter. Yes, over here you can see the linear regression. Now let's check the predictions. So predictions equal to, we want our model to predict the X test values. So X underscore test. Now let's check it, what our model have actually predicted. So firstly we'll print the actual value. Actual value of the house will be test 0. Then let's print the predicted value or the model predicted value. It will be predictions. Okay, that looks good. Shift press enter. Okay, so here you can see the actual value is 1.7 and our model predicted value is 0.6, which is a decent value, which is a decent prediction. Now, since linear regression model is a very basic machine learning model, the prediction which it is given is quite decent. Now, let's also check the mean squared error. So for that, sklearn tricks board mean squared error. That let's mean squared error equal to, oh, sorry, here, okay, let's see equal to mean squared error Y test, and we need predictions. And let's also check the root mean squared error. We will use square root of MSE. And finally we'll print it. Let's print MSE. So you can see the mean squared error is 0.05, which is a good one. Okay.
Now let's get started and understand who is a data scientist. Well, when the term scientist comes to our mind, the first thing is experiments. So scientists are related with experiments, and a data scientist is related with data and experimenting with that data. So a data scientist is someone who experiments with data and has certain tools and technologies at his disposal to draw insights and meaningful patterns from this data. So these tools and technologies are being listed here, and we will cover first machine learning. Now, this machine learning is a very important tool for a data scientist to build and test models. Also, another tool is programming language to extract, analyze, and manipulate the data. A data scientist also uses yet another important tool, and that is statistics. So now statistics is used to make predictive analysis, to understand and interpret the results from the data. So statistics is really important tool for a data scientist. So another tool is database. So database is yet another important tool, which means to access the data. Yet another tool is big data to work with complex data set. And big data technologies are really required now in a data scientist. We will cover all these technologies in detail in the coming up slides. Be patient a little, and this is just a coverage of giving you a brief gist of the tools and techniques. So another technique is deep learning. So a data scientist is also required to have the knowledge of neural networks, NLP, to draw meaningful insights from unstructured data and also to process such data. Now let's move on to discussing about the role of a data scientist. So what exactly does a data scientist do? And this will be clear once we go through a few job responsibilities. of a data scientist. Now, this data has been taken from Glassdoor. So let us look at the role that a data scientist needs to perform. And as you can see in the right-hand side, the gist of the role is being listed. So a data scientist is required to build and test and iterate on the machine learning model. So we've already covered the machine learning is the indispensable tool of a data scientist. So iteration requires a lot of repetitive experiments with the data, and it is quite a complex process. And repetition is done to improve the results of the model. So a data scientist is really required to iterate again and again over the machine learning models. Although the building part is not so much, because already the companies are working under predefined, pre-designed, coded software. So testing and iteration becomes the indispensable part of a data scientist. Now, another role, if we look at here, is that they're working in teams. So working in team with the engineering team to deploy, validate, and monitor the machine learning models. So this is very important, because once a model goes to the production state, so you have to monitor it. And also you have to undertake the deployment of it, how to really connect it with the front end and see how is it really working, what accuracy is it giving. And then most importantly, a data scientist is required to research data, identify opportunities. Now this means that drawing useful insights from the data by using various techniques, as we have seen earlier. So a data scientist applies all these techniques together to draw meaningful insights from the data. And now let us understand what all to learn to become a data scientist, so that this role is suited for a data scientist and one can perform this very well. So the technologies to learn for a data scientist are programming language. It could be either Python or R, machine learning, deep learning, and NLP concepts, which need to be really very clear and solid foundation of the same. Another technology to learn is statistics, that is both descriptive and inferential. Another technology is database, knowledge of SQL and NoSQL, and big data. Big data, the knowledge of Hadoop, Spark, any one of them is required. So now let's cover these technologies in detail. Now, moving on forward to the programming language. Now, why a programming language is really required by a data scientist is to analyze huge volumes of data and also to perform analysis of the data. So programming language really aids in better analysis, manipulation of the data. So programming language generally used are Python, R, Scala, or Java, but generally preferred is Python, and it's the most popular language which is now being used in the data science community. R is also there, but on the production side, it becomes a little tough. Okay, so now we will cover both the languages and the important libraries to study for these languages. So now moving on forward to programming language, Python. So in Python, what all needs to be covered? First library is pandas. Now this library is very important because this is used for data analysis and manipulation. And pandas also provide very fast, flexible data structures. This means that numerous functions and methods are available in pandas, which allows you to perform data analysis and manipulation of the data very quickly and very fast. And time series analysis is also possible with the help of pandas. So the examples, like when you're forecasting weather predictions or stock prices predictions or houses predictions, then pandas really help, in data analysis and manipulation. So that's an example of that. Now coming to NumPy. This is another library which is numerical Python, and this is used for scientific computations. Now, numerical calculation in machine learning is done with the help of NumPy, and this is the foundation, I would say the building block of Python. And all the calculations, mathematical calculations, scientific computations is possible because of NumPy. And NumPy contains multidimensional array and matrix data structure. With these powerful data structures, one can really perform efficient calculations in Python. All right. Now, moving on forward, we have the visualization libraries like Seaborn and Matplotlib. These two libraries are used for visualizing the plots, looking at the spread of the data and seeing how does the data look, whether are there any outliers, or what is the spread of the data. Is it normally distributed or it is unevenly distributed? So these visualization libraries really help us to visualize the data. And also another thing is that Seaborn is built over Matplotlib. That means that it derives functionality methods from Matplotlib, but offers more flexibility in terms of plotting the graphs, and better representation in terms of color, and aesthetically beautiful plots can be plotted with the help of Seaborn. So now we are moving forward to another language, which is R. So R is also preferred in the data science community, and data scientists work with R. R has very strong statistical packages as it was developed by statisticians, and R is really good for data analysis. But when you take next step into machine learning, R has its limitations too, as we have discussed earlier also. So now for R, if we are using R, then we can use dplyr package. Now this is used for data analysis and manipulation and for the exploration of data. dplyr is a very strong package and it is a grammar of manipulation in R. This means that dplyr provides us a consistent set of functions. Then these functions are called verbs. So R has a defined language and that language has to be preserved. So we use verbs here. So functions are called verbs here and they help to perform the manipulation on the data. So now moving on forward, we have another package and that is janitor. And this is used for data cleaning, like removing empty values or removing duplicates from your data and so on. So one thing to note here is that data scientists really spend most of the time in data cleaning, in transforming the data, in just removing the missing values or empty values or cleaning. Cleaning is the most part that data scientists spend to. So these libraries can be really helpful when one is building models or one is working on various complex kind of a data. So now moving on further to another library, that is lubridate. And this lubridate is for date and time manipulation in R. And for Python, we have pandas. All right, for date and time analysis. And this really helps because it already has functions and methods predefined, which understands date and time analysis and manipulation can be done very easily with the help of lubridate. Now, another library that we would cover is ggplot2 for data visualization in R. Now, this GG stands for Grammar of Graphics. Now, in R, ggplot2 is used to make the graphs plots, and we work with layers in ggplot2. So, with the help of these layers, we can plot a very complex plot with the help of ggplot2. And we can say that ggplot2 has very aesthetically appealing plots and it gives us the flexibility to show our data in various structures and various formats, and we can always see what the data is saying. So we visualize the data with the help of ggplot2 in R. Now I want to tell you something really very interesting as why is data visualization important? And now let us just uncover this thing. The significance of data visualization can be understood with the help of the image here on the left hand side. And this is known as Anscombe quadrant. Now, Anscombe was an English mathematician and he developed this quadrant to demonstrate the importance of data visualization. Now, this comprises of four, as we can see, four data sets. And these data sets have the same or identical simple descriptive statistics, right? But when they were being plotted, we get different graphs of each data set. Now, this is the importance of visualization, that the numbers and figures will appear same, but when they are plotted, they would be different. So to get the real picture and the meaning of your data needs to be plotted to get the true picture. All right. So it's always been said that numbers will not reveal the true picture, but the visualization of that data would definitely reveal it. So this was a very important Anscombe quadrant to visualize that, yes, data visualization, why is it really important? So moving on further, linked with this is data visualization tools that a data scientist uses, and one can learn these tools. It could be very handy. So a few visualization tools or softwares are Power BI, Tableau. Now, these tools really help you to visualize large data sets. And these powerful softwares, they can connect with multiple data sources in no time. You can build dashboards, interactive dashboards, powerful visualization, and even you can go on creating applications with these tools. So business intelligence tools knowledge is one of the requirements, but it is not that necessary. It's easy to learn and it's fun too. Okay, now coming on to another concept after programming language, and that is machine learning. Now, machine learning, this is the ability to understand algorithms, both supervised and unsupervised machine learning algorithm. So now we will discuss about supervised and unsupervised machine learning algorithms. So supervised is something when we work with labeled data, that means the output is known, and unsupervised is when we don't know the output and the algorithm has to make a guess, okay, what is this and which category or which cluster will the data fall into. So primarily we deal with supervised machine learning, and there are two types of supervised machine learning, that is classification and regression. And in unsupervised machine learning, we will see dimensionality reduction, and then various algorithms like clustering. And in clustering, there are so many algorithms like hierarchical clustering or k-means and so on. So a data scientist has to know about the algorithms, different kinds of algorithms that can be applied to a data to give good results. That's why it's a little vast, but it is really very interesting. So various algorithms like SVM, naive-Bayes, random forest, k-means, good command over the supervised and unsupervised machine learning is required by a data scientist. Hyperparameter tuning. Now, this is again important because hyperparameters are nothing but they control the behavior of an algorithm. So you can say that if hyperparameter tuning is being done or performed on any algorithm, that is done to improve the results. So for model optimization, this is required. So to improve the predictions by tweaking a few parameters via hyperparameter tuning, that is what a data scientist also does. So to learn machine learning, moving on forward now, to learn machine learning in Python, what libraries are required is that scikit-learn is a package for machine learning library in Python. So the scikit-learn is the machine learning library, and this supports both supervised and unsupervised learning. And it also provides various tools for model fitting, data pre-processing, model selection, model evaluation, and other utilities. So if you're making any model or you're importing any of the algorithms, scikit-learn package would be used. Okay, now moving on further to R. So in R, if one wants to build machine learning models, so MLR is the package or caret is the package. So here MLR has all the important and useful algorithms to perform machine learning tasks, and caret stands for classification and regression training. So with caret, one can process and streamline model building and evaluation process. Also, feature selection could be done, and other techniques are also can be applied with the help of these libraries. These are very strong and powerful libraries which have consolidated packages, and you just need to import it in your project and use it. But the knowledge of how to use it, where to use it, is what the data scientist knows. So now moving on further to another technique and technology, that is deep learning techniques. So now when we want to work with complex data sets, when the data set size is huge, then traditional machine learning algorithms, they are not preferred. And generally we move on to deep learning. So gradually from machine learning, one moves to deep learning. That is a gradual shift. So when we talk about deep learning, what comes to our mind is neural networks. So when you're working with various kind of layers and neural networks, then deep learning is preferred. And neural networks or they are a set of algorithms which are modeled, loosely after the human brain to recognize patterns. So just as to make the system more intelligent by just understanding the patterns and predicting. So deep learning is more advanced than machine learning, I can say. So a few deep learning algorithms are convolution neural networks, RNN, that is recurrent neural networks, or LSTMs, which is long short-term memory network. And there are many other deep learning techniques or algorithms. So these algorithms, they help to solve complex problems like image classification or text to speech or language translation. So these are really very powerful algorithms which are deployed to solve real world challenges and how to really make life simple. So now moving on forward to natural language processing. And what if I say that we all have sometime or the other had experienced with NLP and we know the end result? How? Remember Siri and Alexa? Yes, I'm talking about natural language processing. And this is a subfield of artificial intelligence. And this is concerned with interaction between machines and humans. So it is used for speech recognition, reading text, voicemail, virtual assistants like Alexa or Siri. And these are also the examples of NLP. So for Python, the deep learning libraries are MXNetR, DeepNet, DeepR, H2O. So talking about MXNetR, it is used for feed-forward neural network, convolution neural network, whereas H2O can also be used for the same, but H2O is for deep autoencoders. So when we move on to deep learning, there are more sophisticated terms and technologies that needs to be learned, and to improve the model performance, one needs to understand the working of algorithm, the limitation of these algorithms, and how one can really improve upon the model by iterating over these models. So now moving on forward from machine learning, deep learning, and another tools and technique, and that is statistics. So this is yet another important tool. Now, how does a data scientist use statistics? So it has been used to identify the right questions. So data scientists also use statistics to apply it to the data and ask the right questions. And once they know what the question is, they can use statistics to find answers. So statistics also help them to understand how reliable their results are and how likely is it that the findings can be changed. Now, moving on further, the statistics help data scientists to do predictive modeling. This means that using the past data to create models, and that can be used for predicting the future events. That is predictive modeling. Now, another importance of statistics is that it will help a data scientist to design and interpret experiments to make informed decisions. So now let us understand this with the help of an example. An observation was made that an advertisement X, suppose an advertisement X has a 7% higher click-through rate than an advertisement B. So a data scientist would determine whether or not this difference is significant enough to warrant any increased attention, focus, and investment. Now, this statistics would help us to experiment and design the frequency, statistics, or hypothesis testing and confidence intervals. So data scientists would work with these tools like frequency statistics and hypothesis testing to understand whether this is really important or not, whether advertisement X requires more attention or advertisement B requires more attention, focus, and investment or not. So statistics helps to determine these important and crucial decisions. All right, so now another use of statistics is to estimate intelligently. So data scientists estimate intelligently. That means by using Bayesian theorem. There are various theorems which help to estimate intelligently, because a Bayesian theorem takes the result from the past experiences and observations and then make predictions. So this is estimating intelligently. And they can also summarize what estimates are and mean with the help of Bayesian theorem. So now statistics equip a data scientist to solve problems and make data-driven decisions. And now moving on forward to most common statistical methods, and this is descriptive statistics. So we talked about descriptive statistics. Now let us understand what is descriptive statistics. So descriptive means it is a summary statistics that quantitatively summarizes features. And some measures include, these are the central tendency measures which are being listed on the right-hand side, like mean, median, and mode. And on the left-hand side, it is skewness and variability, which are measures of standard deviations. And variance is nothing but knowledge of like how much is the spread of the data, right? Skewness is where the data is inclined, whether it is right towards the right or left. And determining the normal distribution of the data, we understand that are there any outliers in the data? How the data really is spread. So these descriptive statistics, they help us through the numbers that they give, we understand what the data is. Now moving on further to understanding what is inferential statistics. So a data scientist must also be able to use inferential statistics, because here inferential means we are taking a small sample from the entire data and we are making generalization about the entire data. So this is inferential statistics, inferencing something from a small data, assuming that this will also apply to a large data. Okay, so we make inferences from a sample about the population. Now, the methods for this includes hypothesis testing, probability. Now, probability is used to predict the likelihood of an event. Regression analysis is yet another method. So regression, what we do is we model the relationship between variables, right? ANOVA is yet another, which is analysis of variance. This is a test to compare the means of different groups and how different they are. And based on the results, we take decisions. Another method is chi-square, and this chi-square is used to determine any relationship between variables or compare the result between an expected and an observed values. So this is inferential statistics, and now we will move on to another technique, and that is from statistics to databases. So let's understand what are databases. So now data has to be stored before analyzing or making predictions, and to store the data we have databases. Thus the knowledge of database again becomes important for a data scientist. So every time a data scientist would have to retrieve a data he has to look upon a person who could help him retrieve the data. So it is better that a data scientist should be equipped and should possess this knowledge, so that whenever the need arises to access the data or store the data scientist can do it by himself, right? So that is why database knowledge is required. So now coming to the types of databases, that is relational database first we'll be talking about. So as it is said, relational, that means the data has some relation between itself or between each other. So the data is related and it is stored in a tabular format in some predefined schema in the databases. So what happens is that when it is in a tabular format, when it is in a clean format, the retrieval becomes quite easy. It's smooth. It is not complicated. And this data is related somehow. So the example I can say of relational databases are MySQL, Microsoft SQL Server, or Oracle databases. And now another type of a database is non-relational database. Now, non-relational, that means it is not having any relation. And this database it does not follow any preset schema, and also it is not in a tabular format. This is not important. And we can store any kind of a complex data, whatever complex data we have, unstructured data we have, that goes into non-relational database. And few examples of non-relational database are, as we can see here, MongoDB, Apache, Giraffe. Now, let me tell you something about Apache Giraffe. It is optimized for storing relationship between nodes. So why is it important? Because this shows connection between entities in social graph. And this software really makes social network data more informative, and it provides real-time graph processing. So when you are analyzing huge volume of data from social network sites, these non-relational database really help you to understand, analyze, store the data, and find some relation between them. So that is why it is really important to have the knowledge of these databases, NoSQL databases. And MongoDB is optimized to store the documents, right? So there are various non-relational databases. I've just listed a few here. Now let's move on from database to another technology, and that is big data. Now, to understand or the ability to analyze the unstructured data, this is relevant in the context of big data. So big data, we are moving forward. And big data, what happens here is that we are dealing with large and more complex data set day by day. And companies are dealing with huge volumes of data, especially from new data sources. So these data sets, they're so voluminous that traditional data processing softwares cannot manage them. That's why the big data technology is really helpful. And big data, it is a collection of data from diverse data sources. And it has certain characteristics like volume, variety, velocity, and veracity. So these are certain characteristics of big data. Now moving on forward to big data technologies. Now why they are needed? Because to manage big data, we have to use big data technologies, and they are classified into data mining, data analysis, data visualization, and data storage. So these are the big data technologies. So all these big data technologies are not required by a data scientist. We will particularly deal with data storage, which is required and which is really important to know by a data scientist. So for data storage, we have Hadoop. So we will cover first Hadoop. What is this Hadoop? So Hadoop framework is there to store and process the data in a distributed environment. So which means that it can store and analyze the data which is present in different machines. And it also comes with very high speed and very low cost. So the companies like Microsoft or Intel, IBM, they use Hadoop to store and process data. So when you're working with huge volumes of data, you need to even store and analyze it also at very quick speed and at low cost. So Hadoop gives you that flexibility and power and those features which you really need. So now coming on forward to another big data storage is MongoDB. Now this is again a NoSQL database, and it offers what a direct alternative to rigid schema, which is used in relational databases. But MongoDB, another flexibility is that while handling a wide variety of data types at large volumes, you can use MongoDB, and it also can be used for distributed architectures. So again, MongoDB can be used, and companies like MySQL, SQL Server, they use MongoDB to handle data. Another big data storage is Apache Spark. Now, Apache Spark is again used for large-scale data processing. Now, both, I would say that the Apache Spark and Apache Hadoop, they are both open source frameworks for big data processing. There are some key differences, like Hadoop uses MapReduce to process data, while Spark uses resilient distributed data sets, RDDs. So now moving on further for other technologies which are recommended for a data scientist is Excel. Now Excel is used since decades for analysis, but now more advanced languages and more simple languages are there out, like Python and R. But Excel is here to stay. So using Excel for basic analysis like formulas, pivot tables, VLOOKUPs, or VBAs, this can be used by data scientists. So VBA is nothing but Visual Basic for application, and this can help automate repetitive word and data processing functions, and it could also help you to generate custom graphs, forms, and reports. So Excel is really a very powerful tool, which is yet even today which is being used. So now we are moving on forward to web scraping. So scraping libraries like Beautiful Soup in Python, it is also known as BS4, or Scrapy. These are popular libraries in Python, but if one is using R, then RWest package is useful in extracting information from the web. So web scraping is not there in most of the job responsibilities of a data scientist, but if one is equipped with this and have a knowledge of how to use various APIs and get the data from that, various resources over internet, then this could be a real help. Now moving on forward to Linux. Now why is Linux required? Because the company operate on various operating systems, not necessarily Windows. So Linux is the most recommended language, I would say, or the commands need to be learned for Linux for a data scientist, because anyways, when you're joining a company, you have to learn those commands. So basic knowledge, not much, just basic concepts to how to operate Linux, the commands. And this would be really helpful, as Linux is considered more secure as compared to other OS, and companies really want that their data should be secured, their information should be secured. So a different operating system is used. So that is the entire idea about learning Linux. But this is not essential, but this is an option. Now moving on forward to another technology, that is Git. Now Git is for code management or your source code management when you're working in teams and you're sharing the code. So various versions or various changes could be made in that code by various people. So Git provides one source wherein all the changes could be merged into just one source, and one gets an edited version. So this is very, very handy, and it saves a lot of time. And making collaboration is very easy here. You can also allow multiple changes to be merged into a single source, and it is basically a version control system. Very useful Git. So Git commands and Git knowledge, not commands, but at least you know how to really work with Git for code management. Now moving on further to another, this is again an option, that is cloud technology. But few companies really now are looking for data scientists who also know the knowledge of cloud technology. And now cloud technology like Azure or AWS, so that you can gain access over or to the storage of software or servers over the internet. So how do you really access that? How do you retrieve information from cloud? By using AWS or Azure or different technologies that the company is using. So the benefit of why company are resorting to cloud is that it provides unlimited storage space and very high speed. The backup rate is good, and it restores the data. It is also cost effective, and it saves much of the infrastructure cost of the companies too. So that's why companies are really moving forward to cloud, and they need people who can really access cloud along with deploying machine learning models. So this is preferred. Sometimes it becomes important too. Okay, now so moving on further to how to structure the learning process. Now the above list of subjects could be really overwhelming and can really, demotivate a serious learner in the long run. So how one should structure the learning process to scale up the ladder of a data scientist. Now all these topics need not be learned at one go, but parallel learning is recommended here. By parallel learning, I mean that learning Python first and then moving on to data analysis visualization with the help of various projects, building machine learning models with the help of one programming language. That will give the idea of how really algorithms work on data, understanding the answers or the outputs from the data, and then tweaking in with certain hyperparameters and improving those results. Once you are done with machine learning, move on to deep learning. and apply those statistical analysis, the inferential statistics and descriptive statistics, because we find the description, the statistical part from the data, and understand how does it work by various plots also. So statistics really is helpful in understanding the results. So these learnings are being used in unison, not individually. So the knowledge of all these things are really required.
So, say you're on the verge of exploring a huge and unknown digital world, where every action click, swipe, click leaves a trace. This large, complex, and incredibly promising universe is a world of data. A data science roadmap is a complete guide that is necessary for navigating this environment, much more than the outline. Why we need data science? Here are a few reasons. An average entry-level data scientist earn 8 lakhs and a good ones earn more than 25 lakhs. The number of job openings for data scientists is enormous and is increasing by 30% every year. Around 1 crore 11 lakh data scientist jobs are expected to be created by the year of 2026. Multiple job opportunities. Data science expert can work in diverse roles and domains. Moving on to why we need data scientists. Data scientists have become increasingly vital in the modern businesses and organization for several reasons. Making informed decisions. Data scientists transfer complex data into actionable insights, enabling leaders to make evidence-based decisions. By mining, cleaning, and analyzing data, they provide a solid foundation for strategy development, operational improvements, and policy formulation. Driving innovation. Through predictive analytics and machine learning, data scientists can anticipate market trends, uncover new opportunities, and drive innovation. They play a crucial role in developing new products, services, and technologies based on data-driven insights. Moving on to improving customer experiences. Data scientists analyze customer behavior, preference, and feedback to help businesses tailor their products and services. This leads to enhanced customer experiences, high satisfaction rate, and improved loyalty. Finally, risk management. There are instruments in identifying and mitigating risk. They can analyze historical data, they can predict potential issues, and propose strategy to avoid or minimize these impacts. This is particularly crucial in the industries like finance, healthcare, and cybersecurity. Moving on to key tools for data science. Programming languages, machine learning libraries, data visualization tool, data management systems, cloud computing platforms. Now, we will go through the programming language in data science. Python is a universal language of data science. Due to its simplicity, readability, and the extensive support of libraries from data analysis and machine learning. R is another cornerstone language for statistical analysis and visualization. It's particularly favored in academia and research. SQL is essential for querying databases. A data scientist needs to retrieve and manipulate data stored in a relational databases efficiently. Moving on to machine learning in data science. TensorFlow is particularly powerful for large-scale machine learning projects. Its ability to handle deep learning tasks and its scalability across devices from server to edge computing makes it a go-to library for industries and academic research. Keras. Keras is known for its user-friendliness, modularity, and ease of extension. It's suitable for beginners due to its simple API, and it allows for quick prototyping of deep learning modules. Finally, scikit-learn. Scikit-learn is widely used for traditional machine learning algorithm. Its extensive documentation and ease of use makes it an excellent library for beginners and a standard tool for machine learning practitioners. Moving on to the mathematics in data science. Understanding basic statistical measures, mean, median, mode, variance, and standard deviation, and concepts, probability distribution, statistical significances, hypothesis testing is crucial. These concepts are the key to data exploration, summarization, and the interpretation of data analysis results. Linear algebra is the language of data as it provides the framework for dealing with data sets in the form of vectors and matrices. Operations such as matrix multiplication underpins many machine learning algorithms, including those used in deep learning. Now, we will move to the why choose a career in data science. High demand. The demand of data scientists is skyrocketing across various industries. Companies are constantly seeking professionals who can help them in the harness the power of data to make informed decisions. Moving on, diverse application. Data science is not limited to a specific industry. It finds application in healthcare, finance, marketing, e-commerce, agriculture, and many more. This diversity allows professionals to work in the areas that they are passionate about. Lucrative salary. Data scientists are among the highest paid professionals. The skills and the expertise they bring to the table are highly valued, leading them to the high salary package. Constant learning. Data science is an ever evolving field. Professionals have an opportunity to engage in continuous learning and stay at the front for technology and methodology. Next, we will move on to data science career scope. Data analysis. Data scientists analyze data to identify patterns and trends. This analysis is crucial for making data-driven decisions. Next is the data visualization. Data scientists use tools like Tableau and Power BI to create meaningful visualization that conveys insights to non-technical stakeholders. Machine learning. Machine learning is a subset of data science that involves creating algorithms and modules to make predictions and automate process. Next is the data engineering. Data engineers are responsible for collecting, storing, and processing data. They build the infrastructure that data scientists rely on. Domain expertise. Having knowledge in a specific domain, such as healthcare and finance, can make a data scientist highly valuable in that field. Finally, big data. With the rise of big data, professionals who can work with massive data sets are high in demand. Hadoop, Spark, and NoSQL databases are the key skills in these areas. As we reach the end of our journey on data science roadmap, it is clear that the path of becoming a data scientist is as exhilarating as it is challenging. We will navigate through the reasons why data science is so pivotal in our modern world, understanding its essence and appreciating the crucial need for data scientists across industries.
Let's look at data scientist job trends. This is a graph of number of job openings for data scientists per 1 million postings. What we can infer from the graph is that data scientist jobs have a growing trend, and this trend is expected to continue in the coming years. Apart from this, statistics also say that 97% of data scientist jobs are on full-time basis, whereas only 3% are part-time. Also, one of the important things to get a job is mastering the required skills. The most in-demand skills that every company looks for in a data scientist are listed here, along with the corresponding percentage of job openings. This doesn't necessarily mean you need to master all these skills in order to find a job as a data scientist. In fact, mastering just 3 core skills, which are Python, R, and SQL, can provide a solid foundation for 7 out of 10 job openings today as data scientists. Now let's look at the average data scientist salary based on different criteria. First, let's look at the salary based on degree. As we can see, both in India and the United States, there is a clear correlation between degree level and the associated salary. Higher the degree, better the salary. Hence, PhD holders earn the highest as a data scientist compared to others. The next criteria is experience. Your experience plays a crucial role in deciding your salary. Be it India or the United States, typically more experience in the relevant field results in higher pay, but definitely up to a certain point. In case of stagnant salary, even with a great experience, Consider learning new skills to outstand in the job market. The next criteria we are going to discuss is location. Not surprisingly, geographic location is one of the biggest factors when it comes to how much you can earn in a given profession. As a rule of thumb, salaries are going to be higher in larger cities such as Mumbai in India or New York in the United States than they are in rural locations. However, it's important to remember that cost of living in rural areas is much less than in big cities. Considering these factors, we have found out cities like Bangalore in India and San Francisco in the United States still top the list of providing a high salary. The last criteria we are going to look at includes companies. There are a large number of companies that are now looking for data scientists. But it's essential to find companies that commonly hire data scientists and also provide a good pay. Hence, we have made a list of companies that are ranked similar in India and the United States for data scientist salary. The companies include Oracle, JP Morgan, Intel, Amazon, IBM, and Accenture. Similarly, you can see the salary in each company for a data scientist in the United States. Now, let's quickly discuss the future scope for data scientists. Data scientists are high in demand in industries like healthcare, transport, e-commerce, cybersecurity, along with aviation and airlines. The healthcare industry is extensively making use of data scientists to develop a system that can predict health risks. They are also being hired for the process of drug discovery to provide insights into optimizing and increasing the success rate of predictions. The travel and transport industry always had to handle large amount of data. Conventional ways of handling data is no more enough. Hence, using data scientists, efficient data analysis and prediction can be done to improve business process and customer service. In the e-commerce industry, to improve user experience and personalize service and suggestion, they use customer data. For handling this user data, companies need data science professionals to understand customer behavior and then market them the correct product. The next industry is cybersecurity. Due to an increase in online transactions and internet usage, fraudulent activities have also increased. Organizations are now adopting data scientists to apply techniques to detect such fraudulent activities and to prevent losses. The last industry that we are going to discuss is aviation and airlines. In the aviation and airlines industry, companies use data for putting up their prices, optimizing routes, and carrying out preemptive maintenance. To develop each of this system requires knowledge in the field of data science. This leads to substantial increase in the need of data scientists.
Now let's move ahead and look at the data life cycle. So guys, there are basically 6 steps in the data life cycle. It starts with a business requirement. Next is the data acquisition. After that, you'll process the data, which is called data processing. Then there is data exploration, modeling, and finally deployment. So guys, before you even start on a data science project, it is important that you understand the problem you're trying to solve. So in this stage, you're just going to focus on identifying the central objectives of the project, and you'll do this by identifying the variables that need to be predicted. Next up, we have data acquisition. Okay, so now that you have your objectives defined, it's time for you to start gathering the data. So data mining is the process of gathering your data from different sources. At this stage, some of the questions you can ask yourself is, what data do I need for my project? Where does it live? How can I obtain it? And what is the most efficient way to store and access all of it? Next up, there is data processing. Now, usually all the data that you collected is a huge mess. Okay, it's not formatted, it's not structured, it's not cleaned. So if you find any data set that is cleaned and it's packaged well for you, then you've actually won the lottery, because finding the right data takes a lot of time and it takes a lot of effort. And one of the major time-consuming tasks in the data science process is data cleaning. Okay, this requires a lot of time, it requires a lot of effort, because you have to go through the entire data set to find out any missing values, or if there are any inconsistent values or corrupted data, and you also find the unnecessary data over here and you remove that data. So this was all about data processing. Next, we have data exploration. So now that you have sparkling clean set of data, you are finally ready to get started with your analysis. Okay, the data exploration stage is basically the brainstorming of data analysis. So in order to understand the patterns in your data, you can use histograms. You can just pull up a random subset of data and plot a histogram. You can even create interactive visualizations. This is the point where you dive deep into the data and you try to explore the different models that can be applied to your data. Next up, we have data modeling. So after processing the data, what you're going to do is you're going to carry out model training. Okay, now model training is basically about finding the model that answers the questions more accurately. So the process of model training involves a lot of steps. So firstly, you'll start by splitting the input data into the training data set and the testing data set. Okay, you're going to take the entire data set and you're going to separate it into two parts. One is the training and one is the testing data. After that, you'll build the model by using the training data set. And once you're done with that, you'll evaluate the training and the test data set. Now, to evaluate the training and testing data set, you'll be using series of machine learning algorithms. After that, you'll find out the model which is the most suitable for your business requirement. So this was mainly data modeling. Okay, this is where you build a model out of your training data set, and then you evaluate this model by using the testing data set. Next, we have deployment. So guys, the goal of this stage is to deploy the model into a production or maybe a production-like environment. So this is basically done for final user acceptance, and the users have to validate the performance of the models, and if there are any issues with the model or any issues with the algorithm, then they have to be fixed in this stage.
Let's move ahead and take a look at what is data. Now, this is a quite simple question. If I ask any of you what is data, you'll say that it's a set of numbers or some sort of documents that I've stored in my computer. Now, data is actually everything, all right? Look around you. There is data everywhere. Each click on your phone generates more data than you know. Now, this generated data provides insights for analysis and helps us make better business decisions. This is why data is so important. To give you a formal definition, data refers to facts and statistics collected together for reference or analysis. All right, this is the definition of data in terms of statistics and probability. So as we know, data can be collected, it can be measured and analyzed, it can be visualized by using statistical models and graphs. Now, data is divided into two major subcategories. All right. So first we have qualitative data and quantitative data. These are the two different types of data. Under qualitative data, we have nominal and ordinal data, and under quantitative data, we have discrete and continuous data. Now let's focus on qualitative data. Now this type of data deals with characteristics and descriptors that can't be easily measured but can be observed subjectively. Now, qualitative data is further divided into nominal and ordinal data. So, nominal data is any sort of data that doesn't have any order or ranking. Okay. An example of nominal data is gender. Now, there is no ranking in gender. There's only male, female, or other, right? There is no 1, 2, 3, 4, or any sort of ordering in gender. Race is another example of nominal data. Now, ordinal data is basically an ordered series of information. Okay, let's say that you went to a restaurant. Okay, your information is stored in the form of customer ID. All right, so basically you are represented with a customer ID. Now, you would have rated their service as either good or average. All right, that's how ordinal data is. And similarly, they'll have a record of other customers who visit the restaurant along with their ratings. All right. So any data which has some sort of sequence or some sort of order to it is known as ordinal data. All right. So guys, this is pretty simple to understand. Now let's move on and look at quantitative data. So quantitative data basically deals with numbers and things. Okay. You can understand that by the word quantitative itself. Quantitative is basically quantity, right? So it deals with numbers. It deals with anything that you can measure objectively. All right. So there are two types of quantitative data. There is discrete and continuous data. Now, discrete data is also known as categorical data, and it can hold a finite number of possible values. Now, the number of students in a class is a finite number. All right, you can't have infinite number of students in a class. Let's say in your 5th grade, there were 100 students in your class. All right, there weren't infinite number, but there was a definite finite number of students in your class. Okay, that's discrete data. Next, we have continuous data. Now, this type of data can hold infinite number of possible values. Okay, so when you say weight of a person is an example of continuous data, what I mean to say is my weight can be 50 kgs, or it can be 50.1 kgs, or it can be 50.001 kgs, or 50.0001, or it's 50.023, and so on, right? There are infinite number of possible values, right? So this is what I mean by continuous data. All right, this is the difference between discrete and continuous data. And also I'd like to mention a few other things over here. Now, there are a couple of types of variables as well. All right, we have a discrete variable and we have a continuous variable. Discrete variable is also known as a categorical variable. All right, it can hold values of different categories. Let's say that you have a variable called message, and there are two types of values that this variable can hold. Let's say that your message can either be a spam message or a non-spam message. Okay, that's when you call a variable as discrete or categorical variable. All right, because it can hold values that represent different categories of data. Now, continuous variables are basically variables that can store infinite number of values. So the weight of a person can be denoted as a continuous variable. All right, let's say there is a variable called weight, and it can store infinite number of possible values. That's why we'll call it a continuous variable. So guys, basically variable is anything that can store a value, right? So if you associate any sort of data with a variable, then it will become either discrete variable or continuous variable. There is also dependent and independent type of variables. Now, we won't discuss all of that in depth because that's pretty understandable. I'm sure all of you know what is independent variable and dependent variable, right? Dependent variable is any variable whose value depends on any other independent variable. So guys, that much knowledge I expect all of you to have. All right. So now let's move on and look at our next topic, which is what is statistics. Now, coming to the formal definition of statistics, statistics is an area of applied mathematics which is concerned with data collection, analysis, interpretation, and presentation. Now, usually when I speak about statistics, people think statistics is all about analysis. But statistics has other parts to it. It has data collection is also a part of statistics. Data interpretation, presentation, visualization, all of this comes into statistics. All right, you're going to use statistical methods to visualize data, to collect data, to interpret data. All right. So the area of mathematics deals with understanding how data can be used to solve complex problems. Okay. Now I'll give you a couple of examples that can be solved by using statistics. Okay, let's say that your company has created a new drug that may cure cancer. How would you conduct a test to confirm the drug's effectiveness? Now, even though this sounds like a biology problem, this can be solved with statistics. All right, you will have to create a test which can confirm the effectiveness of the drug. All right, this is a common problem that can be solved using statistics. Let me give you another example. You and a friend are at a baseball game, and out of the blue, he offers you a bet that neither team will hit a home run in that game. Should you take the bet? All right, here you'll just discuss the probability of whether you'll win or lose. All right, this is another problem that comes under statistics. Let's look at another example. The latest sales data has just come in, and your boss wants you to prepare a report for management on places where the company could improve its business. What should you look for and what should you not look for? Now, this problem involves a lot of data analysis. You'll have to look at the different variables that are causing your business to go down, or that you have to look at a few variables that are increasing the performance of your models and thus growing your business. All right. So this involves a lot of data analysis, and the basic idea behind data analysis is to use statistical techniques in order to figure out the relationship between different variables or different components in your business. Okay. So now let's move on and look at our next topic, which is basic terminologies in statistics. Now, before you dive deep into statistics, it is important that you understand the basic terminologies used in statistics. The two most important terminologies in statistics are population and sample. So, throughout the statistics course or throughout any problem that you're trying to solve with statistics, you will come across these two words, which is population and sample. Now, population is a collection or a set of individuals or objects or events whose properties are to be analyzed. Okay, so basically, you can refer to population as a subject that you're trying to analyze. Now, a sample is just like the word suggests, it's a subset of the population. So, you have to make sure that you choose the sample in such a way that it represents the entire population. All right, it shouldn't focus at one part of the population. Instead, it should represent the entire population. That's how your sample should be chosen. So, a well chosen sample will contain most of the information about a particular population parameter. Now, you must be wondering, how can one choose a sample that best represents the entire population? Now, sampling is a statistical method that deals with the selection of individual observations within a population. So, sampling is performed in order to infer statistical knowledge about a population. All right, if you want to understand the different statistics of a population, like the mean, the median, the mode, or the standard deviation, or the variance of a population, then you're going to perform sampling. All right, because it's not reasonable for you to study a large population and find out the mean, median, and everything else. So why is sampling performed? You might ask, what is the point of sampling? We can just study the entire population. Now, guys, think of a scenario wherein you're asked to perform a survey about the eating habits of teenagers in the US. So at present, there are over 42 million teens in the US, and this number is growing as we are speaking right now, correct? Is it possible to survey each of these 42 million individuals about their health? Is it possible? Well, it might be possible, but this will take forever to do. Now, obviously, it's not. It's not reasonable to go around knocking each door and asking for what does your teenage son eat and all of that. All right, this is not very reasonable. That's why sampling is used. It's a method wherein a sample of the population is studied in order to draw inference about the entire population. So it's basically a shortcut to studying the entire population. Instead of taking the entire population and finding out all the solutions, you're just going to take a part of the population that represents the entire population, and you're going to perform all your statistical analysis, your inferential statistics on that small sample. All right. And that sample basically represents the entire population. All right. So I'm sure I've made this clear to you all, what is sample and what is population. Now, there are two main types of sampling techniques that I'll discuss today. We have probability sampling and non-probability sampling. Now, in this video, we'll only be focusing on probability sampling techniques because non-probability sampling is not within the scope of this video. All right, we'll only discuss the probability part because we're focusing on statistics and probability, correct? Now again, under probability sampling, we have three different types. We have random sampling, systematic, and stratified sampling. All right. And just to mention the different types of non-probability samplings, we have snowball, quota, judgment, and convenience sampling. All right. Now guys, in this session, I'll only be focusing on probability. So let's move on and look at the different types of probability sampling. So what is probability sampling? It is a sampling technique in which samples from a large population are chosen by using the theory of probability. All right. So there are three types of probability sampling. All right. First, we have the random sampling. Now, in this method, each member of the population has an equal chance of being selected in the sample. All right, so each and every individual or each and every object in the population has an equal chance of being a part of the sample. That's what random sampling is all about. Okay, you are randomly going to select any individual or any object. So this way, each individual has an equal chance of being selected. Correct? Next, we have systematic sampling. Now, in systematic sampling, every nth record is chosen from the population to be a part of the sample. All right. Now, refer this image that I've shown over here. Out of these 6 groups, every second group is chosen as a sample. Okay, so every second record is chosen here. And this is how systematic sampling works. Okay, you're randomly selecting the nth record and you're going to add that to your sample. Next, we have stratified sampling. Now, in this type of technique, a stratum is used to form samples from a large population. So what is a stratum? A stratum is basically a subset of the population that shares at least one common characteristics. So let's say that your population has a mix of both male and female. So you can create 2 stratums out of this. One will have only the male subset and the other will have the female subset. Alright, this is what stratum is. It is basically a subset of the population that shares at least one common characteristics. Alright, in our example, it is gender. So after you've created a stratum, you're going to use random sampling on these stratums and you're going to choose a final sample. So random sampling meaning that all of the individuals in each of the stratum will have an equal chance of being selected in the sample, correct? So guys, these were the 3 different types of sampling techniques. Now let's move on and look at our next topic, which is the different types of statistics. So after this, we'll be looking at the more advanced concepts of statistics. Alright, so far we discussed the basics of statistics, which is basically what is statistics, the different sampling techniques and the terminologies in statistics. Alright, now we look at the different types of statistics. So there are 2 major types of statistics, descriptive statistics and inferential statistics. In today's session, we'll be discussing both of these types of statistics in depth. Alright, we'll also be looking at a demo which I'll be running in the R language in order to make you understand what exactly descriptive and inferential statistics is. So guys, we're just going to look at the basics, so don't worry if you don't have much knowledge. I'm explaining everything from the basic level. Alright. So guys, descriptive statistics is a method which is used to describe and understand the features of specific data set by giving a short summary of the data. Okay, so it is mainly focused upon the characteristics of data. It also provides a graphical summary of the data. Now, in order to make you understand what descriptive statistics is, let's suppose that you want to gift all your classmates a t-shirt. So to study the average shirt size of a student in a classroom, so if you were to use descriptive statistics to study the average shirt size of students in your classroom, then what you would do is you would record the shirt size of all students in the class and then you would find out the maximum, minimum and average shirt size of the class. Okay, so coming to inferential statistics makes inferences and predictions about a population based on the sample of data taken from the population. Okay, so in simple words, it generalizes a large data set and it applies probability to draw a conclusion. Okay, so it allows you to infer data parameters based on a statistical model by using sample data. So if we consider the same example of finding the average shirt size of students in a class, in inferential statistics, you will take a sample set of the class, which is basically a few people from the entire class. Alright, you already have had grouped the class into large, medium and small. Alright, in this method, you basically build a statistical model and expand it for the entire population in the class. So guys, that was a brief understanding of descriptive and inferential statistics. So that's the difference between descriptive and inferential. Now in the next section, we'll go in depth about descriptive statistics. Alright, so let's discuss more about descriptive statistics. So like I mentioned earlier, descriptive statistics is a method that is used to describe and understand the features of a specific data set by giving short summaries about the sample and measures of the data. There are 2 important measures in descriptive statistics. We have measure of central tendency, which is also known as measure of center, and we have measures of variability. This is also known as measures of spread. So measures of center include mean, median, and mode. Now, what is measures of center? Measures of the center are statistical measures that represent the summary of a data set. Okay, the 3 main measures of center are mean, median, and mode. coming to measures of variability or measures of spread, we have range, interquartile range, variance, and standard deviation. All right. So now let's discuss each of these measures in a little more depth, starting with the measures of center. Now, I'm sure all of you know what the mean is. Mean is basically the measure of the average of all the values in a sample. Okay, so it's basically the average of all the values in a sample. How do you measure the mean? I hope all of you know how the mean is measured. If there are 10 numbers and you want to find the mean of these 10 numbers, all you have to do is you have to add up all the 10 numbers and you have to divide it by 10. 10 here represents the number of samples in your data set. All right, since we have 10 numbers, we're going to divide this by 10. All right, this will give us the average or the mean. So to better understand the measures of central tendency, let's look at an example. Now the data set over here is basically the cars data set, and it contains a few variables. All right, it has something known as cars, it has mileage per gallon, cylinder type, displacement, horsepower, and real axle ratio. All right, all of these measures are related to cars. Okay, so what you're going to do is you're going to use descriptive analysis and you're going to analyze each of the variables in the sample data set for the mean, standard deviation, median, mode, and so on. So let's say that you want to find out the mean or the average horsepower of the cars among the population of cars. Like I mentioned earlier, what you'll do is you'll check the average of all the values. So in this case, we'll take the sum of the horsepower of each car and we'll divide that by the total number of cars. Okay, that's exactly what I've done here in the calculation part. So this 110 basically represents the horsepower for the first car. All right, similarly, I've just added up all the values of horsepower for each of the cars and I've divided it by 8. Now 8 is basically the number of cars in our data set. All right, so 103.625 is what our mean is, or the average of horsepower is. All right, now let's understand what median is with an example. Okay, so to define median, median is basically a measure of the central value of the sample set is called the median. All right, you can say that it is a middle value. So if we want to find out the center value of the mileage per gallon among the population of cars, first what we'll do is we'll arrange the MPG values in ascending or descending order and choose a middle value. All right, in this case, since we have 8 values, right, we have 8 values, which is an even entry. So whenever you have even number of data points or samples in your data set, then you're going to take the average of the two middle values. If we had 9 values over here, we can easily figure out the middle value and choose that as a median. But since there are even number of values, we're going to take the average of the two middle values. All right. So 22.8 and 23 are my two middle values, and I'm taking the mean of those two, and hence I get 22.9, which is my median. All right. Lastly, let's look at how mode is calculated. So what is mode? Now, the value that is most recurrent in the sample set is known as mode, or basically the value that occurs most often. Okay, that is known as mode. So let's say that we want to find out the most common type of cylinder among the population of cars. All we have to do is we will check the value which is repeated the most number of times. Here we can see that the cylinders come in two types. We have cylinder of type 4 and cylinder of type 6, right? So take a look at the data set. You can see that the most recurring value is 6, right? We have 1, 2, 3, 4, and 5. We have 5, 6, and we have 1, 2, 3. Yeah, we have 3, 4 type cylinders and 5, 6 type cylinders. So basically we have 3, 4 type cylinders and we have 5, 6 type cylinders. All right. So our mode is going to be 6, since 6 is more recurrent than 4. So guys, those were the measures of the center or the measures of central tendency. Now let's move on and look at the measures of the spread. All right. Now what is the measure of spread? A measure of spread, sometimes also called as measure of dispersion, is used to describe the variability in a sample or population. Okay, you can think of it as some sort of deviation in the sample. All right, so you measure this with the help of the different measure of spreads. We have range, interquartile range, variance, and standard deviation. Now, range is pretty self-explanatory, right? It is the given measure of how spread apart the values in a data set are. The range can be calculated as shown in this formula. So you're basically going to subtract the maximum value in your data set from the minimum value in your data set. That's how you calculate the range of the data. All right. Next, we have interquartile range. So before we discuss interquartile range, let's understand what a quartile is. Alright, so quartiles basically tell us about the spread of a data set by breaking the data set into different quartiles. Okay, just like how the median breaks the data into two parts, the quartile will break it into different quartiles. So to better understand how quartile and interquartile are calculated, let's look at a small example. Now, this data set basically represents the marks of 100 students ordered from the lowest to the highest scores. Alright, so the quartiles lie in the following ranges. Now, the first quartile, which is also known as Q1, it lies between the 25th and the 26th observation. Alright, so if you look at this, I've highlighted the 25th and the 26th observation. So how you can calculate Q1 or first quartile is by taking the average of these two values. Alright, since both the values are 45, when you add them up and divide them by 2, you'll still get 45. Now, the second quartile or Q2 is between the 50th and the 51st observation. So you're going to take the average of 58 and 59 and you'll get a value of 58.5. Now, this is my second quarter. The third quartile or Q3 is between the 75th and the 76th observation. Here again, you'll take the average of the two values, which is the 75th value and the 76th value. All right, and you'll get a value of 71. All right. So guys, this is exactly how you calculate the different quartiles. Now let's look at what is interquartile range. So IQR or the interquartile range is a measure of variability based on dividing a data set into quartiles. Now the interquartile range is calculated by subtracting the Q1 from Q3. So basically Q3 minus Q1 is your IQR. So your IQR is your Q3 minus Q1. Alright. Now this is how each of the quartiles are. Each quartile represents a quarter, which is 25%. Alright. So guys, I hope all of you are clear with interquartile range and what are quartiles. Now let's look at variance. Now variance is basically a measure that shows how much a random variable differs from its expected value. Okay, it's basically the variance in any variable. Now variance can be calculated by using this formula. Right here, X basically represents any data point in your data set. N is the total number of data points in your data set, and X bar is basically the mean of data points. Alright, this is how you calculate variance. Variance is basically computing the squares of deviations. Okay, that's why it says S squared there. Now let's look at what is deviation. Deviation is just the difference between each element from the mean. Okay, so it can be calculated by using this simple formula where xi basically represents a data point and mu is the mean of the population. Alright, this is exactly how you calculate deviation. Now, population variance and sample variance are very specific to whether you're calculating the variance in your population dataset or in your sample dataset. That's the only difference between population and sample variance. So the formula for population variance is pretty explanatory. So xi is basically each data point, mu is the mean of the population, n is the number of samples in your dataset. All right. Now let's look at sample variance. Now, sample variance is the average of square differences from the mean. Alright, here xi is any data point or any sample in your data set. X bar is the mean of your sample. Alright, it's not the mean of your population. It's the mean of your sample. And if you notice, n here is a smaller n, it's the number of data points in your sample. And this is basically the difference between sample and population variance. I hope that is clear. Coming to standard deviation, it is the measure of dispersion of a set of data from its mean. Alright, so it's basically the deviation from your mean. That's what standard deviation is. Now, to better understand how the measures of spread are calculated, let's look at a small use case. So let's say Daenerys has 20 dragons. They have the numbers 9, 2, 5, 4 and so on as shown on the screen. What you have to do is you have to work out the standard deviation. Alright, in order to calculate the standard deviation, you need to know the mean. right? So first you're going to find out the mean of your sample set. So how do you calculate the mean? You add all the numbers in your data set divided by the total number of samples in your data set. So you get a value of 7 here. Then you calculate the RHS of your standard deviation formula. All right, so from each data point, you're going to subtract the mean and you're going to square that. All right, so when you do that, you'll get the following result. You'll basically get this 425, 4, 9, 25, and so on. So finally, you'll just find the mean of these squared differences. All right, so your standard deviation will come up to 2.983 once you take the square root. So guys, this is pretty simple. It's a simple mathematic technique. All you have to do is you have to substitute the values in the formula. All right. I hope this was clear to all of you. Now let's move on and discuss the next topic, which is information gain and entropy. Now this is one of my favorite topics in statistics. It's very interesting. And this topic is mainly involved in machine learning algorithms like decision trees and random forest. All right. It's very important for you to know how information gain and entropy really work and why they're so essential in building machine learning models. We'll focus on the statistic parts of information gain and entropy. And after that, we'll discuss a use case and see how information gain and entropy is used in decision trees. So for those of you who don't know what a decision tree is, it is basically a machine learning algorithm. You don't have to know anything about this. I'll explain everything in depth, so don't worry. Now let's look at what exactly entropy and information gain is. Now guys, entropy is basically the measure of any sort of uncertainty that is present in the data. Alright, so it can be measured by using this formula. So here S is the set of all instances in the data set or all the data items in the data set. N is the different type of classes in your data set. Pi is the event probability. Now this might seem a little confusing to you all, but when we go through the use case, you'll understand all of these terms even better. Alright. Coming to information gain, as the word suggests, information gain indicates how much information a particular feature or a particular variable gives us about the final outcome. Okay, it can be measured by using this formula. So again, here h of S is the entropy of the whole data set S. Sj is the number of instances with the j value of an attribute A. S is the total number of instances in the data set. V is the set of distinct values of an attribute A. H of Sj is the entropy of subset of instances, and H of A, S is the entropy of an attribute A. Even though this seems confusing, I'll clear out the confusion. Alright, let's discuss a small problem statement where we'll understand how information gain and entropy is used to study the significance of a model. So like I said, information gain and entropy are very important statistical measures that let us understand the significance of a predictive model. Okay, to get a more clear understanding, let's look at a use case. Alright, now suppose we're given a problem statement. Alright, the statement is that you have to predict whether a match can be played or not by studying the weather conditions. So the predictor variables here are outlook, humidity, wind. Day is also a predictor variable. The target variable is basically play. Alright, the target variable is the variable that you're trying to predict. Okay. Now the value of the target variable will decide whether or not a game can be played. Alright, so that's why the play has two values. It has no and yes. No meaning that the weather conditions are not good and therefore you cannot play the game. Yes meaning that the weather conditions are good and suitable for you to play the game. Alright, so that was a problem statement. I hope the problem statement is clear to all of you. Now to solve such a problem, we make use of something known as decision trees. So guys, think of an inverted tree and each branch of the tree denotes some decision. Alright, each branch is known as the branch node, and at each branch node you're going to take a decision in such a manner that you'll get an outcome at the end of the branch. Alright, now this figure here basically shows that out of 14 observations, 9 observations result in a yes, meaning that out of 14 days the match can be played only on 9 days. Alright, so here if you see on day 1, day 2, day 8, day 9 and day 11, the outlook has been sunny. Alright, so basically we're trying to cluster our data set depending on the outlook. So when the outlook is sunny, this is our data set. When the outlook is overcast, this is what we have. And when the outlook is rain, this is what we have. All right. So when it is sunny, we have 2 yeses and 3 nos. Okay. When the outlook is overcast, we have all 4 as yeses, meaning that on the 4 days when the outlook was overcast, we can play the game. All right. Now, when it comes to rain, we have 3 yeses and 2 nos. All right. So if you notice here, the decision is being made by choosing the outlook variable as the root node. Okay, so the root node is basically the topmost node in a decision tree. Now, what we've done here is we've created a decision tree that starts with the outlook node. All right, then you're splitting the decision tree further depending on other parameters like sunny, overcast, and rain. All right, now, like we know that outlook has 3 values: sunny, overcast, and rain. So let me explain this in a more in-depth manner. Okay, so what you're doing here is you're making the decision tree by choosing the outlook variable at the root node. The root node is basically the topmost node in a decision tree. Now, the outlook node has 3 branches coming out from it, which is sunny, overcast, and rain. So basically, outlook can have 3 values. Either it can be sunny, it can be overcast, or it can be rainy. Okay, now these 3 values are assigned to the immediate branch nodes, and for each of these values, the possibility of play is equal to yes is calculated. So the sunny and the rain branches will give you an impure output, meaning that there is a mix of yes and no, right? There are 2 yeses here, 3 no's here. There are 3 yeses here and 2 no's over here. But when it comes to the overcast variable, it results in a 100% pure subset. All right. This shows that the overcast variable will result in a definite and certain output. This is exactly what entropy is used to measure. All right. It calculates the impurity or the uncertainty. All right. So the lesser the uncertainty or the entropy of a variable, more significant is that variable. So when it comes to overcast, there's literally no impurity in the data set. It is a 100% pure subset, right? So we want variables like these in order to build our model. All right. Now, we don't always get lucky and we don't always find variables that will result in pure subsets. That's why we have the measure entropy. So the lesser the entropy of a particular variable, the more significant that variable will be. So in a decision tree, the root node is assigned the best attribute so that the decision tree can predict the most precise outcome. Meaning that on the root node, you should have the most significant variable. All right, that's why we've chosen outlook. All right, now some of you might ask me, why haven't you chosen overcast? Now guys, overcast is not a variable. It is a value of the outlook variable. All right, that's why we've chosen outlook here, because it has a 100% pure subset, which is overcast. All right, now the question in your head is, how do I decide which variable or attribute best splits the data? Now, right now, I know I looked at the data and I told you that, here we have a 100% pure subset. But what if it's a more complex problem and you're not able to understand which variable will best split the data? So guys, when it comes to decision trees, information gain and entropy will help you understand which variable will best split the data set, all right, or which variable you have to assign to the root node. Because whichever variable is assigned to the root node, it will best split the data set, and it has to be the most significant variable. All right. So how we can do this is we need to use information gain and entropy. So from the total of the 14 instances that we saw, 9 of them said yes, and 5 of the instances said no, that you cannot play on that particular day. All right. So how do you calculate the entropy? So this is the formula. You just substitute the values in the formula. So when you substitute the values in the formula, you'll get a value of 0.940. All right. This is the entropy, or this is the uncertainty of the data present in our sample. Now, in order to ensure that we choose the best variable for the root node, let us look at all the possible combinations that you can use on the root node. Okay. So these are all the possible combinations. You can either have outlook, you can have windy, humidity, or temperature. Okay, these are our 4 variables, and you can have any one of these variables as your root node. But how do you select which variable best fits the root node? That's what we are going to see by using information gain and entropy. So guys, now the task at hand is to find the information gain for each of these attributes. All right, so for outlook, for windy, for humidity, and for temperature, we're going to find out the information gain. All right. Now, a point to remember is that the variable that results in the highest information gain must be chosen because it will give us the most precise and output information. All right. So the information gain for attribute windy, we'll calculate that first. Here we have 6 instances of true and 8 instances of false. Okay. So when you substitute all the values in the formula, you'll get a value of 0.048. So we get a value of 0.048. Now this is a very low value for information gain. All right, so the information that you're going to get from windy attribute is pretty low. So let's calculate the information gain of attribute outlook. All right, so from the total of 14 instances, we have 5 instances which say sunny, 4 instances which are overcast, and 5 instances which are rainy. All right, for sunny, we have 3 yeses and 2 nos. For overcast, we have all the 4 as yes. For rainy, we have 3 yes and 2 no's. Okay, so when you calculate the information gain of the outlook variable, you'll get a value of 0.247. Now compare this to the information gain of the windy attribute. This value is actually pretty good, right? We have 0.247, which is a pretty good value for information gain. Now let's look at the information gain of attribute humidity. Now over here we have 7 instances which say high and 7 instances which say normal, right? And under the high branch node, we have 3 instances which say yes and the rest 4 instances which say no. Similarly, under the normal branch, we have 1, 2, 3, 4, 5, 6, 7 instances which say yes and 1 instance which says no. All right. So when you calculate the information gain for the humidity variable, you're going to get a value of 0.151. Now this is also a pretty decent value, but when you compare it to the information gain of the attribute outlook, it is less, right? Now let's look at the information gain of attribute temperature. All right, so the temperature can hold, repeat. So basically the temperature attribute can hold hot, mild, and cool. Okay, under hot we have 2 instances which says yes and 2 instances for no. Under mild we have 4 instances of yes and 2 instances of no. And under cool, we have 3 instances of yes and 1 instance of no. Alright, now when you calculate the information gain for this attribute, you'll get a value of 0.029, which is again very less. So what you can summarize from here is, if we look at the information gain for each of these variables, we'll see that for outlook, we have the maximum gain. Alright, we have 0.247, which is the highest information gain value. And you must always choose a variable with the highest information gain to split the data at the root node. So that's why we assign the outlook variable at the root node. Alright, so guys, I hope this use case was clear. If any of you have doubts, please keep commenting those doubts. Now let's move on and look at what exactly a confusion matrix is. Now the confusion matrix is the last topic for descriptive statistics. Alright, after this, I'll be running a short demo where I'll be showing you how you can calculate mean, median, mode, and standard deviation, variance, and all of those values by using R. Okay, so let's talk about confusion matrix. Now guys, what is a confusion matrix? Now don't get confused, this is not any complex topic. Now a confusion matrix is a matrix that is often used to describe the performance of a model. Alright, and this is specifically used for classification models or a classifier. And what it does is it will calculate the accuracy or it will calculate the performance of your classifier by comparing your actual results and your predicted results. Alright, so this is what it looks like: true positive plus true negative and all of that. Now this is a little confusing. I'll get back to what exactly true positive, true negative, and all of this stands for. For now, let's look at an example and let's try and understand what exactly confusion matrix is. So guys, I made sure that I put examples after each and every topic because it's important you understand the practical part of statistics. Alright, statistics has literally nothing to do with theory. You need to understand how calculations are done in statistics. Okay, so here what I've done is, now let's look at a small use case. Okay, let's consider that you're given data about 165 patients, out of which 105 patients have a disease and the remaining 50 patients don't have a disease. Okay, so what you're going to do is you'll build a classifier that predicts by using these 165 observations. You'll feed all of these 165 observations to your classifier, and it will predict the output every time a new patient's detail is fed to the classifier, right? Now, out of these 165 cases, let's say that the classifier predicted yes 110 times and no 55 times. All right. So yes basically stands for yes, the person has a disease, and no stands for no, the person does not have a disease. All right. That's pretty self-explanatory. But yeah, so it predicted that 110 times the patient has a disease and 55 times that no, the patient doesn't have a disease. However, in reality, only 105 patients in the sample have the disease and 60 patients do not have the disease, right? So how do you calculate the accuracy of your model? You basically build the confusion matrix, all right? This is how the matrix looks like. N basically denotes the total number of observations that you have, which is 165 in our case. Actual denotes the actual values in the data set, and predicted denotes the predicted values by the classifier. So the actual value is no here and the predicted value is no here. So your classifier was correctly able to classify 50 cases as no. All right. Since both of these are no, so 50 it was correctly able to classify. But 10 of these cases it incorrectly classified. Meaning that your actual value here is no, but your classifier predicted it as yes. All right. That's why there's 10 over here. Similarly, it wrongly predicted that 5 patients do not have diseases, whereas they actually did have diseases, and it correctly predicted 100 patients which have the disease. All right, I know this is a little bit confusing, but if you look at these values, no, no, 50, meaning that it correctly predicted 50 values. No, yes means that it wrongly predicted yes for the values that it was supposed to predict no. All right. Now, what exactly is this true positive, true negative, and all of that? I'll tell you what exactly it is. So, true positive are the cases in which we predicted a yes and they do not actually have the disease. All right. So, it is basically this value. All right. We predicted a yes here, even though they did not have the disease. So, we have 10 true positives, right? Similarly, true negative is we predicted no and they don't have the disease, meaning that this is correct. False positive is we predicted yes, but they do not actually have the disease. All right, this is also known as type 1 error. False negative is we predicted no, but they actually do not have the disease. So guys, basically false negative and true negatives are basically correct classifications. All right. So this was confusion matrix, and I hope this concept is clear. So guys, that was descriptive statistics. Now before we go to probability, I promised you all that we'll run a small demo in R. All right, we'll try and understand how mean, median, mode works in R. Okay, so let's do that first. So guys, again, what we just discussed so far was descriptive statistics. All right, next we're going to discuss probability, and then we'll move on to inferential statistics. Okay, inferential statistics is basically the second type of statistics. Okay, now to make things more clearer for you, let me just zoom in. So guys, it's always best to perform practical implementations in order to understand the concepts in a better way. Okay, so here we'll be executing a small demo that will show you how to calculate the mean, median, mode, variance, standard deviation, and how to study the variables by plotting a histogram. Okay, don't worry if you don't know what a histogram is. It's basically a frequency plot. There's no big science behind it. All right. This is a very simple demo, but it also forms the foundation that every machine learning algorithm is built upon. Okay, you can say that most of the machine learning algorithms, actually all the machine learning algorithms and deep learning algorithms have this basic concept behind them. Okay, you need to know how mean, median, mode, and all of that is calculated. So guys, I'm using the R language to perform this, and I'm running this on R Studio. For those of you who don't know R language, I will leave a couple of links in the description box. You can go through those videos. So what we're doing is we're randomly generating numbers and we're storing it in a variable called data. Right? So if you want to see the generated numbers, just run the line data. All right? This variable basically stores all our numbers. All right? Now what we're going to do is we're going to calculate the mean. Now all you have to do in R is specify the word mean along with the data that you're calculating the mean of. And I've assigned this whole thing into a variable called mean, which will hold the mean value of this data. So now let's look at the mean. For that, I've used a function called print and mean. Alright, so our mean is around 5.99. Okay, next is calculating the median. It's very simple, guys. All you have to do is use the function median, alright, and pass the data as a parameter to this function. That's all you have to do. So R provides functions for each and everything. Alright, statistics is very easy when it comes to R because R is basically a statistical language. Okay, so all you have to do is just name the function, and that function is already inbuilt in your R. Okay, so your median is around 6.4. Similarly, we'll calculate the mode. All right, let's run this function. I basically created a small function for calculating the mode. So guys, this is our mode, meaning that this is the most recurrent value, right? Now we're going to calculate the variance and the standard deviation. For that, again, we have a function in R called as var. All right, all you have to do is pass the data to that function. Okay, similarly, we'll calculate the standard deviation, which is basically the square root of your variance, right? Now we'll print the standard deviation, right? This is our standard deviation value. Now finally, we'll just plot a small histogram. Histogram is nothing but it's a frequency plot, all right? It'll show you how frequently a data point is occurring. So this is the histogram that we've just created. It's quite simple in R because R has a lot of packages and a lot of inbuilt functions that support statistics. All right, it is a statistical language that is mainly used by data scientists or by data analysts and machine learning engineers because they don't have to sit and code these functions. All they have to do is they have to mention the name of the function and pass the corresponding parameters. So guys, that was the entire descriptive statistics module. And now we'll discuss about probability. Okay, so before we understand what exactly probability is, let me clear out a very common misconception. People often tend to ask me this question: what is the relationship between statistics and probability? So probability and statistics are related fields, all right? So probability is a mathematical method used for statistical analysis. Therefore, we can say that probability and statistics are interconnected branches of mathematics that deal with analyzing the relative frequency of events. So they're very interconnected fields, and probability makes use of statistics and statistics makes use of probability. All right, they're very interconnected fields. So that is the relationship between statistics and probability. Now let's understand what exactly is probability. So probability is the measure of how likely an event will occur. To be more precise, it is the ratio of desired outcome to the total outcomes. Now the probability of all outcomes always sum up to 1. Now the probability will always sum up to 1. Probability cannot go beyond 1. Okay, so either your probability can be 0 or it can be 1, or it can be in the form of decimals like 0.52 or 0.55, or it can be in the form of 0.5, 0.7, 0.9, but its value will always stay between the range 0 and 1. Okay, now the famous example of probability is rolling a dice example. So when you roll a dice, you get 6 possible outcomes, right? You get 1, 2, 3, 4, and 5, 6 phases of a dice. Now each possibility only has one outcome. So what is the probability that on rolling a dice, you'll get 3? The probability is 1 by 6, right? Because there's only one phase which has the number 3 on it. Out of 6 phases, there's only one phase which has the number 3. So the probability of getting 3 when you roll a dice is 1 by 6. Similarly, if you want to find the probability of getting a number 5, again the probability is going to be 1 by 6. All right. So all of this will sum up to 1. All right. So guys, this is exactly what probability is. It's a very simple concept. We all learned it in 8th standard onwards, right? Now let's understand the different terminologies that are related to probability. Now there are 3 terminologies that you often come across when we talk about probability. We have something known as random experiment. Okay, it's basically an experiment or a process for which the outcomes cannot be predicted with certainty. All right, that's why you use probability. You're going to use probability in order to predict the outcome with some sort of certainty. Sample space is the entire possible set of outcomes of a random experiment. An event is one or more outcomes of an experiment. So if you consider the example of rolling a dice, now let's say that you want to find out the probability of getting a 2 when you roll a dice. Okay, so finding this probability is the random experiment. The sample space is basically your entire possibility. Okay, so 1, 2, 3, 4, 5, 6 phases are there, and out of that you need to find the probability of getting a 2, right? So all the possible outcomes will basically represent your sample space. Okay, so 1 to 6 are all your possible outcomes. This represents your sample space. Now, event is one or more outcome of an experiment. So in this case, my event is to get a 2 when I roll a dice, right? So my event is the probability of getting a 2 when I roll a dice. So guys, this is basically what random experiment, sample space, and event really means. All right. Now, let's discuss the different types of events. There are two types of events that you should know about. There is disjoint and non-disjoint events. Disjoint events are events that do not have any common outcome. For example, if you draw a single card from a deck of cards, it cannot be a king and a queen, correct? It can either be king or it can be queen. Now, non-disjoint events are events that have common outcomes. For example, a student can get 100 marks in statistics and 100 marks in probability. All right. And also the outcome of a ball delivered can be a no ball and it can be a 6. Right. So this is what non-disjoint events are. All right. These are very simple to understand. Right. Now let's move on and look at the different types of probability distribution. All right. I'll be discussing the three main probability distribution functions. I'll be talking about probability density function, normal distribution, and central limit theorem. Okay. Probability density function, also known as PDF, is concerned with the relative likelihood for a continuous random variable to take on a given value. All right. So the PDF gives the probability of a variable that lies between the range A and B. So basically what you're trying to do is you're going to try and find the probability of a continuous random variable over a specified range. Okay, now this graph denotes the PDF of a continuous variable. Now this graph is also known as the bell curve. All right, it's famously called the bell curve because of its shape. And there are three important properties that you need to know about a probability density function. Now the graph of a PDF will be continuous over a range. This is because you're finding the probability that a continuous variable lies between the ranges A and B, right? The second property is that the area bounded by the curve of a density function and the x-axis is equal to 1. Basically, the area below the curve is equal to 1, all right, because it denotes probability. Again, the probability cannot range more than 1. It has to be between 0 and 1. Property number 3 is that the probability that a random variable assumes a value between A and B is equal to the area under the PDF bounded by A and B. Okay, now what this means is that the probability value is denoted by the area of the graph. All right, so whatever value that you get here, which is basically 1, is the probability that a random variable will lie between the range A and B. All right, so I hope all of you have understood the probability density function. It's basically the probability of finding the value of a continuous random variable between the range A and B. All right. Now let's look at our next distribution, which is normal distribution. Now, normal distribution, which is also known as the Gaussian distribution, is a probability distribution that denotes the symmetric property of the mean, right? Meaning that the idea behind this function is that the data near the mean occurs more frequently than the data away from the mean. So what it means to say is that the data around the mean represents the entire data set. Okay, so if you just take a sample of data around the mean, it can represent the entire data set. Now, similar to the probability density function, the normal distribution appears as a bell curve. All right. Now, when it comes to normal distribution, there are two important factors. All right, we have the mean of the population and the standard deviation. Okay, so the mean in the graph determines the location of the center of the graph, right? And the standard deviation determines the height of the graph. Okay, so if the standard deviation is large, the curve is going to look something like this. All right, it'll be short and wide. And if the standard deviation is small, the curve is tall and narrow. All right. So this was it about normal distribution. Now let's look at the central limit theory. Now the central limit theory states that the sampling distribution of the mean of any independent random variable will be normal or nearly normal if the sample size is large enough. Now that's a little confusing. Okay, let me break it down for you. Now in simple terms, if we had a large population and we divided it into many samples, then the mean of all the samples from the population will be almost equal to the mean of the entire population. All right, meaning that each of the sample is normally distributed, right? So if you compare the mean of each of the sample, it will almost be equal to the mean of the population, right? So this graph basically shows a more clear understanding of the central limit theorem, right? You can see each sample here and the mean of each sample is almost along the same line, right? Okay, so this is exactly what the central limit theorem states. Now, the accuracy or the resemblance to the normal distribution depends on two main factors, right? So the first is the number of sample points that you consider, all right? And the second is the shape of the underlying population. Now, the shape obviously depends on the standard deviation and the mean of a sample, correct? So guys, central limit theorem basically states that each sample will be normally distributed in such a way that the mean of each sample will coincide with the mean of the actual population. All right, in short terms, that's what central limit theorem states. All right, and this holds true only for a large data set. Mostly for a small data set, there are more deviations when compared to a large data set. It's because of the scaling factor, right? The smallest deviation in a small data set will change the value very drastically. But in a large data set, a small deviation will not matter at all. Now let's move on and look at our next topic, which is the different types of probability. Now this is an important topic because most of your problems can be solved by understanding which type of probability should I use to solve this problem, right? So we have three important types of probability. We have marginal, joint, and conditional probability. So let's discuss each of these. Now the probability of an event occurring unconditioned on any other event is known as marginal probability or unconditional probability. So let's say that you want to find the probability that a card drawn is a heart. All right. So if you want to find the probability that a card drawn is a heart, the probability will be 13 by 52. Since there are 52 cards in a deck and there are 13 hearts in a deck of cards, right? And there are 52 cards in a total deck. So your marginal probability will be 13 by 52. That's about marginal probability. Now let's understand what is joint probability. Now joint probability is a measure of two events happening at the same time. Okay, let's say that the two events are A and B. So the probability of event A and B occurring is the intersection of A and B. So for example, if you want to find the probability that a card is a 4 and a red, that would be joint probability. All right, because you're finding a card that is 4 and the card has to be red in color. So for the answer, this will be 2 by 52 because we have 1, 2 in hearts and we have 1, 2 in diamonds, correct? So both of these are red in color, therefore our probability is 2 by 52. And if you further down it, it is 1 by 26. Right? So this is what joint probability is all about. Moving on, let's look at what exactly conditional probability is. So if the probability of an event or an outcome is based on the occurrence of a previous event or an outcome, then you call it as a conditional probability. Okay. So the conditional probability of an event B is the probability that the event will occur given that an event A has already occurred, right? So if A and B are dependent events, then the expression for conditional probability is given by this. Now this first term on the left hand side, which is P B of A, is basically the probability of event B occurring given that event A has already occurred. All right. So like I said, if A and B are dependent events, then this is the expression. But if A and B are independent events, then the expression for conditional probability is like this, right? So guys, P of A and P of B is obviously the probability of A and probability of B, right? Now let's move on. Now in order to understand conditional probability, joint probability, and marginal probability, let's look at a small use case. Okay, Now, basically, we're going to take a data set which examines the salary package and training undergone by candidates. Okay, now in this, there are 60 candidates without training and 45 candidates which have enrolled for Edureka's training. Right now, the task here is you have to assess the training with the salary package. Okay, let's look at this in a little more depth. So in total, we have 105 candidates, out of which 60 of them have not enrolled for Edureka's training and 45 of them have enrolled for Edureka's training. All right, this is a small survey that was conducted, and this is the rating of the package or the salary that they got. Right, so if you read through the data, you can understand. There were 5 candidates without Edureka training who got a very poor salary package. Okay, similarly, there are 30 candidates with Edureka training who got a good package, right? So guys, basically you're comparing the salary package of a person depending on whether or not they've enrolled for Edureka training, right? This is our data set. Now let's look at our problem statement. Find the probability that a candidate has undergone Edureka's training. Quite simple. Which type of probability is this? This is marginal probability, right? So the probability that a candidate has undergone Edureka's training is obviously 45 divided by 105. Since 45 is the number of candidates with Edureka training and 105 is the total number of candidates. So you get a value of approximately 0.42. All right, that's the probability of a candidate that has undergone Edureka's training. Next question. Find the probability that a candidate has attended Edureka's training and also has good package. Now, this is obviously a joint probability problem, right? So how do you calculate this? Now, since our table is quite formatted, we can directly find that people who have gotten a good package along with Edureka training are 30, right? So out of 105 people, 30 people have Edureka training and a good package, right? They're specifically asking for people with Edureka training. Remember that. Right? The question is find the probability that a candidate has attended Edureka's training and also has a good package. All right, so you need to consider 2 factors, that is a candidate who's attended Edureka's training and who has a good package. So clearly that number is 30. 30 divided by total number of candidates, which is 105. Right? So here you get the answer clearly. Next, we have find the probability that a candidate has a good package given that he has not undergone training. Okay, now this is clearly conditional probability because here you're defining a condition. You're saying that you want to find the probability of a candidate who has a good package given that he's not undergone any training, right? The condition is that he's not undergone any training. All right, so the number of people who have not undergone training are 60, and out of that, 5 of them have got a good package. Right, so that's why this is 5 by 60 and not 5 by 105, because here they've clearly mentioned has a good package given that he has not undergone training. So you have to only consider people who have not undergone training, right? So only 5 people who have not undergone training have gotten a good package, right? So 5 divided by 60, you get a probability of around 0.08, which is pretty low, right? Okay. So this was all about the different types of probability. Now let's move on and look at our last topic in probability, which is Bayes' theorem. Now guys, Bayes' theorem is a very important concept when it comes to statistics and probability. It is majorly used in naive Bayes algorithm. Those of you who aren't aware, naive Bayes is a supervised learning classification algorithm, and it is mainly used in Gmail spam filtering. Right, a lot of you might have noticed that if you open up Gmail, you'll see that you have a folder called spam, right? All of that is carried out through machine learning, and the algorithm used there is naive Bayes, right? So now let's discuss what exactly the Bayes theorem is and what it denotes. The Bayes theorem is used to show the relation between one conditional probability and its inverse. All right. Basically, it's nothing but the probability of an event occurring based on prior knowledge of conditions that might be related to the same event. Okay, so mathematically, the Bayes theorem is represented like this, right, like shown in this equation. The left-hand term is referred to as the likelihood ratio, which measures the probability of occurrence of event B given an event A. Okay. On the left-hand side is what is known as the posterior. Alright, it is referred to as posterior, which means that the probability of occurrence of A given an event B. Right? The second term is referred to as the likelihood ratio. Alright, this measures the probability of occurrence of B given an event A. Now, P of A is also known as the prior, which refers to the actual probability distribution of A, and P of B is again the probability of B. Right? This is the Bayes theorem. Now, in order to better understand the Bayes theorem, let's look at a small example. Let's say that we have three bowls. We have bowl A, bowl B, and bowl C. Okay, bowl A contains 2 blue balls and 4 red balls. Bowl B contains 8 blue balls and 4 red balls. Bowl C contains 1 blue ball and 3 red balls. Now, if we draw one ball from each bowl, what is the probability to draw a blue ball from a bowl A if we know that we drew exactly a total of 2 blue balls? Right? If you didn't understand the question, please reread it. I shall pause for a second or two. Right? So I hope all of you have understood the question. Okay, now what I'm going to do is I'm going to draw a blueprint for you and tell you how exactly to solve the problem. But I want you all to give me the solution to this problem, right? I'll draw a blueprint. I'll tell you what exactly the steps are, but I want you to come up with the solution on your own, right? The formula is also given to you. Everything is given to you. All you have to do is come up with a final answer, right? Let's look at how you can solve this problem. So first of all, what we'll do is let's consider A. All right, let A be the event of picking a blue ball from bag A, and let X be the event of picking exactly 2 blue balls, right? Because these are the 2 events that we need to calculate the probability of. Now, there are 2 probabilities that you need to consider here. One is the event of picking a blue ball from bag A, and the other is the event of picking exactly 2 blue balls. Okay. So these 2 are represented by A and X respectively. So what we want is the probability of occurrence of event A given X, which means that given that we're picking exactly 2 blue balls, what is the probability that we are picking a blue ball from bag A? So by the definition of conditional probability, this is exactly what our equation will look like, correct? This is basically occurrence of event A given an event X, and this is the probability of A and X, and this is the probability of X alone, correct? Now what we need to do is we need to find these 2 probabilities, which is probability of A and X occurring together and probability of X. Okay, this is the entire solution. So how do you find P, probability of X? This you can do in 3 ways. So first is white ball from A, either white from B or red from C. Now, first is to find the probability of X. X basically represents the event of picking exactly 2 blue balls, right? So these are the 3 ways in which it is possible. So you'll pick 1 blue ball from bowl A and 1 from bowl B. In the second case, you can pick 1 from A and another blue ball from C. In the third case, you can pick a blue ball from bag B and a blue ball from bag C. Right? These are the 3 ways in which it is possible. So you need to find the probability of each of this. Step 2 is that you need to find the probability of A and X occurring together. This is the sum of terms 1 and 2. Okay, this is because in both of these events, we are picking a ball from bag A. Correct? So guys, find out this probability and let me know your answer in the comment section. All right, we'll see if you get the answer right. I gave you the entire solution to this. All you have to do is substitute the value, right? If you want a second or two, I'm going to pause on the screen so that you can go through this in a more clearer way, right? Remember that you need to calculate 2 probabilities. The first probability that you need to calculate is the event of picking a blue ball from bag A given that you're picking exactly 2 blue balls. Okay. The second probability you need to calculate is the event of picking exactly 2 blue balls. All right. These are the 2 probabilities you need to calculate. So remember that, and this is the solution. All right. So guys, make sure you mention your answers in the comment section. For now, let's move on and look at our next topic, which is the inferential statistics. So guys, we just completed the probability module, right? Now we'll discuss inferential statistics, which is the second type of statistics. We discussed descriptive statistics earlier, all right? So like I mentioned earlier, inferential statistics, also known as statistical inference is a branch of statistics that deals with forming inferences and predictions about a population based on a sample of data taken from the population. All right. Now, the question you should ask is, how does one form inferences or predictions on a sample? The answer is you use point estimation. Okay. Now, you must be wondering, what is point estimation? Point estimation is concerned with the use of the sample data to measure a single value which serves as an approximate value or the best estimate of an unknown population parameter. That's a little confusing. Let me break it down to you. For example, in order to calculate the mean of a huge population, what we do is we first draw out the sample of the population and then we find the sample mean, right? The sample mean is then used to estimate the population mean. This is basically point estimate. You're estimating the value of one of the parameters of the population, right? Basically, the mean, you're trying to estimate the value of the mean. This is what point estimation is. There are two main terms in point estimation. There's something known as the estimator and there's something known as the estimate. Estimator is a function of the sample that is used to find out the estimate. All right. In this example, it's basically the sample mean, right? So a function that calculates the sample mean is known as the estimator, and the realized value of the estimator is the estimate, right? So I hope point estimation is clear. Now, how do you find the estimates? There are 4 common ways in which you can do this. The first one is method of moments. Here what you do is you form an equation in the sample data set and then you analyze a similar equation in the population data set as well, like the population mean, population variance, and so on. So in simple terms, what you're doing is you're taking down some known facts about the population and you're extending those ideas to the sample. All right. Once you do that, you can analyze the sample and estimate more essential or more complex values. Right. Next, we have maximum of likelihood. Now, this method basically uses a model to estimate a value. All right. Now, a maximum of likelihood is majorly based on probability. So there's a lot of probability involved in this method. Next, we have the Bayes estimator. This works by minimizing the errors or the average risk. Okay. The Bayes estimator has a lot to do with the Bayes theorem. All right. Let's not get into the depth of these estimation methods. Finally, we have the best unbiased estimators. In this method, there are several unbiased estimators that can be used to approximate a parameter. Okay. So guys, these were a couple of methods that are used to find the estimate. But the most well-known method to find the estimate is known as the interval estimation. Okay, this is one of the most important estimation methods. All right, this is where confidence interval also comes into the picture, right? Apart from interval estimation, we also have something known as margin of error. So I'll be discussing all of this in the upcoming slides. So first, let's understand what is interval estimate. Okay. An interval or range of values which are used to estimate a population parameter is known as an interval estimation. Right? That's very understandable. Basically, what they're trying to say is you're going to estimate the value of a parameter. Let's say you're trying to find the mean of a population. What you're going to do is you're going to build a range and your value will lie in that range or in that interval. All right. So this way your output is going to be more accurate because you've not predicted a point estimation. Instead, you have estimated an interval within which your value might occur, right? Okay, now this image clearly shows how point estimate and interval estimate are different. So guys, interval estimate is obviously more accurate because you're not just focusing on a particular value or a particular point in order to predict the probability. Instead, you're saying that the value might be within this range, between the lower confidence limit and the upper confidence limit. All right. This just denotes the range or the interval. Okay, if you're still confused about interval estimation, let me give you a small example. If I stated that I will take 30 minutes to reach the theater, this is known as point estimation. Okay. But if I stated that I will take between 45 minutes to an hour to reach the theater, this is an example of interval estimation. All right. I hope it's clear now. Now, interval estimation gives rise to 2 important statistical terminologies. One is known as confidence interval and the other is known as margin of error. All right. So guys, it's important that you pay attention to both of these terminologies. Confidence interval is one of the most significant measures that are used to check how essential a machine learning model is. All right. So, what is confidence interval? Confidence interval is the measure of your confidence that the interval estimated contains the population parameter or the population mean or any of those parameters. Right. Now, statisticians use a confidence interval to describe the amount of uncertainty associated with a sample estimate of a population parameter. Now guys, this is a lot of definition. Let me just make you understand confidence interval with a small example. Okay, let's say that you perform a survey and you survey a group of cat owners to see how many cans of cat food they purchase in 1 year. Okay, you test your statistics at the 99% confidence level and you get a confidence interval of 100, 200. This means that you think that the cat owners buy between 100 to 200 cans in a year. And also, since the confidence level is 99%, it shows that you're very confident that the results are correct. Okay, I hope all of you are clear with that. Right, so your confidence interval here will be 100 and 200, and your confidence level will be 99%. Right, that's the difference between confidence interval and confidence level. So within your confidence interval, your value is going to lie, and your confidence level will show how confident you are about your estimation. Right, I hope that was clear. Let's look at margin of error. Now, margin of error for a given level of confidence is the greatest possible distance between the point estimate and the value of the parameter that it is estimating. You can say that it is a deviation from the actual point estimate. Right? Now, the margin of error can be calculated using this formula. Now, ZC here denotes the critical value or the confidence interval, and this is multiplied by standard deviation divided by root of the sample size. All right, n is basically the sample size. Now, let's understand how you can estimate the confidence intervals. So, guys, the level of confidence, which is denoted by C, is the probability that the interval estimate contains a population parameter. Let's say that you're trying to estimate the mean. All right. So the level of confidence is the probability that the interval estimate contains the population parameter. So this interval between minus ZC and ZC, or the area beneath this curve, is nothing but the probability that the interval estimate contains a population parameter. All right, it should basically contain the value that you are predicting. Right, now these are known as critical values. This is basically your lower limit and your higher limit confidence level. Also, there's something known as the z-score. Now this score can be calculated by using the standard normal table. All right, if you look it up anywhere on Google, you'll find the z-score table or the standard normal table. Okay, to understand how this is done, let's look at a small example. Okay, let's say that the level of confidence is 90%. This means that you are 90% confident that the interval contains the population mean. Okay, so the remaining 10%, which is out of 100%, the remaining 10% is equally distributed on these tail regions. Okay, so you have 0.05 here and 0.05 over here. Right, so on either side of C, you'll distribute the other leftover percentage. Now these z-scores are calculated from the table as I mentioned before. All right, 1.645 is calculated from the standard normal table. Okay, so guys, this is how you estimate the level of confidence. So to sum it up, let me tell you the steps that are involved in constructing a confidence interval. First, you'll start by identifying a sample statistic. Okay, this is the statistic that you will use to estimate a population parameter. This can be anything like the mean of the sample. Next, you will select a confidence level. Now, the confidence level describes the uncertainty of a sampling method. Right? After that, you'll find something known as the margin of error. Right? We discussed margin of error earlier. So you find this based on the equation that I explained in the previous slide. Then you'll finally specify the confidence interval. All right. Now let's look at a problem statement to better understand this concept. A random sample of 32 textbook prices is taken from a local college bookstore. The mean of the sample is so and so, and the sample standard deviation is this. Use a 95% confident level and find the margin of error for the mean price of all textbooks in the bookstore. Okay, now this is a very straightforward question. If you want, you can read the question again. All you have to do is you have to just substitute the values into the equation. All right. So guys, we know the formula for margin of error. You take the z-score from the table. After that, we have deviation, which is 23.44, right? And that's standard deviation. And n stands for the number of samples. Here the number of samples is 32, basically 32 textbooks. So approximately your margin of error is going to be around 8.12. This is a pretty simple question. All right. I hope all of you understood this. Now that you know the idea behind confidence interval, let's move ahead to one of the most important topics in statistical inference, which is hypothesis testing, right? So basically, statisticians use hypothesis testing to formally check whether the hypothesis is accepted or rejected. Okay. Hypothesis testing is an inferential statistical technique used to determine whether there is enough evidence in a data sample to infer that a certain condition holds true for an entire population. So to understand the characteristics of a general population, we take a random sample and we analyze the properties of the sample, right? We test whether or not the identified conclusion represents the population accurately, and finally we interpret their results. Now, whether or not to accept the hypothesis depends upon the percentage value that we get from the hypothesis. Okay, so to better understand this, let's look at a small example. Before that, there are a few steps that are followed in hypothesis testing. You begin by stating the null and the alternative hypothesis. All right, I'll tell you what exactly these terms are. And then you formulate an analysis plan. All right, after that, you analyze the sample data. And finally, you can interpret the results, right? Now, to understand the entire hypothesis testing, we'll look at a good example. Okay. Now consider four boys, Nick, John, Bob, and Harry. These boys were caught bunking a class and they were asked to stay back at school and clean their classroom as a punishment. Right? So what John did is he decided that four of them would take turns to clean their classrooms. He came up with a plan of writing each of their names on chits and putting them in a bowl. Now every day they had to pick up a name from the bowl and that person had to clean the class. Right? That sounds pretty fair enough. Now it has been 3 days and everybody's name has come up except John's. Assuming that this event is completely random and free of bias, what is the probability of John not cheating? Right? What is the probability that he's not actually cheating? This can be solved by using hypothesis testing. Okay, so we'll begin by calculating the probability of John not being picked for a day. Right? So we're going to assume that the event is free of bias. So we need to find out the probability of John not cheating, right? First, we'll find the probability that John is not picked for a day, right? We get 3 out of 4, which is basically 75%. Now, 75% is fairly high. So if John is not picked for 3 days in a row, the probability will drop down to approximately 42%. Okay, so 3 days in a row meaning the probability drops down to 42%. Now let's consider a situation where John is not picked for 12 days in a row. The probability drops down to 3.2%. Okay, thus the probability of John cheating becomes fairly high, right? So in order for statisticians to come to a conclusion, they define what is known as the threshold value, right? Considering the above situation, if the threshold value is set to 5%, it would indicate that if the probability lies below 5%, then John is cheating his way out of detention. But if the probability is above the threshold value, then John is just lucky and his name isn't getting picked. So the probability and hypothesis testing give rise to two important components of hypothesis testing, which is null hypothesis and alternate hypothesis. Null hypothesis is basically approving the assumption. Alternate hypothesis is when your result disapproves the assumption. Right? Therefore, in our example, if the probability of an event occurring is less than 5%, which it is, then the event is biased. Hence, it proves the alternate hypothesis. So guys, with this, we come to the end of this session. So before I wrap up, we're going to run a quick demo, which is based on inferential statistics. Let's quickly open up R Studio. Again, I'll be running this in R language, and those of you who don't know R, it's okay. I'm going to leave a couple of links in the description, and this is pretty understandable. This is just basic math, right? Now, in this demo, what we'll be doing is we'll be using the Gapminder dataset to perform hypothesis testing. Now, guys, the Gapminder dataset contains a list of 142 countries with their respective values for life expectancy, a GDP per capita, and population every 5 years from 1952 to 2007. Okay, don't worry, I'll show you the dataset. So what we'll do is we'll begin by installing and downloading the Gapminder dataset. So this install.packages will basically install the Gapminder package, and this library Gapminder will just load the Gapminder library. All right. So we've successfully loaded our Gapminder package. Now let's view this data set. These are the countries, all right, different countries, and you have the continents, the year, the life expectancy, the population, and the GDP per capita. Okay, for so each of these countries, we have this information, right? Now the next step is to load the famous deployer package provided by R. We're specifically looking to use the pipe operator in this package. Okay. Now for those of you who don't know what the pipe operator does, this is a pipe operator, right? Now the pipe operator allows you to pipe your data from the left hand side into the data at the right hand side of the pipe. Okay, it's quite self-explanatory. It's a pipe which connects two data points, right? So let's install and load this package. All right. Now, our next step, what we're going to do is we're going to compare the life expectancy of two places. Okay, we're going to compare the life expectancy of Ireland and South Africa, and we're going to perform the t-test to check if the comparison follows a null hypothesis or an alternate hypothesis. Okay, so let's run the code. Okay, so now we'll apply the t-test and we'll compare the life expectancy of these two places. All right, let's run this. Notice the mean in group Ireland and South Africa. Right here is the mean. You can see that the life expectancy almost differs by a scale of 20. Now we need to check if this difference in the value of life expectancy in South Africa and Ireland is actually valid and not just by pure chance. Okay. For this reason, the t-test is carried out. So pay special attention to this p-value over here. This is also known as the probability value, right? The p-value is very important measurement when it comes to ensuring the significance of a model. A model is said to be statistically significant only when the p-value is less than the predetermined statistical significance level, which is ideally 0.05, right? So your p-value has to be much lesser than 0.05. As you can see from our output, the p-value is very, very lesser when compared to 0.05. Right, it is an extremely small value, which is a good thing. Now, in the summary of the model, notice another important parameter called the t-value. Right, I've been talking about the t-test. And what exactly is this t-value? You can see it over here. It is 10.067. Now, a larger t-value suggests that the alternate hypothesis is true and that the difference in life expectancy is not equal to 0 by pure luck. Hence, in our case, the null hypothesis is disproved. So to conclude the demo, we'll be plotting a graph for each continent such that the graph shows how the life expectancy for each continent varies with the respective GDP per capita. Just to add a little bit data visualization, I'm performing this last step. So guys, here we can clearly see from the output that the alternate hypothesis is true. All right. And also this is calculated with a 95% confidence interval. Right, you get what I'm saying when I'm talking about 95% confidence interval, right? This is our confidence interval 15 to 22 and our confidence level is 95%. This is exactly what we discussed a couple of minutes ago. Now just to end the demo, I'll show you a small visualization. Here what we're doing is we're showing how the life expectancy for each continent varies with respect to the GDP per capita for that continent. Okay, so this is our plot. Okay, if you look at the illustration, you can almost see a linear variance, right? You can almost see a linear line in the life expectancy for each of the continent with respect to the GDP per capita, Right? This also shows how well the R language can be used for statistical analysis. Right? Look at how pretty the graph looks, and also how well they show that there is almost a linear dependency between the GDP per capita and the life expectancy.
Basically, data science focuses on building models for future predictions, while data analytics analyzes the past data for present decision making. So, what is data analytics? Data analytics involves analyzing data sets to identify trends and also draw conclusions, using systems to transform, organize, and model the data to identify patterns. Data analytics is commonly used for business intelligence, reporting, and descriptive analysis to support ongoing operations and decision making. Moving forward, let's understand the process of data science. The first step is problem definition and data collection. Here, we will define our problem statement while strategically gathering the relevant data simultaneously. And the next step is data cleaning and pre-processing. With the data in hand, it is a process of addressing differences and inequality in a data, and also ensuring our data is in a prime condition for analysis as well as modeling. And the next phase is exploratory data analysis and feature engineering. In this part, it will reveal the insights, while feature engineering creates a new dimensions for insights. Moving forward, we have modeling and evaluation. In this step, we select, build, and evaluate machine learning models. And the final step is deployment, monitoring, and maintenance. In this step, models are implemented into a production space and also monitored or maintained over a time. Now, let's see the process of data analytics. The first step is project requirement and data collection. This step is almost similar to the step of data science. Based on a problem statement, we have to collect the data. And the next step is data cleaning and pre-processing. In this step also, we are following the same step of data science. Like with the data in our hand, it is a process of addressing data differences or inequality in data. And also, we have to ensure our data is in a prime condition for analysis purpose. And then we have exploratory data analysis or visualization. Here, we have to investigate the data for insights and visualize patterns through analysis. Moving forward, we have decision making and reporting. It is a significant step for reporting key findings to support a decision making processes. And the final step is implementation. This step applies insights and recommendations to influence business processes. Now, we will discuss the key differences between data science and data analytics. The first key difference is data science involves programming, statistics, and machine learning, whereas data analytics involves statistical analysis, data visualization, and business intelligence tools. And the next one is the objective of data science is to cover the new patterns and insights through complex algorithms, whereas in data analytics focuses on descriptive analysis for decision support and process optimization. In data science, it is concerned with the long-term strategical decisions based on future predictions, whereas in data analytics, it is concerned with the short-term operational decisions based on current insights. Data science deals with the explorations and new innovations, whereas data analytics makes a use of existing resources. Data science is utilized in predictive modeling, artificial intelligence, and automation, whereas data analytics is used in business intelligence, reporting, and process optimization. And finally, data science deals with the unstructured data, whereas data analytics deals with the structured data. Since we got an overview of the key differences between data science and data analytics, let's move on to some essential technical skills required for data science. The first skill is programming skill. You must be familiar with a variety of languages including Python, C or C++, Java and SQL, but Python is being a most commonly required coding language in data science roles. And the next one is statistical analysis and mathematics. Machine learning requires statistical analysis concepts like linear regression and logistical regression. As well as data scientists must understand mean mode, median, variance and standard deviation also, and should be familiar with the probability distribution, over and under sampling, and also dimension reduction. And then we have machine learning skill. As a data scientist, it is essential to learn machine learning and deep learning with the advanced models like random forest and also some of the key machine learning algorithms like logistic regression, naive Bayes, decision tree, linear regression and also K-nearest neighbor. And the next skill required is data wrangling. Data wrangling means cleaning, transforming and organizing the raw data to ensure it is structured and ready for analysis. This is a foundational skill for effective data science workflows such as Pandas, NumPy and OpenRefine. And also, data scientists must familiar with the database management tools like MongoDB, MySQL and also Oracle. And the final skill is data visualization. After all these skills, not only we need to know how to analyze, organize and categorize the data, but we should also develop data visualization skills. It would help if we were comfortable with the technologies like Tableau, Microsoft Excel and Power BI. Next, we will see the skills that are required for data analytics. The first skill we required is SQL and database knowledge. SQL is a database coding language used to manage large datasets in relational databases. Proficiency in SQL allows CRUD operations, which means create, read, update and delete, and also querying the data from databases. And the next skill is data integration and analysis. Data integration seamlessly combines informations from the various sources, resulting in a unified or a comprehensive dataset. They extract meaningful insights, uncover patterns, and transform the raw data into actionable intelligence. And the next skill is spreadsheet skills. Here, Microsoft Excel is a powerful data management tool for its quick analytics and easy data storage. Organizations and employers prefer it for its analysis, with the advanced Excel knowledge for data manipulation as well as for visualization. And the next skill is business acumen and domain knowledge. Business acumen refers to understanding organizational goals and strategies, whereas domain knowledge refers to understanding a specific industry or sector. These abilities enable analysts to align data insights with the business objectives, making actionable recommendations and decision making. And the final skill is communication skill. It is one of the important skills which we required for each and every roles in the industry. So, data analysts collaborate with the various departments to create profitable solutions for organizations. Excellent communication skills include active listening, verbal and written communications. So basically, data analysts communicate insights, suggest solutions, and write clear performance reports. Let's see the career opportunities for data science. And some of them are data scientist, machine learning engineering, data engineering, and also business intelligence manager. Now, we will discuss the career opportunities for data analyst learners. And some of them are data analyst, business intelligence analyst, operations analyst, and also market research analyst. Coming to the final section of this video, let us look at the 5 top companies that are hiring for data science. Some of the companies are IBM, Accenture, Amazon, Microsoft, and Cloudera. Moving forward, we will see the companies that are hiring for data analysts as well. Some of the companies are Accenture, IBM, Amazon, Oracle, and Tableau. Finally, let's see the salary status for both data scientist and data analytics. So first we'll see for data scientist. The average annual salary for data scientists in India is 14 lakhs per annum, whereas in USA, it is around $156,000. Next, we will see for data analyst. In India is 7 lakhs per annum, whereas in USA, it is around $82,000.
So what is the importance or what is the need for machine learning? Now, ever since the technical revolution, we've been generating an immeasurable amount of data. As per research, we're generating around 2.5 quintillion bytes of data every single day. And it is estimated that 1.7 MB of data will be created every second for every person on Earth. Now, that is a lot of data. Right now, this data comes from sources such as the cloud, IoT devices, social media, and all of that. Since all of us are very interested in the internet right now, we're generating a lot of data. Right? You have no idea how much data we generate through social media. All the chatting that we do and all the images that we post on Instagram, the videos that we watch, all of this generates a lot of data. Now, how does machine learning fit into all of this? Since we're producing this much data, we need to find a method that can analyze, process, and interpret this much data. All right, and we need to find a method that can make sense out of data. And that method is machine learning. Now, there are a lot of top-tier companies and data-driven companies such as Netflix and Amazon, which build machine learning models by using tons of data in order to identify any profitable opportunities. And if they want to avoid any unwanted risks, they make use of machine learning. All right. So through machine learning, you can predict risks, you can predict profits, you can identify opportunities which will help you grow your business. So now I'll show you a couple of examples wherein machine learning is used. All right. So I'm sure all of you have binge watched on Netflix. Now, the most important thing about Netflix is its recommendation engine. All right. Most of Netflix's revenue comes from its recommendation engine. So the recommendation engine basically studies the movie viewing patterns of its users and then recommends relevant movies to them. All right. It recommends movies depending on users' interests, depending on the type of movies the user watches and all of that. All right. So that is how Netflix uses machine learning. Next, we have Facebook's auto tagging feature. Now, the logic behind Facebook's auto tagging feature is machine learning and neural networks. I'm not sure how many of you know this, but Facebook makes use of DeepMind face verification system, which is based on machine learning, natural language processing, and neural networks. So DeepMind basically studies the facial features in an image and it tags your friends and family. Another such example is Amazon's Alexa. Now, Alexa is basically an advanced level virtual assistant that is based on natural language processing and machine learning. Now, it can do more than just play music for you, all right? It can book your Uber, it can connect with other IoT devices at your house, it can track your health, it can order food online and all of that. Okay, so data and machine learning are basically the main factors behind Alexa's power. Another such example is the Google spam filter. So guys, Gmail basically makes use of machine learning to filter out spam messages. If any of you just open your Gmail inbox, you'll see that there are separate sections. There's one for primary, there's social, there's spam, and there's your general mail. Now, basically, Gmail makes use of machine learning algorithms and natural language processing to analyze emails in real time and then classify them as either spam or non-spam. Now, this is another famous application of machine learning. So, to sum this up, let's look at a few reasons why machine learning is so important. So, the first reason is obviously increase in data generation. So because of excessive production of data, we need a method that can be used to structure, analyze, and draw useful insights from data. This is where machine learning comes in. It uses data to solve problems and find solutions to the most complex tasks faced by organizations. Another important reason is that it improves decision making. So by making use of various algorithms, machine learning can be used to make better business decisions. For example, machine learning is used to forecast sales. It is used to predict any downfalls in the stock market. It is used to identify risks, anomalies, and so on. Now, the next reason is it uncovers patterns and trends in data. Finding hidden patterns and extracting key insights from data is the most essential part of machine learning. So by building predictive models and using statistical techniques, machine learning allows you to dig beneath the surface and explore the data at a minute scale. Now, understanding data and extracting patterns manually will take a lot of days. Now, if you do this through machine learning algorithms, you can perform such computations in less than a second. Another reason is that it solves complex problems. So from detecting genes that are linked to deadly ALS diseases to building self-driving cars and building face detection systems, machine learning can be used to solve the most complex problems. So guys, now that you know why machine learning is so important, let's look at what exactly machine learning is. The term machine learning was first coined by Arthur Samuel in the year 1959. Now, looking back, that year was probably the most significant in terms of technological advancements. Guys, if you browse through the net about what is machine learning, you'll get at least 100 different definitions. Now, the first and very formal definition was given by Tom M. Mitchell. Now, the definition says that a computer program is said to learn from experience E with respect to some class of tasks T and performance measure P if its performance at tasks in T as measured by P improves with experience E. Alright. Now, I know this is a little confusing, so let's break it down into simple words. Now, in simple terms, machine learning is a subset of artificial intelligence which provides machines the ability to learn automatically and improve from experience without being explicitly programmed to do so. In the sense, it is the practice of getting machines to solve problems by gaining the ability to think. But wait, now how can a machine think or make decisions? Well, if you feed a machine a good amount of data, it will learn how to interpret, process, and analyze this data by using machine learning algorithm. Okay. Now, guys, look at this figure on top. Now, this figure basically shows how a machine learning algorithm or how the machine learning process really works. So the machine learning process begins by feeding the machine lots and lots of data. Okay, by using this data, the machine is trained to detect hidden insights and trends. Now, these insights are then used to build a machine learning model by using an algorithm in order to solve a problem. Okay, so basically, you're going to feed a lot of data to the machine. The machine is going to get trained by using this data. It's going to use this data and it's going to draw useful insights and patterns from it. And then it's going to build a model by using machine learning algorithms. Now, this model will help you predict the outcome or help you solve any complex problem or any business problem. So that's a simple explanation of how machine learning works. Now let's move on and look at some of the most commonly used machine learning terms. So first of all, we have algorithm. Now this is quite self-explanatory. Basically, algorithm is a set of rules or statistical techniques which are used to learn patterns from data. Now an algorithm is the logic behind a machine learning model. Alright, an example of a machine learning algorithm is linear regression. I'm not sure how many of you have heard of linear regression. It's the most simple and basic machine learning algorithm. Alright, next we have model. Now model is the main component of machine learning. Alright, so model will basically map the input to your output by using the machine learning algorithm and by using the data that you're feeding the machine. So basically, the model is a representation of the entire machine learning process. So the model is basically fed input, which is a lot of data, and then it will output a particular result or a particular outcome by using machine learning algorithms. Next, we have something known as predictor variable. Now, predictor variable is a feature of the data that can be used to predict the output. So for example, let's say that you're trying to predict the weight of a person depending on the person's height and their age. All right. So over here, the predictor variables are your height and your age because you're using height and age of a person to predict the person's weight. All right. So the height and the age are the predictor variables. Now, weight, on the other hand, is the response or the target variable. So response variable is a feature or the output variable that needs to be predicted by using the predictor variables. All right. After that, we have something known as training data. So guys, the data that is fed to a machine learning model is always split into two parts. First, we have the training data and then we have the testing data. Now, training data is basically used to build the machine learning model. So usually training data is much larger than the testing data, because obviously if you're trying to train the machine, then you're going to feed it a lot more data. Testing data is just used to validate and evaluate the efficiency of the model. All right, so that was training data and testing data. So guys, these were a few terms that I thought you should know before we move any further. Okay, now let's move on and discuss the machine learning process. Now this is going to get very interesting because I'm going to give you an example and make you understand how the machine learning process works. So first of all, let's define the different stages or the different steps involved in the machine learning process. So a machine learning process always begins with defining the objective or defining the problem that you're trying to solve. Next stage is data gathering or data collection. Now the data that you need to solve this problem is collected at this stage. This is followed by data preparation or data processing. After that, you have data exploration and analysis. And the next stage is building a machine learning model. This is followed by model evaluation. And finally, you have prediction or your output. Now let's try to understand this entire process with an example. So our problem statement here is to predict the possibility of rain by studying the weather conditions. So let's say that you're given a problem statement and you're asked to use a machine learning process to solve this problem statement. So let's get started. All right, so the first step is to define the objective of the problem statement. Our objective here is to predict the possibility of rain by studying the weather conditions. Now, in the first stage of a machine learning process, you must understand what exactly needs to be predicted. Now, in our case, the objective is to predict the possibility of rain by studying weather conditions, right? So at this stage, it is also essential to take mental notes on what kind of data can be used to solve this problem, or the type of approach that you can follow to get to the solution. All right. A few questions that are worth asking during this stage is, what are we trying to predict? What are the target features, or what are the predictor variables? What kind of input data do we need? And what kind of problem are we facing? Is it a binary classification problem, or is it a clustering problem? Now, don't worry if you don't know what classification and clustering is. I'll be explaining this in the upcoming slides. So guys, this was the first step of a machine learning process, which is define the objective of the problem. All right, now let's move on and look at step number 2. So step number 2 is basically data collection or data gathering. Now at this stage, you must be asking questions such as what kind of data is needed to solve the problem? Is the data available? And if it is available, how can I get the data? Okay, so once you know the type of data that is required, you must understand how you can derive this data. Data collection can be done manually or by web scraping. But if you're a beginner and you're just looking to learn machine learning, you don't have to worry about getting the data. Okay, there are thousands of data resources on the web. You can just go ahead and download the data sets from websites such as Kaggle. Okay, now coming back to the problem at hand, the data needed for weather forecasting includes measures such as humidity level, temperature, pressure, locality, whether or not you live in a hill station, and so on. So guys, such data must be collected and stored for analysis. Now the next stage in machine learning is preparing your data. The data you collected is almost never in the right format. So basically you'll encounter a lot of inconsistencies in the data set. Okay, this includes missing values, redundant variables, duplicate values, and so on. Removing such values is very important because they might lead to wrongful computations and predictions. So that's why at this stage, you must scan the entire data set for any inconsistencies and you have to fix them at this stage. Now, the next step is exploratory data analysis. Now, data analysis is all about diving deep into data and finding all the hidden data mysteries. Okay, this is where you become a detective. So EDA or exploratory data analysis is like the brainstorming of machine learning. Data exploration involves understanding the patterns and the trends in your data. So at this stage, all the useful insights are drawn and all the correlations between the variables are understood. So you might ask, what sort of correlations are you talking about? For example, in the case of predicting rainfall, we know that there is a strong possibility of rain if the temperature has fallen low. Okay, so such correlations have to be understood and mapped at this stage. Now this stage is followed by stage number 5, which is building a machine learning model. So all the insights and the patterns that you derived during data exploration are used to build the machine learning model. So this stage always begins by splitting the data set into two parts, training data and the testing data. So earlier in this session, I already told you what training and testing data is. Now the training data will be used to build and analyze the model, and the logic of the model will be based on the machine learning algorithm that is being implemented. Okay. Now in the case of predicting rainfall, since the output will be in the form of true or false, we can use a classification algorithm like logistic regression. Now choosing the right algorithm depends on the type of problem you're trying to solve, the data set you have, and the level of complexity of the problem. So in the upcoming sections, we'll be discussing different types of problems that can be solved by using machine learning. So don't worry if you don't know what classification algorithm is and what logistic regression is. Okay. So all you need to know is at this stage, you'll be building a machine learning model by using machine learning algorithm and by using the training data set. The next step in a machine learning process is model evaluation and optimization. So after building a model by using the training data set, it is finally time to put the model to a test. Okay. So the testing data set is used to check the efficiency of the model and how accurately it can predict the outcome. So once you calculate the accuracy, any improvements in the model have to be implemented in this stage. Okay. So methods like parameter tuning and cross-validation can be used to improve the performance of the model. This is followed by the last stage, which is predictions. So once the model is evaluated and improved, it is finally used to make predictions. The final output can be a categorical variable or it can be a continuous quantity. In our case, for predicting the occurrence of rainfall, the output will be a categorical variable. In the sense, our output will be in the form of true or false, yes or no. Yes basically represents that it's going to rain, and no will represent that no, it won't rain. Okay, as simple as that. So guys, that was the entire machine learning process.
Now, without wasting any more time, let us understand what regression in machine learning is. So what exactly is regression? The main goal of regression is the construction of an efficient model to predict the dependent attributes from a bunch of attribute variables. A regression problem is where the output variable is either real or a continuous value like salary, weight, area, etc. We can also define regression as a statistical means that is used in applications like housing, investing, etc. to predict the relationship between a dependent variable and a bunch of independent variables. For example, let's say in the finance application or investing, we can actually predict the values of certain stock prices, or those values depending on the independent variables like how many years it takes for a stock to actually mature, or how many days will it take to grow, or those variables that you have in investing. And depending upon that, we can make a possible outcome or a possible prediction of how our stock is going to be invested in a profit state or a loss state, or all those things. Or we can take another example like housing. We can take different parameters like number of years it's been there, how many people have used it, or what is the area of the house. Depending on all these factors, or how many rooms does a house have, we can predict the price of a house. So this is basically what regression really is. So let us take a look at the various types of regression techniques that we have. We have simple linear regression, then we have polynomial regression, support vector regression, decision tree regression, we have random forest regression, and we have logistic regression as well. That is also a type of regression that we have. But for now, we'll be focusing on simple linear regression. So let's talk about how or what exactly is simple linear regression first. So one of the most interesting and common regression technique is simple linear regression. In this, we predict the outcome of a dependent variable y based on the independent variables x. So the relationship between the variables is linear, hence the word linear regression. Then comes the polynomial regression. So in this regression technique, we transform the original features into a polynomial feature of a given degree and then perform regression on it. So this is basically polynomial regression. After this, we have support vector machine regression, or we can also call it SVR. We identify a hyperplane with maximum margin such that the maximum number of data points are within those margins. It is also quite similar to the support vector machine classification algorithm. Then we have decision tree regression. A decision tree can be used for both regression and classification, but in this case of regression, we use the ID3 algorithm, which is iterative dichotomizer 3, to identify the splitting node by reducing the standard deviation. After this, we have a random forest regression, which is basically an ensemble of predictions of several decision tree regressions. So this is all about the types of regressions. For now, we are going to focus on simple linear regression. So let's take a look at what exactly is a simple linear regression. Simple linear regression is a regression technique in which the independent variable has a linear relationship with the dependent variable. The straight line in the diagram is the best fit line, and the main goal of the simple linear regression is to consider the given data points and plot the best fit line to fit the model in the best way possible. So if we talk about a real life analogy to explain linear regression, we can take an example of a car resale value. So we have different parameters, when we are talking about a resale value of a car, like how many years the car has been there in the market and how many kilometers it has been ridden, the kind of mileage the car gives, and then we have different parameters we can focus upon, and all these independent variables somehow are linearly connected or interconnected to the price of the car. So that is one example to understand linear regression. We'll be doing that in the use case. I'll be telling you about how you can predict the price of car. Now, talking about linear regression terminologies, there are a few terminologies that you have to be thorough with to begin with linear regression. So first of all, we have to talk about cost function. So the best fit line can be based on the linear equation that is given here. So in this, the dependent variable that is to be predicted is denoted by y. A line that touches the y-axis is denoted by the intercept b0. The b1 is the slope of the line, and x represents the independent variables that determine the prediction of y. The error in the resultant prediction is denoted by e. Now talking about cost function, the cost function provides the best possible values for b0 and b1 to make the best fit line for the data points. We do this by converting this problem into a minimization problem to get the best values for b0 and b1. So with this, the error is minimized in this problem between the actual value and the predicted value, and we choose the function above to minimize. Now we square the error difference and sum the error over all the data points. The division between the total number of data points and the produced value provides the average square error for all the data points. It is also known as mean squared error, and we can change the values of b0 and b1 so that the MSE or the mean squared error value is settled at the minimum. So this is one terminology, that is cost function, that we use in linear regression. Then we have the gradient descent. So the next important terminology to understand linear regression is gradient descent, of course, and it is a method of updating b0 and b1 value to reduce the MSE, which is the mean squared error. The idea behind this is to keep iterating the b0 and b1 values until we reduce the MSE to the minimum. Now to update b0 and b1, we take the gradients from the cost function, and to find these gradients, we take partial derivatives with respect to b0 and b1. And these partial derivatives are the gradients and are used to update the values of b0 and b1. I'm sure guys this might be a little confusing for you guys if you are new to this, like gradient descent and cost function, but you don't have to worry about this, because in Python when we're using a linear regression, we're going to be using the sklearn or the scikit-learn library, so you don't have to worry about this. You just have to integrate your model with the linear regression module that we have already over there, and you will be done with it. And when I'm implementing the linear regression model, you'll see how easy it is to actually implement linear regression in Python. So after this, let's talk about a few advantages and disadvantages of linear regression. So talking about the advantages first, linear regression performs exceptionally well for linearly separable data. And it is actually very easy to implement, interpret, and very efficient to train as well. And even though the linear regression is prone to overfitting, it handles it pretty well using dimensional reduction techniques, regularization, and cross-validation. And one more advantage is that the extrapolation beyond a specific data set. So these are all the advantages that we have with linear regression. Let's talk about a few disadvantages as well. So one of the most common disadvantage with linear regression is that it takes the assumption of linearity between dependent and independent variables. The next disadvantage is it is often very prone to noise and overfitting as well, which is not a very good sign for any model if you are doing regression or classification in machine learning. The next disadvantage is it is very quite sensitive to outliers as well. And the last one is that it is very prone to multicollinearity. So these are all the advantages and disadvantages of linear regression. Now let's also take a look at a few use cases that we can use linear regression for. So we can use it for sales forecasting. Depending upon the features, like we can actually predict the price of a item, or in sales we can forecast the price or make assumptions over there, like predictions obviously. Then we can use it for risk analysis for disease predictions. Like we can take a disease data set, and depending upon several features that are linearly connected with one risk detection, we can use it for risk analysis as well. We can obviously use it for housing applications to predict the prices and other factors, like what are the different aspects that are going to be decisive in the price of a house, all those features using the linear regression. And then of course we can use it for finance applications to predict the stock prices, investment evaluation, etc. The basic idea behind linear regression is to find the relationship between the dependent and independent variables to get the best fitting line that would predict the outcome with the least error. So we can use linear regression in simple real life situations as well, like predicting the SAT scores with regard to the number of hours of study and other decisive factors that we can use it for. Now that we are done with the use cases as well, let's take a look at specific use case that I'm going to show you in sklearn or scikit-learn library, and we're going to implement the linear regression model over there. So let me take you through the steps that are going to take place over there. So first of all, we are going to load the data. After that, we'll explore the data. So we'll take a look at how our data is, what are the different features, and what are the data points that we have in the data set. After that, we'll slice the data according to our requirements, and then we'll train and split the data using the fit and predict method that we have in scikit-learn. And then we'll generate the model from the scikit-learn. And after we are done making the model, we'll evaluate the accuracy. So let's take it up to PyCharm, guys. I'll show you a very simple example first of all with the diabetes dataset that we have in scikit-learn. We can simply import it from the datasets module that we have in scikit-learn. And after this simple example, I'm going to show you a custom dataset that is a car resale value, and we're going to predict some prices for car resale values. So without wasting any more time, let's take it up to PyCharm. So now that we're in PyCharm, guys, we'll try to implement linear regression using simple dataset that we have in sklearn library. So first of all, we'll have to import basic libraries like matplotlib. I'll make it a little bigger for visibility. So first I'll import matplotlib.pyplot as, let's say, plt. And after that, I'll import numpy as np. So from sklearn, we'll have to import datasets because we are going to use the dataset from the datasets module. And we are going to import linear model as well for linear regression. Okay, I made a mistake over here. And again, we have to import metrics for accuracy evaluation, and we'll be importing mean squared error. So these are all the libraries that I'm going to use to show you how you can implement linear regression. But before that, don't make a mistake of using these libraries just as it is, because I have already installed all these libraries. So for that, you can just go to the project interpreter that you'll find in the settings, and over here you can just install all the packages that you need. So this is the add button. There you can add all the libraries that you need. So for sklearn, you can just type sklearn and install that library. I'm not doing that again because I've already done it. So after this, first thing that you have to do is import your dataset. So for that, I'm taking a variable disease and datasets dot load datasets, or I'm just going to load diabetes because that's the dataset that we are going to use in this. And let's just see what all we have in the dataset that we have over here. So I'm just going to print this to know what all we are dealing with right now. So it's going to take a while. So this is our dataset, guys. We already have our data over here. I'm sure we'll be having a target. We have a description over here. So this is our dataset, guys. We have a target also. So this is a very sliced up data, which is actually pretty good for our use right now because I'm showing you a simple implementation of linear regression. So this is going to be very easy. So what I'll do is I'll comment this line because we don't need this right now. And after this, I'll just take one more variable. Let's just say disease x, and inside this I am going to take disease.data. Now after this, I'm going to split my data into train and test. So what I'll do is I'll just write disease x. After this, I'll write train, and let me take another variable, that is the x test, and we'll have to take this same variable for y as well because we need two variables. So I'll take it as y, train, and disease, y, test. Now inside this, I'll have to split my data into training and testing data. So I'll use the disease over here, or we can just call it data also, disease X. And I'm going to split the data from the starting until -30. So I'll leave the last 30 data entries inside the data set, which I'm going to use in the training set. So I'll use for the training set the -20, that is from the last, the 20 entries that we have over here. And similarly, in the same thing, we are going to do for the y train and y test as well. So over here, I'll just write y. So before doing this, I'm just going to make it as target, because we're using the target variable over here, disease.target again. And in this, I am going to use the last 20 entries. So we have successfully split our data. Now what happens is, after splitting your data, you have to generate your model. For that, I'm just going to take one variable. So I'm just going to take it as reg, or regression. We can call it as regression as well. So I'm going to use linear model, and I'm going to call linear regression. So this is how you can generate your model. So after this, you have to fit your training data inside the model using the fit function. So I'll use fit over here, and to fit the data, I'm going to use disease X train, that has the data variables, all those values that we have over here. That is this one. This array is going to be in the training one, and we're going to use the target one for the disease Y. So I'll just do that, disease X train and disease Y train as well. So we're done. After this, I have to make a prediction variable as well. I'll make it as Y predict, and inside this, I am going to use the predict function. So for this, we are going to use the disease X test, because this is what we are testing right now. So our model is actually done, guys. I'll just write some code for checking the accuracy as well. So I'll use the mean squared error over here, and inside this, I'll pass disease Y test and the Y predict that we are going to get after the prediction. So we're almost done. After this, I'll print the accuracy as well, whatever we will get, and let's just print the weights and the coefficients as well. So let's just say weights is equal to reg dot. So you have a function for this as well to calculate the coefficient, that is the weights, and intercept as well. So I'll name it as intercept and reg dot intercept. We'll print these as well, weights and intercept. So our model is done, guys. So we have successfully used all these libraries. We have loaded the data set, and after that, we have generated the model by splitting the data and everything. So I'll just run this code and see what the output is. Okay, so we have the accuracy, that is a mean square error, that is 2004, and then we have the intercept and the weights as well. So this might sound a bit confusing for you guys. So I'll just add a few things over here to make you understand this better. So what I'll do is I'll make a few changes over here. So I'll just write it like np.new axis. I'll write it as 2 over here, and we'll plot the graph also. So for that, I'll just write plot scatter. Inside this, I'll use disease.xtest, disease.ytest, plt.plot for the line, and inside this, I'm going to use disease xtest and y predict. So now when I run my code, you will be able to see the graph which will have the data entries, and you'll be able to see the graph which has the data points, and there'll be an intercept as well with a line plotted, which is the best fit line over here. Okay, we have not written plt.show, that's why we're not getting the graph. Now it should be fine, and we'll be able to see the graph as well. So this is our best fit line, guys. So we have successfully implemented linear regression using Python for this disease data set. But to do this, I had to segregate this data all separately, and if you implement it using all the columns that you have in over here in the data, it's not going to be fine. I mean, it's going to throw you an error and will not show you a best fit line. So now that we are done with this one, I'll show you one more use case. Inside we are going to use the custom data set which has the car resale values. So let's get it done. So I'll just remove all this. So first of all, I will import, as you can see over here in the directory guys, you can already see this cars.csv. This is my custom data set that I'm going to use inside this one. So I'll just import numpy as np, import pandas. Because we are using a custom data set, I'm going to have to use pandas to import or to actually load the CSV file that I have over there. And after this, I'll use matplotlib.pyplot as plt, and from sklearn linear model, we are going to use linear regression. And after this, I'll just import sklearn.metrics and import the R2 score, or we're not going to use that, so I'll just remove this one for now, and we'll use import stats model. We'll leave this one for later as well. So first of all, I have to load the data, so I'm naming it as cars. So for this, I'll just write pd.read csv, and if you don't know how you can import the CSV files, the custom made CSV files inside your program, you can check out other tutorials on Edureka. So we have a tutorial in detail how you can read CSV files. So first of all, let me just get a quick exploration of the data what we have over here. So I'll just write the print statement. I'll get the head. So this is what my data set looks like guys. It's loading still. So we have all these values, and to get the better picture over here, I'll try to print the columns as well. So I'll just write cars.columns. So it will give me the name of all the columns that I have in this data set. Okay, so we have all these values, sales in thousands, we have a 4-year resale value, then we have price in thousands, and we have engine size, horsepower, wheelbase, width, length, then we have curb weight, we have fuel capacity, fuel efficiency as well. Okay, so this is what our data looks like guys. So let me just plot a graph first of all. So I'll just write plt, and we're going to use the figure size. For figure size is equal to, let's just say 16 by 8, and after this I will use a scatter plot, and inside this I'm going to give a few values. So I'm going to use cars. So first of all, I want to check the relationship between a horsepower, and then I'll check what is the relation between a horsepower and the price of the car, which is in thousands of course. And let's just get it as black. Yes, and let's just put a few labels as well. So X label is going to be, let's say, horsepower, and we will write the Y label as, let's just say, price. And let's just plot this graph for now. Okay, I'll put it over here only. Now when I run this, let's see what I'm getting over here. Okay, so I'm getting a graph like this. So you can see all the data points, and as we go further, the values are actually increasing. We're not getting the Y labels over here somehow. I think there's some problem. I'll just check it out. Okay, we leave it for now, and let's check the image of over here. So on the x-axis we have the horsepower, which is going until 450. So a car with the horsepower 450 is ranging around 70,000. That is the price, and that's going to be in dollars guys. And all these values, like a 150 horsepower car, it's going to be around 20,000 bucks, and a simple 50 horsepower car is going to be around 10,000 bucks. So this is our data guys. I think it's pretty evident that we have a relation between a horsepower and the price of the car that we are actually looking at right now. So we'll build a model around this for now. So I'll take one variable, let's just say X, and inside this I'm going to put cars horsepower, because we are going to take horsepower as our independent variable, and all these values I'm going to reshape them into -1 and 1. I'm going to take one more independent variable y. That's going to be my price in thousands, guys. I'm going to do the reshaping again. It's just basically to avoid the errors, guys. The reshaping that I'm doing over here. And I'll just generate my model right now. So I'll use linear regression. And after this, I'll try to fit my x and y over here using the fit method. So just write x and y. Now I'm going to print the coefficient using the coefficient function that I've shown you before. I'm going to take the values as 0 and 0. Again, for the same thing, I want the intercept as well. So instead of coefficient, I'll write as intercept, and I'll remove this one. After this, let's make one variable. Let's just say predictions. That's going to store the predicted value, and we're going to use the predict function over here. So I'm just going to put x over here in the predict function, and let's just plot a graph again. So I'll write figure size. Again, let's just take 16 by 8. We'll use the scatter plot again. We'll just write it again. So first of all, we have cars and horsepower. Then we have cars, price in thousands. After this, I'm just going to write C is equal to black. Now we have one more plot for the line, so I'm going to use plt.plot. Inside this, we'll have cars horsepower. We'll use the predictions as well, and let's just make it blue. We'll put the label again. So the X label is going to be the horsepower, and the Y label is going to be prices, or just price. I'll write plt.show. Now when I run this, I should be getting okay, we'll get the first plot before getting the second plot. So we have a plot like this. So actually the horsepower is over here, that is going up till 450 horsepower, and this is actually our price. Now when I close this, okay, I've made a mistake somewhere. Okay, this is actually, now when I run this again, it should be fine. I'll close this, and after this, okay, so I've got the mistake that I was making. So before running this program, I'll add the line width as well. And let's just run this again. So first I'm getting this, which is horsepower right here, and we have the price right over here. After this, let's see. So we have a best fit line over here, as you can see, guys. So this is a simple linear regression implementation on a custom data set.
So today we'll be discussing logistic regression. So let's move forward and understand the what and why of logistic regression. Now this algorithm is most widely used when the dependent variable, or you can say the output, is in the binary format. So here you need to predict the outcome of a categorical dependent variable. So the outcome should be always discrete or categorical in nature. Now by discrete, I mean the value should be binary, or you can say you just have two values. It can either be 0 or 1. It can either be yes or a no, either be true or false, or high or low. So only these can be the outcomes. So the value which you need to predict should be discrete, or you can say categorical in nature. Whereas in linear regression, we have the value of y, or you can say the value you need to predict is in a range. So that is how there is a difference between linear regression and logistic regression. Now you must be having a question, why not linear regression? Now guys, in linear regression, the value of y or the value which you need to predict is in a range. But in our case, as in the logistic regression, we just have two values. It can be either 0 or it can be 1. It should not entertain the values which is below 0 or above 1. But in linear regression, we have the value of y in the range. So here, in order to implement logistic regression, we need to clip this part. So we don't need the value that is below 0 or we don't need the value which is above 1. So since our value of y will be between only 0 and 1, that is the main rule of logistic regression, the linear line has to be clipped at 0 and 1. Now once we clip this graph, it would look somewhat like this. So here you are getting a curve which is nothing but 3 different straight lines. So here we need to make a new way to solve this problem. So this has to be formulated into an equation, and hence we come up with logistic regression. So here the outcome is either 0 or 1, which is the main rule of logistic regression. So with this, our resulting curve cannot be formulated. So hence our main aim to bring the values to 0 and 1 is fulfilled. So that is how we came up with logistic regression. Now here, once it gets formulated into an equation, it looks somewhat like this. So guys, this is nothing but a S curve, or you can say the sigmoid curve or sigmoid function curve. So this sigmoid function basically converts any value from minus infinity to infinity to your discrete values, which a logistic regression wants, or you can say the values which are in binary format, either 0 or 1. So if you see here, the values are either 0 or 1, and this is nothing but just the transition of it. But guys, there's a catch over here. So let's say I have a data point that is 0.8. Now how can you decide whether your value is 0 or 1? Now here you have the concept of threshold, which basically divides your line. So here threshold value basically indicates the probability of either winning or losing. So here by winning I mean the value is equals to 1, and by losing I mean the value is equals to 0. But how does it do that? Let's say I have a data point which is over here. Let's say my cursor is at 0.8. So here I'll check whether this value is less than my threshold value or not. Let's say if it is more than my threshold value, it should give me the result as 1. If it is less than that, then it should give me the result as 0. So here my threshold value is 0.5. Now I need to define that if my value, let's say 0.8, it is more than 0.5, then the value shall be rounded off to 1. And let's say if it is less than 0.5, let's say I have a value 0.2, then should reduce it to 0. So here you can use the concept of threshold value to find your output. So here it should be discrete, it should be either 0 or it should be 1. So I hope you caught this curve of logistic regression. So guys, this is the sigmoid S curve. So to make this curve, we need to make an equation. So let me address that part as well. So let's see how an equation is formed to imitate this functionality. So over here we have an equation of a straight line, which is y is equals to mx plus c. So in this case, I just have only one independent variable. But let's say if we have many independent variables, then the equation becomes m1x1 plus m2x2 plus m3x3 and so on till mn(xn). Now let us put in b and x. So here the equation becomes y is equals to b1x1 plus b2x2 plus b3x3 and so on till bn(xn) plus c. So guys, your equation of the straight line has a range from minus infinity to infinity. But in our case, or you can say in logistic equation, the value which we need to predict, or you can say the y value, it can have the range only from 0 to 1. So in that case, we need to transform this equation. So to do that, what we had done, we have just divided the equation by 1 minus y. So now if y is equals to 0, so 0 over 1 minus 0 which is equals to 1. So 0 over 1 is again 0. And if we take y is equals to 1, then 1 over 1 minus 1 which is 0. So 1 over 0 is infinity. So here my range is now between 0 to infinity. But again we want the range from minus infinity to infinity. So for that what we'll do, we'll have the log of this equation. So let's go ahead and have the logarithmic of this equation. So here we have just transform it further to get the range between minus infinity to infinity. So over here we have log of y over 1 minus 1, and this is your final logistic regression equation. So guys, don't worry, you don't have to write this formula or memorize this formula. In Python, you just need to call this function which is logistic regression and everything will be automatically for you. So I don't want to scare you with the maths and the formulas behind it, but it's always good to know how this formula was generated. Next, let us see what are the major differences between linear regression versus logistic regression. Now, first of all, in linear regression, we have the value of y as a continuous variable, or the variable which we need to predict are continuous in nature. Whereas in logistic regression, we have the categorical variable. So here the value which you need to predict should be discrete in nature. It should be either 0 or 1, or it should have just two values to it. So for example, whether it is raining or it is not raining. Is it humid outside or it is not humid outside? Now, does it going to snow or it is not going to snow? So these are the few examples where you need to predict where the values are discrete, or you can just predict whether this is happening or not. Next, linear regression solves your regression problems. So here you have a concept of independent variable and a dependent variable. So here you can calculate the value of y which you need to predict using the value of x. So here your y variable, or you can say the value that you need to predict, are in a range. But whereas in logistic regression you have discrete values. So logistic regression basically solves your classification problem. So it can basically classify it and it can just give you result whether this event is happening or not. Next, in linear regression, the graph that you have seen is a straight line graph. So over here you can calculate the value of y with respect to the value of x. Whereas in logistic regression, the curve that we got was a S curve, or you can say the sigmoid curve. So using the sigmoid function, you can predict your y values. Moving ahead, let us see the various use cases wherein logistic regression is implemented in real life. So the very first is weather prediction. Now, logistic regression helps you to predict your weather. For example, it is used to predict whether it is raining or not, whether it is sunny, is it cloudy or not. So all these things can be predicted using logistic regression. Whereas you need to keep in mind that both linear regression and logistic regression can be used in predicting the weather. So in that case, linear regression helps you to predict what will be the temperature tomorrow. Whereas logistic regression will only tell you whether it's going to rain or not, or whether it's cloudy or not, whether it's going to snow or not. So these values are discrete. Whereas if you apply linear regression, you'll be predicting things like what is the temperature tomorrow, or what is the temperature day after tomorrow, and all those things. So these are the slight differences between linear regression and logistic regression. Now moving ahead, we have classification problem. So Python performs multi-class classification. So here it can help you tell whether it's a bird or it's not a bird. Then you can classify different kind of mammals. Let's say whether it's a dog or it's not a dog. Similarly, you can check it for reptile, whether it's a reptile or not a reptile. So in logistic regression, it can perform multi-class classification. So this point I have already discussed that it is used in classification problems. Next, it also helps you to determine the illness as well. So let me take an example. Let's say a patient goes for a routine checkup in a hospital. So what doctor will do, it will perform various tests on the patient and will check whether the patient is actually ill or not. So what will be the features? So doctor can check the sugar level, the blood pressure, then what is the age of the patient, is it very small or is it an old person, then what is the previous medical history of that patient, and all of these features will be recorded by the doctor. And finally, doctor checks the patient data and determines the outcome of an illness and the severity of illness. So using all the data, a doctor can identify whether a patient is ill or not. So these are the various use cases in which you can use logistic regression. Now I guess enough of theory part, so let's move ahead and see some of the practical implementation of logistic regression. So over here I'll be implementing two projects wherein I have the data set of a Titanic. So over here we'll predict what factors made people more likely to survive the sinking of the Titanic ship. And in my second project, we'll see the data analysis on the SUV cars. So over here we have the data of the SUV cars, who can purchase it, and what factors made people more interested in buying SUV. So these will be the major questions as to why you should implement logistic regression and what output will you get by it. So let's start by the very first project, that is Titanic data analysis. So some of you might know that there was a ship called as Titanic which basically hit an iceberg and it sunk to the bottom of the ocean. And it was a big disaster at that time because it was the first voyage of the ship and it was supposed to be really strongly built and one of the best ships of that time. So it was a big disaster of that time, and of course there is a movie about this as well. So many of you might have watched it. So what we have data of the passengers, those who survived and those who did not survive in this particular tragedy. So what you have to do, you have to look at this data and analyze which factors would have been contributed the most to the chances of a person's survival on the ship or not. So using the logistic regression, we can predict whether the person survived or the person died. Now, apart from this, we'll also have a look with the various features along with that. So first, let us explore the data set. So over here, we have the index value. Then the first column is passenger ID. Then my next column is survived. So over here, we have two values, a 0 and a 1. So 0 stands for did not survive and 1 stands for survive. So this column is categorical where the values are discrete. Next, we have passenger class. So over here, we have three values, 1, 2, and 3. So this basically tells you that whether a passenger is traveling in the first class, second class, or third class. Then we have the name of the passenger, we have the sex or you can say the gender of the passenger, whether passenger is a male or female. Then we have the age, we have the 𝐓𝐵. So this basically means the number of siblings or the spouses aboard the Titanic. So over here we have values such as 1, 0 and so on. Then we have patch. So patch is basically the number of parents or children aboard the Titanic. So over here we also have some values. Then we have the ticket number, we have the fare, we have the cabin number, and we have the embarked column. So in my embarked column, we have three values. We have S, C, and Q. So S basically stands for Southampton, C stands for Cherbourg, and Q stands for Queenstown. So these are the features that we'll be applying our model on. So here we'll perform various steps and then we'll be implementing logistic regression. So now these are the various steps which are required to implement any algorithm. So now in our case we are implementing logistic regression. So our very first step is to collect your data or to import the libraries that are used for collecting your data and then taking it forward. Then my second step is to analyze your data. So over here I can go through the various fields and then I can analyze the data. I can check, did the females or children survive better than the males, or did the rich passenger survive more than the poor passenger, or did the money matter, as in who paid more to get into the ship, were they evacuated first, and what about the workers, does the worker survived, or what is the survival rate if you were the worker in the ship and not just a traveling passenger. So all of these are very interesting questions and you would be going through all of them one by one. So in this stage you need to analyze your data and explore your data as much as you can. Then my third step is to wrangle your data. Now data wrangling basically means cleaning your data. So over here you can simply remove the unnecessary items, or if you have a null values in the data set, you can just clear that data and then you can take it forward. So in this step you can build your model using the trained data set and then you can test it using the test. So over here you will be performing a split, which basically split your data set into training and testing data set. And finally you will check the accuracy so as to ensure how much accurate your values are. So now let's go into all these steps in detail. So number one, we have to collect your data, or you can say import the libraries. So let me just show you the implementation part as well. So I'll just open my Jupyter notebook and I'll just implement all of these steps side by side. So guys, this is my Jupyter notebook. So first let me just rename the Jupyter notebook to, let's say, Titanic data analysis. Now our first step was to import all the libraries and collect the data. So let me just import all the libraries first. So first of all, I'll import pandas. So pandas is used for data analysis. So I'll say import pandas as PD. Then I'll be importing numpy. So I'll say import numpy as NP. So numpy is a library in Python which basically stands for numerical Python, and it is widely used to perform any scientific computation. Next we'll be importing seaborn. So seaborn is a library for statistical plotting. So I'll say import seaborn as SNS. I'll also import matplotlib. So matplotlib library is again for plotting. So I'll say import matplotlib.pyplot as PLT. Now to run this library in Jupyter Notebook, all I have to write in is %matplotlib inline. Next I'll be importing one module as well, so as to calculate the basic mathematical functions. So I'll say import maths. So these are the libraries that I'll be needing in this Titanic data analysis. So now let me just import my data set. So I'll take a variable, let's say Titanic data, and using the pandas, I will just read my CSV, or you can say the data set. I'll write the name of my data set, that is titanic.csv. Now I have already showed you the data set. So over here, let me just print the top 10 rows. So for that, I'll just say, I'll take the variable Titanic data dot head and I'll say the top 10 rows. So now I'll just run this. So to run this, so I just have to press Shift plus Enter, or else you can just directly click on this cell. So over here I have the index, we have the passenger ID, which is nothing but again the index which is starting from 1. Then we have the survived column, which has the categorical values, or you can say the discrete values, which is in the form of 0 or 1. Then we have the passenger class, we have the name of the passenger, sex, age, and so on. So this is the dataset that I'll be going forward with. Next, let us print the number of passengers which are there in this original dataset. So for that, I'll just simply type in print. I'll say number of passengers. And using the length function, I can calculate the total length. So I'll say length, and inside this, I'll be passing this variable, which is Titanic data. So I'll just copy it from here. I'll just paste it, dot index. And next, so let me just print this one. So here the number of passengers which are there in the original data set we have is 891. So around this number were traveling in the Titanic ship. So over here, my first step is done, where you have just collected data, imported all the libraries, and find out the total number of passengers which are traveling in Titanic. So now let me just go back to presentation and let's see what is my next step. So we're done with the collecting data. Next step is to analyze your data. So over here, we'll be creating different plots to check the relationship between variables, as in how one variable is affecting the other. So you can simply explore your dataset by making use of various columns, and then you can plot a graph between them. So you can either plot a correlation graph, you can plot a distribution graph. It's up to you guys. So let me just go back to my Jupyter notebook and let me analyze some of the data. Over here, my second part is to analyze data. So I just put this in header 2. Now to put this in header 2, I just have to go on code, click on markdown, and I'll just run this. So first let us plot a count plot, where you compare between the passengers who survived and who did not survive. So for that, I'll be using the 𝐶born library. So over here, I have imported 𝐶born as SNS. So I don't have to write the whole name. I'll simply say sns.countplot. I'll say X is who survived. And the data that I'll be using is the Titanic data. Or you can say the name of variable in which you have stored your data set. So now let me just run this. So over here, as you can see, I have survived column on my x-axis, and on the y-axis, I have the count. So 0 basically stands for did not survive, and 1 stands for the passengers who did survive. So over here, you can see that around 550 of the passengers who did not survive, and there were around 350 passengers who only survived. So here you can basically conclude that there are very less survivors than non-survivors. So this was the very first plot. Now let us plot another plot to compare the sex as to whether out of all the passengers who survived and who did not survive, how many were men and how many were female. So to do that, I'll simply say sns.countplot. I'll add the hue as sex. So I want to know how many females and how many males survived. Then I'll be specifying the data. So I'm using Titanic data set. And let me just run this. Okay, I've done a mistake over here. So over here you can see I have survived column on the x-axis and I have the count on the y. Now, so here your blue color stands for your male passengers and orange stands for your female. So as you can see here, the passengers who did not survive, that has a value 0. So we can see that majority of males did not survive. And if we see the people who survived, here we can see the majority of females survived. So this basically concludes the gender of the survival rate. So it appears on average women were more than 3 times more likely to survive than men. Next, let us plot another plot where we have the hue as the passenger class. So over here we can see which class that the passenger was traveling in, whether it was traveling in class 1, 2 or 3. So for that, I'll just write the same command. I'll say sns.countplot. I'll keep my x-axis as subject only. I'll change my hue to passenger class. So my variable is named as P class. And the data set that I'll be using is Titanic data. So this is my result. So over here you can see I have blue for first class, orange for second class, and green for the third class. So here the passengers who did not survive were majorly of the third class, or you can say the lowest class or the cheapest class to get into the Titanic. And the people who did survive majorly belong to the higher classes. So here 1 and 2 has more rise than the passenger who were traveling in the third class. So here we have concluded that the passengers who did not survive were majorly of third class, or you can say the lowest class. And the passengers who were traveling in first and second class would tend to survive more. Next, let us plot a graph for the age distribution. Over here, I can simply use my data. So we'll be using pandas library for this. I'll declare an array and I'll pass in the column that is age. So I plot and I want a histogram. So I'll say plot.hist. So you can notice over here that we have more of young passengers, or you can say the children between the ages 0 to 10. And then we have the average age people. And if you go ahead, lesser would be the population. So this is the analysis on the age column. So we saw that we have more young passengers and more mediocre age passengers which are traveling in the Titanic. So next, let me plot a graph of fare as well. So I'll say Titanic data. I'll say fare. And again, I'll plot a histogram. So I'll say hist. So here you can see the fare size is between 0 to 100. Now let me add the bin size so as to make it more clear. So over here, I'll say bin is equals to, let's say 20. And I'll increase the figure size as well. So I'll say fig size. Let's say I'll give the dimensions as 10 by 5. Okay, so it is bins. So this is more clear now. Next, let us analyze the other columns as well. So I'll just type in Titanic data. And I want the information as to what all columns are left. So here we have passenger ID, which I guess it's of no use. Then we have see how many passengers survived and how many did not. We also see the analysis on the gender basis. We saw whether female tend to survive more or the men tend to survive more. Then we saw the passenger class, whether passenger is traveling in the first class, second class, or third class. Then we have the name. So in name we cannot do any analysis. We saw the sex, we saw the age as well. Then we have SIB-SP. So this stands for the number of siblings or the spouses which are aboard the Titanic. So let us do this as well. So I'll say sns.countplot. I'll mention X as SIB-SP. And I'll be using the Titanic data. So you can see the plot over here. So over here you can conclude that it has the maximum value on 0. So you can conclude that neither a children nor a spouse was on board the Titanic. Now second most highest value is 1. And then we have very less values for 2, 3, 4 and so on. Next, if I go above, we saw this column as well. Similarly, you can do for Parj. So next we have Parj, or you can say the number of parents or children which were aboard the Titanic. So similarly, you can do this as well. Then we have the ticket number. So I don't think so any analysis is required for ticket. Then we have fare. So fare we have already discussed. As in the people who tend to travel in the first class usually pay the highest fare. Then we have the cabin number and we have embarked. So these are the columns that we'll be doing data wrangling on. So we have analyzed the data and we have seen quite a few graphs in which we can conclude which variable is better than the another or what is the relationship they hold. So third step is my data wrangling. So data wrangling basically means cleaning your data. So if you have a large data set, you might be having some null values or you can say NaN values. So it's very important that you remove all the unnecessary items that are present in your data set. So removing this directly affects your accuracy. So I'll just go ahead and clean my data by removing all the NaN values and unnecessary columns which has a null value in the data set. So next I'll be performing data wrangling. So first of all, I'll check whether my data set is null or not. So I'll say Titanic data, which is the name of my data set, and I'll say is null. So this will basically tell me what all values are null and it will return me a Boolean result. So this basically checks the missing data and your result will be in Boolean format, as in the result will be true or false. So false means if it is not null and true means if it is null. So let me just run this. Over here you can see the values as false or true. So false is where the value is not null and true is where the value is null. So over here you can see in the cabin column we have the very first value which is null. So we have to do something on this. So you can see that we have a large data set. So the counting does not stop and we can actually see the sum of it. We can actually print the number of passengers who have the NaN value in each column. So I'll say Titanic underscore data is null and I want the sum of it. So I'll say dot sum. So this will basically print the number of passengers who have the NaN values in each column. So we can see that we have missing values in each column, that is 177. Then we have the maximum value in the cabin column. And we have very less in the embarked column, that is 2. So here if you don't want to see these numbers, you can also plot a heat map and then you can visually analyze it. So let me just do that as well. So I'll say sns.heatmap. I'll say white tick labels to false. So I'll just run this. So as we have already seen that there were 3 columns in which missing data value was present. So this might be age. So over here almost 20% of age column has a missing value. Then we have the cabin columns. So this is quite a large value. And then we have 2 values for embarked column as well. Add a CMap for color coding. So I'll say CMap. So if I do this, so the graph becomes more attractive. So over here your yellow stands for true or you can say the values are null. So here we have concluded that we have the missing value of age. We have a lot of missing values in the cabin column and we have very less value which is not even visible in the embarked column as well. So to remove these missing values, you can either replace the values and you can put in some dummy values to it or you can simply drop the column. So here let us first pick the age column. So first let me just plot a box plot and they will analyze with having a column as age. So I'll say sns.boxplot. I'll say X is equals to passenger class. So it's P class. I'll say Y is equals to age. And the data set that I'll be using is Titanic set. So I'll say data is equals to Titanic data. You can see the age in first class and second class tends to be more older rather than we have it in the third class. Well, that depends on the experience, how much you earn. or might be there n number of reasons. So here we concluded that passengers who were traveling in class 1 and class 2 tend to be older than what we have in the class 3. So we have found that we have some missing values in M. Now one way is to either just drop the column or you can just simply fill in some values to that. So this method is called as imputation. Now to perform data wrangling or cleaning, let us first print the head of the data set. So I'll say Titanic.head, it's Titanic underscore data. Let's say I just want the 5 rows. So here we have survive, which is again categorical. So in this particular column, I can apply logistic regression. So this can be my Y value or the value that I need to predict. Then we have the passenger class, we have the name, then we have ticket number, fare, cabin. So over here we have seen that in cabin we have a lot of null values, or you can say the NaN values, which is quite visible as well. So first of all, we'll just drop this column. So for dropping it, I'll just say Titanic underscore data, and I'll simply type in drop and the column which I need to drop. So I have to drop the cabin column. I'll mention the axis equals to 1, and I'll say in place also to true. So now again, I'll just print the head and let us see whether this column has been removed from the data set or not. So I'll say Titanic.head. So as you can see here, we don't have cabin column anymore. Now you can also drop the NA values. So I'll say Titanic data.drop all the NA values, or you can say NaN, which is not a number. And I'll say in place is equals to true. It's Titanic. So over here, let me again plot the heat map, and let's say what the values which were before showing a lot of null values, has it been removed or not. So I'll say sns.heatmap, I'll pass in the data set. I'll check it is null. I'll say y-tick labels is equals to false. And I don't want color coding, so again I'll say false. So this will basically help me to check whether my values has been removed from the data set or not. So as you can see here, I don't have any null values. So it's entirely black. Now you can actually know the sum as well. So I'll just go above. So I'll just copy this part and I just use the sum function to calculate the sum. So here that tells me that data set is clean, as in the data set does not contain any null value or any NaN value. So now we have wrangled our data, or you can say clean our data. So here we have done just one step in data wrangling, that is just removing one column out of it. Now you can do a lot of things. You can actually fill in the values with some other values, or you can just calculate the mean and then you can just fit in the null values. But now if I see my data set, so I'll say Titanic data.head. But now if I see over here, I have a lot of string values. So this has to be converted to categorical variables in order to implement logistic regression. So what we will do, we will convert this to categorical variable into some dummy variables, and this can be done using pandas, because logistic regression just take two values. So whenever you apply machine learning, you need to make sure that there are no string values present, because it won't be taking these as your input variables. So using string, you don't have to predict anything. But in my case, I have the survived column, so I need to predict how many people tend to survive and how many did not. So 0 stands for did not survive and 1 stands for survive. So now let me just convert these variables into dummy variables. So I'll just use pandas and I'll say pd.getDummies. You can simply press tab to autocomplete. I'll say Titanic data and I'll pass the sex. So you can just simply click on shift plus tab to get more information on this. So here we have the type data frame and we have the passenger ID, survived, and the passenger class. So if you run this, you'll see that 0 basically stands for not a female and 1 stands for it is a female. Similarly for male, 0 stands for it's not male and 1 stands for male. Now we don't require both these columns, because one column itself is enough to tell us whether it's male or you can say female or not. So let's say if I want to keep only male, now I'll say if the value of male is 1, so it is definitely a male and it is not a female. So that is how you don't need both of these values. So for that, I'll just remove the first column, let's say female. So I'll say drop first and true. So over here it has given me just one column which is male and has the value 0 and 1. Now let me just set this as a variable, let's say sex. So over here I can say sex.head. I'll just want to see the first 5 rows. Sorry, it's dot. So this is how my data looks like. Now here we have done it for sex. Then we have the numerical values in age. We have the numerical values in spouses. Then we have the ticket number, we have the fare, and we have embarked as well. So in embarked, the values are in S, C, and Q. So here also we can apply this get dummy function. So let's say I'll take a variable, let's say embark. I'll use the pandas library. I'll enter the column name, that is embarked. So let me just print the head of it. So I'll say embark.head. So over here we have C, Q and S. Now here also we can drop the first column because these two values are enough whether the passenger is either traveling for Q, that is Queenstown, S for Southampton, and if both the values are 0, then definitely the passenger is from Cherbourg, that is the third value. So you can again drop the first value. So I'll say drop and true. Let me just run this. So this is how my output looks like. Now similarly you can do it for passenger class as well. So here also we have three classes, 1, 2 and 3. So I'll just copy the whole statement. So let's say I want the variable name, let's say PCL. I'll pass in the column name, that is P class, and I'll just drop the first column. So here also the values would be 1, 2 or 3, and I'll just remove the first column. So here we just left with 2 and 3. So if both the values are 0, then definitely the passenger is traveling in the first class. Now we have made the values as categorical. Now my next step would be to concatenate all these new rows into a data set. Or you can say Titanic data. Using the pandas, we'll just concatenate all these columns. So I'll say p.concat, and I'll say we have to concatenate sex, we have to concatenate embark and PCL. And then I'll mention the access to 1. And I'll just run this. Okay, I need to print the head. So over here you can see that these columns have been added over here. So we have the male column, which basically tells whether a person is male or it's a female. Then we have the embark, which is basically Q and S. So if it's traveling from Queenstown, the value would be 1, else it would be 0. And if both of these values are 0, it is definitely traveling from Cherbourg. Then we have the passenger class as 2 and 3. So if the value of both these is 0, then the passenger is traveling in class 1. So I hope you got this till now. Now these are the irrelevant columns that we have it over here. So we can just drop these columns. We'll dropping P class, the embarked column, and the sex column. So I'll just type in Titanic data dot drop, and I'll mention the columns that I want to drop. So I'll say I'll even delete the passenger ID because it's nothing but just the index value which is starting from 1. So I'll drop this as well. Then I don't want name as well, so I'll delete name as well. Then what else we can drop? We can drop the ticket as well. And then I'll just mention the access, and I'll say in place is equals to true. Okay, so my column name starts from uppercase. So these has been dropped. Now let me just print my data set again. So this is my final data set, guys. We have the survived column which has the value 0 and 1. Then we have the passenger class. Oh, we forgot to drop this as well. So no worries, I'll drop this again. So now let me just run this. So over here we have the survived, we have the age, we have the SIB SP, we have the parch, we have fair, male, and these we have just converted. So here we have just performed data wrangling, or you can say clean the data, and then we have just converted the values of gender to male, then embark to Q and S, and the passenger class to 2 and 3. So this was all about my data wrangling or just cleaning the data. Then my next step is training and testing your data. So here we will split the dataset into train subset and test subset. And then what we'll do, we'll build a model on the trained data and then predict the output on your test dataset. So let me just go back to Jupyter and let us implement this as well. Over here, I need to train my dataset. So I'll just put this in heading 3. So over here, you need to define your dependent variable and independent variable. So here my y is the output, or you can say the value that I need to predict. So over here, I'll write Titanic data. I'll take the column which is survived. So basically, I have to predict this column whether the passenger survived or not. And as you can see, we have the discrete outcome, which is in the form of 0 and 1. And rest all the things, we can take it as a features, or you can say independent variable. So I'll say Titanic data dot drop. So we'll just simply drop this survived, and all the other columns will be my independent variable. So everything else are the features which leads to the survival rate. So once we have defined the independent variable and the dependent variable, next step is to split your data into training and testing subset. So for that, we'll be using sklearn. I'll just type in from sklearn.cross-validation, import train test split. Now here, if you just click on Shift and Tab, you can go to the documentation and you can just see the examples over here. I'll click on plus to open it, and then I just go to examples and see how you can split your data. So over here you have xtrain, xtest, ytrain, ytest. And then using this train test split, you can just pass in your independent variable and dependent variable and just define a size and a random state to it. So let me just copy this and I'll just paste it over here. Over here we'll train, test, then we have the dependent variable train and test, and using the split function we'll pass in the independent and dependent variable, and then we'll set a split size. So let's say I'll put it at 0.3. So this basically means that your data set is divided in 0.3, that is in 70-30 ratio, and then I can add any random state to it. So let's say I'm applying 1. This is not necessary. If you want the same result as that of mine, you can add the random state. So this will basically take exactly the same sample every time. Next, I have to train and predict by creating a model. So here logistic regression will grab from the linear regression. So next I'll just type in from sklearn.linear model, import logistic regression. Next I'll just create the instance of this logistic regression model. So I'll say log model is equals to logistic regression. Now I just need to fit my model, so I'll say log model dot fit, and I'll just pass in my xtrain and ytrain. Alright, so here it gives me all the details of logistic regression. So here it gives me the class weight, dual, fit, intercept, and all those things. Then what I need to do, I need to make prediction. So I'll take a variable, let's say predictions, and I'll pass on the model to it. So I'll say log model dot predict, and I'll pass in the value that is xtest. So here we have just created a model, fit that model, and then we had made predictions. So now to evaluate how my model has been performing, so you can simply calculate the accuracy, or you can also calculate a classification report. So don't worry guys, I'll be showing both of these methods. So I'll say from sklearn.metrics, import classification report. So over here I'll use classification report, and inside this I'll be passing in ytest and the predictions. So guys, this is my classification report. So over here I have the precision, I have the recall, we have the F1 score, and then we have support. So here we have the value of precision as 75, 72, and 73, which is not that bad. Now, in order to calculate the accuracy as well, you can also use the concept of confusion matrix. So if you want to print the confusion matrix, I'll simply say from sklearn.metrics, import confusion matrix first of all, and then we'll just print this. So here my function has been imported successfully. So I'll say confusion matrix, and I'll again pass in the same variables, which is ytest and predictions. So I hope you guys already know the concept of confusion matrix. So can you guys give me a quick confirmation as to whether you guys remember this confusion matrix concept or not? So if not, I can just quickly summarize this as well. Okay, Jagriti says a yes. Okay, Swati is not clear with this. So I'll just tell you in a brief what confusion matrix is all about. So confusion matrix is nothing but a 2 by 2 matrix which has 4 outcomes. This basically tells us that how accurate your values are. So here we have the column as predicted no, predicted y, and we have actual no and an actual yes. So this is the concept of confusion matrix. So here let me just feed in these values which we have just calculated. So here we have 105, 21, 25, and 63. So as you can see here, we have got 4 outcomes. Now 105 is the value where a model has predicted no, and in reality it was also a no. So here we have predicted no and an actual no. Similarly, we have 63 as a predicted yes. So here the model predicted yes, and actually also it was a yes. So in order to calculate the accuracy, you just need to add the sum of these two values and just divide the whole by the sum. So here these two values tells me where the model has actually predicted the correct output. So this value is also called as true negative. This is called as false positive. This is called as true positive, and this is called as false negative. Now in order to calculate the accuracy, you don't have to do it manually. So in Python, you can just import accuracy score function and you can get the results from that. So I'll just do that as well. So I'll say from sklearn.metrics, import accuracy score, and I'll simply print the accuracy. And I'll pass in the same variables, that is ytest and predictions. So over here it tells me the accuracy as 78, which is quite good. So over here, if you want to do it manually, you have to plus these two numbers, which is 105 plus 63. So this comes out to almost 168. And then you have to divide it by the sum of all the four numbers. So 105 plus 63 plus 21 plus 25. So this gives me a result of 214. So now if you divide these two numbers, you'll get the same accuracy, that is 78%, or you can say 0.78. So that is how you can calculate the accuracy. So now let me just go back to my presentation and let's see what all we have covered till now. So here we have first split our data into train and test subset. Then we have built our model on the train data and then predicted the output on the test data set. And then my fifth step is to check the accuracy. So here we have calculated accuracy to almost 78%, which is quite good. You cannot say that accuracy is bad. So here it tells me how accurate your results are. So here my accuracy score defines that, and hence we got a good accuracy. So now moving ahead, let us see the second project, that is SUV data analysis. So in this, a car company has released new SUV in the market, and using the previous data about the sales of their SUV, they want to predict the category of people who might be interested in buying this. So using the logistic regression, you need to find what factors made people more interested in buying this SUV. So for this, let us see a data set where I have user ID, I have gender as male and female, then we have the age, we have the estimated salary, and then we have the purchased column. So this is my discrete column, or you can say the categorical column. So here we just have the value, that is 0 and 1. And this column we need to predict whether a person can actually purchase a SUV or not. So based on these factors, we will be deciding whether a person can actually purchase a SUV or not. So we know the salary of a person, we know the age. And using these, we can predict whether a person can actually purchase a SUV or not. So let me just go to my Jupyter notebook and let us implement logistic regression. So guys, I will not be going through all the details of data cleaning and analyzing the part. So that part, I'll just leave it on you. So just go ahead and practice as much as you can. Alright. So my second project is SUV predictions. Alright. So first of all, I have to import all the libraries. So I say import numpy as np. And similarly, I'll do the rest of it. Alright. So now let me just print the head of this data set. So this we've already seen that we have columns as user ID, we have gender, we have the age, we have the salary, and then we have to calculate whether the person can actually purchase a SUV or not. So now let us just simply go on to the algorithm part. So we'll directly start off with the logistic regression, or how you can train a model. So for doing all those things, we first need to define your independent variable and a dependent variable. So in this case, I want my x, that is an independent variable. I say dataset.iloc. So here I'll be specifying all the rows. So colon basically stands for that. And in the columns, I want only 2 and 3 dot values. So here it should fetch me all the rows and only the second and third column, which is age and estimated salary. So these are the factors which will be used to predict the dependent variable, that is purchase. So here my dependent variable is purchase. And the dependent variable is of age and salary. So I'll say dataset.iloc. I'll have all the rows and I just want fourth column, that is my purchased column, dot values. Alright, so I've just forgot one square bracket over here. Alright. So over here I have defined my independent variable and dependent variable. So here my independent variable is age and salary, and dependent variable is the column purchase. Now you must be wondering, what is this iloc function? So iloc function is basically an indexer for pandas data frame, and it is used for integer based indexing, or you can also say selection by index. Now let me just print these independent variables and dependent variable. So if I print the independent variable, I have the age as well as the salary. Next, let me print the dependent variable as well. So over here you can see I just have the values in 0 and 1. So 0 stands for did not purchase. Next, let me just divide my dataset into training and test subset. So I'll simply write in from sklearn.crosssplit.crossvalidation import train test. Next, I'll just press shift and tab, and over here I'll go to the examples and just copy the same line. So I'll just copy this. I'll remove the points. Now I want the text size to be, let's say, 25. So I have divided the train and test split in 75-25 ratio. Now let's say I'll take the random state as 0. So random state basically ensures the same result, or you can say the same samples taken whenever you run the code. So let me just run this. Now you can also scale your input values for better performing, and this can be done using standard scaler. So let me do that as well. So I'll say from sklearn.preprocessing import standard scaler. Now why do we scale it? Now if you see our data set, we are dealing with large numbers. Well, although we are using a very small data set, so whenever you're working in a prod environment, you'll be working with large data set where you'll be using thousands and hundred thousands of tuples. So their scaling down will definitely affect the performance by a large extent. So here let me just show you how you can scale down these input values. And then the pre-processing contains all your methods and functionality which is required to transform your data. So now let us scale down for test as well as your training data set. So I'll first make an instance of it. So I'll say standard scaler. Then I'll have xtrain. I'll say sc.fit, fit underscore transform. And I'll pass in my xtrain variable. And similarly, I can do it for test, wherein I'll pass the xtest. Alright. Now my next step is to import logistic regression. So I'll simply apply logistic regression by first importing it. So I'll say from sklearn.linear model import logistic regression. Now over here I'll be using classifier. So I'll say classifier dot is equals to logistic regression. So over here I'll just make an instance of it. So I'll say logistic regression. And over here I just pass in the random state which is 0. And now I'll simply fit the model. And I simply pass in xtrain and ytrain. So here it tells me all the details of logistic regression. Then I have to predict the value. So I'll say ypred is equals to classifier, then predict function, and then I just pass in xtest. So now we have created the model, we have scaled down our input values, then we have applied logistic regression, we have predicted the values, and now we want to know the accuracy. So to know the accuracy, first we need to import accuracy score. So I'll say from sklearn.metrics import accuracy score, and using this function we can calculate the accuracy, or you can manually do that by creating a confusion matrix. So I'll just pass in my y test and my y predicted. Alright, so over here I get the accuracy as 89%. So if we want to know the accuracy in percentage, so I just have to multiply it by 100, and if I run this, so it gives me 89%. So here I have taken my independent variables as age and salary, and then we have calculated that how many people can purchase the SUV, and then we have calculated our model by checking the accuracy. So over here we get the accuracy as 89, which is great.
So what is classification? And if I have to tell you about classification, like for example, what happens is like we have two type of, when we talk about machine learning is nothing but, you know, like a series of instructions you give it to the computer so that it can learn the patterns from your data set, right? To give you an example, imagine that there is a trending topic. For example, you want to find it out whether Prime Minister Modi will be the second Prime Minister, once again the Prime Minister for the country or not. Okay, so now what you will do is you will collect the data set from multiple different sources, and you will actually build it like a algorithm where you will get a label as yes or no. Yes, he will continue as the next prime minister, or no, he will not continue as a next prime minister. So you will collect the data set and you will feed this data set to the computer, and this process is called as a machine learning, right? So now in this case, what happens is so this is about the classification, right? So now machine learning is basically of two types. One is called as a supervised machine learning, another is called as a unsupervised machine learning, and the third one is a reinforcement machine learning. So when we speak about supervised machine learning, as the name suggests, it provides some supervision, right? For example, the teacher teaching the kid, it's a supervised machine learning, right? So we will give the trained examples, we will give the trained data set with the pure label on top of that. This is called as a supervised machine learning. So if I draw in front of you, this type of machine learning look like this, supervised machine learning, where what happens is like you would have the data set, which is a structured data set, and you would have one column which is called as a label, what you want to predict. Okay, and you would have a various predictors by which you want to predict. to give you an example, imagine that you want to predict a pricing of a community. Okay, you want to predict what would be the pricing of apartment in a particular community, right? Now this can be the variable, like you can see that what would be the number of how many floors it has. You can have a variable like what is a pollution level, how many educational institutions are nearby, right? So based upon that, the pricing will change. But this type of supervised machine learning, why it is called supervised machine learning? Because we provide the independent variable, or we provide the predictors, also we provide the label data set. Okay, now this supervised machine learning is basically of two types. So this supervised machine learning, one first is called as the regression based supervised machine learning. Okay, and the second one is called as a classification based supervised machine learning. Now, what is the difference between regression based and a classification based supervised machine learning? Regression based supervised machine learning is that machine learning where what you want to predict is continuous in nature. Okay, imagine you want to predict the community prices, right, which is a continuous value. If it is a continuous value, then we will go ahead with regression based supervised machine learning. Okay, whereas if you want to predict something which is the discrete outcome, to give you an example, you want to predict that whether I will win the match or not. Okay, I want to predict whether the particular employee will churn out from the company or not. You want to predict, like whether the person will have a cancer or not. You're getting my point, right? So if you have the output which you want to predict is in the form of yes or no, or true or false, right? This is called as the supervised machine learning, but a classification based supervised machine learning. Okay, so classifications based supervised machine learning is the process of dividing the data set into different categories or group by adding a label. Okay, so always remember that whenever you guys want to predict the classes in the data set, whenever you want to predict, like whether this will happen or not, whether a person will do a credit card fraud or not. You're getting my point, right? Whether the employee will churn out from the company or not, right? Whether the particular person will have a diabetes as a disease or not. All these questions, wherever you want to find it out, yes or no, or true or false, or you want to predict classes in the data set, this is called as a classification based supervised machine learning. Okay, so this is what is called as a classification based supervised machine learning. And today I will teach you, I will tell you about various form of classification based supervised machine learning, although we will do a deep dive into decision tree. Right now you will be able to understand that decision tree, how decision tree is connected to the network, what we are learning today with classification based supervised machine learning. Okay, so now we have various algorithms. Algorithm is nothing but a set of mathematical equations for classification based supervised machine learning. We first of all we have something called as decision tree, then we would have something called as random forest, then knife base, and then KNN, which is called as a k nearest neighbors. Okay, so let me give you few statements about this algorithm, and we have many others, but today we will focus on one of them, which is decision tree. So now first let's start with decision tree. Now what is a decision tree? What I was telling you is, believe me or not, decision tree is something you use every day in your daily life. For example, you take decisions, and today also you took a decision to attend this webinar, right? But how do you decide a decision? Based on various further decisions, right? For example, for today joining the webinar, you have seen that, okay, when this webinar is about, okay, so you said it is weekday or weekend, then you might have said check it out, right? What is the time of the webinar? Then you might have checked it out, what is the topic of the webinar, right? So, and who is conducting this webinar? So based upon this, you took a decision, shall I go ahead or not go ahead? You're getting my point, right? So this is what is called as a decision tree. We call it as decision tree because it is a graphical representation of all the possible solution to a decision. It's like a tree. Like decision tree is like a tree. Why? Because a tree also start with a root and then it emerge into various branches. Similarly, you have a decision tree, which I'm showing to you here as a simplest algorithm, which is being used for machine learning purposes. Now it is something like this. Imagine that you want to find it out that, like, do you want to go to a restaurant or do you want to buy an hamburger? Okay, so you have two choices. Either you can go for a restaurant or either you can buy a hamburger. Now, how would you decide which one you would follow? So you will start with what is called as a root node. You will start with the root node that whether I am hungry or not, right? If I am hungry, right, then only I will go for all these activity. If I am not hungry at all, then simply go and sleep. You got my point, right? So this is how you will start with the first node, which is to find it out whether I'm feeling hungry or not. If I'm feeling hungry, then I will decide that, well, I have money which is around $25 worth. If I have money, then I will go for a restaurant. If I don't have a money, then I will buy an hamburger. You understood this? This is simplest representation of decision tree. Basically, you decide something on the basis of the previous outcomes. And you can imagine any sort of example here. Imagine that you want to find it out whether the person will do a credit card fraud or not. Again, it will depend upon the previous circumstances that, for example, it will depend upon how much is the salary of the person. It will depend upon what is the job profile of the person. It will depend upon the fact that, like, for example, how many fraud or how many cards this person have, right? So on basis of you will decide that whether this will do a credit card fraud or not. So this is the simplest form of classification based algorithm. Then we have the next algorithm, which is called as a random forest. Now, what is a random forest? As the name suggests, you built one decision tree in the last example, right? But one decision tree can sometimes be overfitting as a case, right? So people said that, like, why should I only trust one decision tree? For example, whenever you take a bold decision in your life, you don't trust only a single voice, right? You want to hear it from multiple different people to make your decision more stronger, right? Go to a doctor. If the doctor says to you that you have this type of a disease, you don't believe in that. What you do is you also talk to second doctor, third doctor, fourth doctor to confirm that this is true or not. Okay, so this is what is called as a random forest. As the name suggests, why it is called random forest? It is called random forest because now you're building the various number of decision trees here. It's like a forest of all the trees, right? It is no longer a single tree, it is a forest of complete trees. So for example, you can imagine that if it is my training data set, I will split my training data set into multiple examples, multiple decision trees will be built, and then based upon the majority, I will decide whether should I do this or not. Okay, so it is also called as a bagging sort of methodology where we bring the outcome of various models or we bring the outcome of various trees all together to make our powerful decision. Okay, this is another algorithm which is called as a random forest. Then after random forest, we have something called as naive Bayes. Okay, now what is a naive Bayes algorithm? Naive Bayes is also a simplest algorithm, but naive Bayes is basically based on the Bayes theorem. Okay, so this algorithm is basically based on the Bayes theorem, and Bayes theorem is based on the conditional probability, right? So it is based on the conditional probability, which is your naive Bayes. Now in naive Bayes, what happens is, like, we decide that whether something will happen or not on the basis of probability. So let me illustrate you with this example. Imagine that you want to find it out whether I would have a disease or not. Okay, so first of all, the probability of having a disease is 0.10 and the probability of not having a disease is 0.90. Okay, so if there is a probability of having a disease is 0.10, you will further find it out that what is the probability that my test will be positive given I am diseased. What is the probability that my test to diagnose the disease is negative given I have a disease, right? Similarly, if you go into this direction, if there is a probability of not having a disease is 0.90, you will find it out that what is the probability of having a disease, test being positive with no disease, and what is the probability of no disease given I don't have the disease, which is 0.90. So basically here you check the outcomes. Here you check the outcome of all the possible combinations. This is what is called as the naive Bayes algorithm or Bayes theorem or conditional probability based theorem. Okay, Then we also have something which is called as a key nearest neighbor, which is the one of the finest algorithm, which also helps you in deciding the classification, right? Now, what is k nearest neighbor? K nearest neighbor, as the name suggests, what happens in this case is we try to build, basically it's like a neighbor. So it's something like this, like if I give you the data set, say I give you the customer data set, okay, and it is a transaction data set. So customer number one has bought a product number one, right, from a particular vendor at a particular rate, and this is a profit this customer has given to us, and this is the revenues. Okay, this is my customer number one. Similarly, you would have customer number two, customer number three, customer number four, right? Now if I ask you that which customer profiling is nearby same, right? So what you can do is you can group your customers, or you will get to know that which customer behave in the similar way. So you can say that customer one, customer three, and customer four, they behave in a similar way because they are giving us the high profit and high revenue margins. You understood? So this is what happens in the case of k nearest neighbor. So k nearest neighbor, what you generally do is you find it out that what I would be able to, find it out who is my nearest neighbor, like what are the similarities in the patterns we have, right? This is what we use for k nearest neighbors. And this you can see that, for example, the algorithm based on the distance based mechanism find it out that how many people or what type of audience is similar to the outcomes, right? So then moving further here, with the second topic, let's go into detail about what is decision tree all about, right? So far I have touched base on classification based algorithm, right? And I was teaching you different type of classification based algorithm, but since the focus of today's class is decision tree, let's take a deep dive into the decision tree. Okay, so let's get started with decision tree. A decision tree is a graphical representation of all possible solutions to a decision based on a certain condition. What does it mean? It means that it is as simple as that. Imagine that this is a tree, right? So it is like a tree where you have a problem statement that should I accept a job offer or not? Imagine that you want to find it out that should I accept a job offer or not? This is a problem statement which is there in your mind. Now, how would you solve this problem statement with the help of a decision tree? First of all, you will start with what we call as a root node. We will start with a root node, starting with, to find it out, what is a salary? Okay, what is the salary I'm getting? So if my salary is equal to or greater than equal to 50,000, I'll go here. If my salary is not greater than equal to 50,000, I will say I will not accept this offer. Okay, now imagine that you say that your salary is greater than 50,000, then you will check another variable here. You will check it out whether I have to commute more than 1 hour. If I have to commute more than 1 hour, I will decline the offer. Then if you don't have to commute more than 1 hour, then you will still consider this option, and then you will check it out. For example, in this case, we are checking it out whether you are getting the free offers also, like coffee or some snacks or other things like that. If yes, then you will accept finally the offer. Otherwise, you will decline the offer. You got my point? This is how our decision tree works. Basically, decision tree will keep on splitting unless and until you are able to find it out your decision. Okay, so here the decision was, shall I accept this or not, right? So it will keep on splitting unless and until you get your decision whether you do this or not, like this example which I have explained you. Okay, now with this, what happens is, like, if I go further and explain you further on this decision tree, let's understand this more importantly, right? Let's understand this one by one. So imagine that this is my data set. Okay, now in my data set, you can see that I have various colors given to you. It's like a green color, yellow color, red color, and a yellow color. I am saying if there is a green color fruit with a diameter of 3, right? And I can say it is a mango. Whereas I'm saying if it is a yellow color and a diameter 3, still will be called as a mango. If it is a red color with 1 diameter, then it is a grape. And it can be a red color with a diameter of 1, still can be a grape, but even a yellow with a diameter of 3 can be lemon. Now, what is happening in this case is, if you have this type of a data set where you want to predict the label of the fruit, right? You want to predict whether a fruit will be mango, whether a fruit will be lemon, right? Or whether a fruit in this case is mango and lemon or grape. I have to build a classifier, which is a decision tree classifier on the basis of this data set. Imagine this is a problem statement given to you. Now, first of all, what you will do here is you will take this data set, right? You will take this data set and you will start with a root node. Root node, imagine here is like, is my diameter of the fruit greater than equal to 3 or not? Okay, is my diameter of the fruit greater than equal to 3 or not? If it is greater than equal to 3, right? Now, if it is greater than equal to 3, you can see that you have 3 fruits here, 3 rows of the data set here. One is green with 3 mango, yellow with 3 lemon, yellow with 3 mango. And wherever it fails in the condition, you are left with where the diameter is not greater than equal to 3, it is less than equal to 3. Then which are the data set we have? Red 1 grape and red 1 grape. Okay, so I hope you are understanding this, right? How we have starting with the decision tree with the based on one condition here, right? Which is diameter. Now, based upon this, what I will do is I have to split it further. Here in this case, I don't have to split it because I already got the result. So if my diameter is greater than equal to 3, in my data set, if the diameter is not equal to greater than equal to 3, I know it is a grape, right? Whereas if the diameter is greater than equal to 3, then it can be a mango or it can be a lemon. I'm not sure on my decision. So what I will do here is I will split it further. So I have to split this further. Here the splitting is not required, but if I split this further, I may check it out now. Is the color equal to yellow or not? Now, if the color is equal to yellow, then I have two fruit, which is your this row, which is your mango or lemon. And if the color is not equal to yellow, then you will have the another row of the data set, which is which you are left with, right? So this is how you have done this work in the case of your decision tree. Okay, and how you will find it out at which type of the criteria or which type of the algorithm I should, or which type of criteria or variable I should choose here to split the tree is on the basis of Gini index and the information gain. How your decision tree works basically on the basis of the condition, and if you get a pure subset, then no need to split it further. If there is no pure subset, you will keep on splitting unless and until you get a pure subset. So in this case, what has happened is you got 100% mango. Here you got 50% mango and 50% lemon. So now this is what, like, how does it work, right? Now this all depend upon the Gini index basis, right? Now in the next subsequent slide, let me tell you and explain you about Gini index and information gain. How does it work, right? How does that something works on the basis of your Gini index? So imagine that, imagine that I have a feature here, is the color green or not, right? Basis of whether the feature, whether you have a color green or not, what would happen here is, if the color is green, you will get this row here. If it is not, you will get these two rows here, right? In the next, it may decide on the other basis, right? It can be, is the diameter which is greater than equal to 3 or not, and many other things. Okay. Now let's go ahead the example and the questions which is coming to your mind, which is related to decision tree terminologies. I'm pretty sure you would have these questions in your mind, and you would be thinking that how should I decide that which feature I should use and which feature shouldn't I be using? This is the question which you had. And this is an excellent question for understanding the decision tree. But before I go on to that, I have to tell you about some of the terminologies which we commonly use while we build the decision tree. So first of all, decision tree looks like this type of a tree based structure. Okay, so every decision tree will have its root node. So root node is where the decision tree will start. So it represents the entire population or sample, and it is further get divided or into two or more homogeneous sets. So as you know that this will be the first feature on the basis of your tree will start. Like tree start with a root, your in this case your decision tree will also start with a root node. Okay, now once you have the root, after that in a tree what happens is you will start getting the branches, right? I hope you understand what is branches. In this case we will keep on splitting unless and until we get a decision whether this will happen or not. So it's like a branches. Okay, then we would also have a parent or a child node. So child node is nothing but when you have a branches, then the branches can also have the outcomes. So in the previous example, like for example, we have whether the diameter is greater than equal to 3 or not. You remember whether the diameter is greater than equal to 3 or not. If it is true, what is happening? If it is a false, what is happening? So this is a child or child node. Basically, this is an intermediate node. This is not the final decision which is being made. So this is called as a parent or the child node. Then we also have other terminology here, which is splitting, which you know that we will keep on splitting unless and until you get a desired node. And finally, the tree end with the leaf node. So always remember one thing, you will start your tree with a root node. Root node is a node with which you will start the decision tree, and you will end your decision as decision tree at a leaf node where you will get a decision that you should do this or not. Okay, and now pruning is the activity where you will cut down the decision tree if it is pruned lot amount of times. I will even explain you this. It is a case of overfitting. You shouldn't build shouldn't build 1,000 branches of the tree when it is not even required. So I'll explain you this point. Now let's move further here and let's see this with the help of an example, which was your Gini index and your information gain, right? So this is where you were asking me that which question to ask and when, right? How would you decide that which feature has to be taken first, right? Let's take up an example here, and I would encourage every one of you to hear me really fine here, because this is on the basis how would you decide or how the algorithm decide to break this further. And I'm explaining you with the help of one simplest example, and we will do some maths over it. So imagine that there is a data set where I want to find it out whether I will play the match or not. Okay, there is a cricket match or there is a football match or whatever it is. I want to find it out whether I will play the match or not. Okay, now how do the decision tree look like? Decision tree look like this. If the outlook is humid, if the outlook is humid and if the outlook is humid and humidity is very high, then I will not play the match. On the other hand, if the outlook is humid and humidity is normal, I may play the match. Okay. If the outlook is absolutely clear, then I will always play. On the other hand, if outlook is windy and the winds are very strong, I may not play the match. On the other hand, if the outlook is windy and the wind are weak, I may play the match. So now what is happening again is that you are not sure how you decided with outlook, how you decided with these nodes here, how you decided with these features here. Let me try to show you this entire data set. So this entire data set look like this. Okay, so this is basically your 14 days data set, and this exactly happens in the case of your classification based algorithm. You will get a data set like this. So you can imagine that you want to find it out. I would like whether I will play or not, right? This is what you want to essentially find it out whether I would play or not. On basis of what? On basis of 4 different variables you have. 4 different variables or features in the data set is outlook, temperature, humidity, and wind, right? So now it can be like if the outlook is sunny, temperature is hot, humidity is high, wind is not there, I will not play the match. This is how you will read this one data point, right? Similarly, I have multiple data point. Now I have to decide how can I build a decision tree, and out of these 4 features, which feature should I use first as my root node, right? So this is what I have to decide, and let's do it accordingly, right? So now what I'll do from here is I will illustrate you what is Gini index, what is information gain, and how does this happens, right? And this is basically used to build your decision tree. So before I make you understand about Gini index or information gain, one thing which you should always remember is to understand the concept of impurity. What is impurity? Impurity is nothing but, you can see there is a basket where you have apples, right? Now, if you have a basket which is of apple and another tray, it is written the label as apple. Now, in this case, you will never make a mistake. You will never make a mistake because here you have an apple, here you have only one label. So everything will be perfect. It will be 100%. Basically, there is no impurity, there is no problem in your data set, right? On the other hand, let me flip the story. In this case, imagine that I have different fruits in the basket, which is like apple, you have a banana, you have a grapes, you have a cherries and many other things, right? And you have many apples, many labels here. In this case, try imagining you have to match each fruit with its label, right? Now, in this case, the impurity cannot be equal to 0. The impurity will not be equal to 0 in this case, because what would happen here is that you have a chances of misclassification, right? This is a very important concept, right? When you have perfect thing, the misclassification will not happen. But whereas if you have a multiple labels with multiple fruit, misclassification or impurities will not be equal to 0, right? So this is associated with a term called as entropy. Maybe in your childhood days, you have learned about entropy in your chemistry class. In a simple sense, what is entropy? Entropy is a randomness of the space, sample space. Whenever you are not sure on your decision, then entropy will be more. Imagine that I'm giving you the data set where it is like 51% of doing this thing, 49% of not doing this thing. 51% chance that the employee may leave the organization, 49% chance that employee may not leave the organization. So basically, you are not sure on your decision. If you are not sure on your decision, then the entropy will be very high. On the other hand, if you are very sure on your decision, then the entropy will be very low. So basically, we need that feature which can provide us lowest entropy rather than the highest entropy to select as that as a good feature. So we generally find it out entropy by the help of this formula. What we simply do is don't get scared with this formula because everything happens automatically in R or Python, right? Imagine, just look at this formula. What is this formula? This formula says that what is the probability that something will happen, multiply by log base 2 probability that something will happen, subtract this with probability that something will not happen, into log base 2 probability that something will not happen. Okay, let's take up an example. Don't worry about it. Let's take up an example that probability that I will win the match you will apply here, and probability that I will not play the match or win the match you will apply here, and then you will calculate the entropy. Let's take an example how you can do this in our case. So in our case, let me show you. Yeah, how we will build the decision tree in our case. In our case, you just see here what is happening is that we have 14 instances or 14 rows of the data set, where 9 times if you see it, I will play the match, and 5 times I will not play the match. Okay, so if you see carefully, there are 9 labels where I'm playing the match, and there are 5 labels where I'm not playing the match, right? So first of all, I have to find it out the total entropy. How I will find the total entropy? This is being determined by probability that I will play the match, multiply this with log base power 2 probability that I will play the match. What are the chances that I will play the match? 9 out of 14. All of you will be with me, right? This is 9 out of 14. Multiply with log base 2, 9 out of 14. Subtract this with what is the probability that I will not play the match? 5 out of 14. Multiply this with log base 2, 5 out of 14. So once you calculate this, you will find it out the entropy of this entire system entropy of this entire system is 0.94. Okay, so this is the entropy of your entire sample space. This is the first thing. Now, how this entropy will help you in selecting which features you will take or not? So let's go further. So now we will take each feature one by one, whether I should take outlook, whether I should take temperature, whether I should pick up humidity, or whether should I pick up windy, right? Let's go one by one. Now, first I'm plotting for outlook. Imagine for outlook, how many times, so what are the distinct value of outlook? Outlook can be sunny, outlook can be overcast, or outlook can be rainy, right? These are the three different combinations you can have for outlook. Now, if the outlook is sunny, 2 times I'm playing, 3 times I'm not playing the match. If the outlook is overcast, I'm always playing the match. If the outlook is rainy, 3 times I'm playing, 2 times I'm not playing the match, right? This is how I have bifurcated it. What I will do in the next iteration is, let me find it out the entropy of outlook. Okay, so if we start with outlook, remember this formula, which is, probability that I will play, multiply with the probability that I will play, right? And subtract with probability which I will not play, and log base 2 of not playing. So 2 by 5 is the chances that I will play, into log base 2 2 by 5. This is a subtraction here, right? With I will play and log 3 by 5 I will play, right? So you will calculate this entropy when outlook is sunny. Yeah, so you got this entropy when the outlook is sunny is 0.971. Accordingly, you will proceed with calculating the entropy when the outlook is overcast. Outlook is overcast, always you are playing, right? If the outlook is overcast every time you are playing, so it means that you will get a probability of 0. If you apply in that formula, you will get 0. And third, what would happen if the outlook is sunny? In that case, you will again multiply and you will put the formula and you will get it out 0.971, right? So you will find it out entropy for each and every distinct combination of your feature. You got my point, right? Outlook being sunny, outlook being overcast, outlook being sunny, overcast, sunny, and rainy. This should be replaced here, right? And then what you will do is you will finally calculate the information gain. Information gain is nothing but what you will do is you will pick it up the chances, you will pick it up the entire chances when you are playing, right? Which is 5 out of 14. You remember 5 out of 14 were the total chances that I will play, into if it is sunny, plus 4 out of 14 if it is overcast, 5 out of 14 if it is rainy, right? And you will calculate the information from this outlook. And once you calculate the information, you will subtract this information from your total entropy, which I found it out in the last slide, which was 0.94. You will subtract this and you will get the information gain, or this is also called as a information gain from a particular feature. So basically, these type of a calculation, first of all, don't get scared away that you have to do this calculation. But what I'm trying to explain you is this is how your algorithm will work. For each and every feature, it will calculate the information gain from your feature, right? If you have the more information gain, it means that this variable is of very, very important in predicting that something will happen or not. Okay, so for outlook, I got the information gain as 0.247 with all the calculation. Remember, then we will proceed with wind, if the wind is there or not, right? And then I will proceed with wind and I will calculate the information gain and say information gain I found it out is 0.048, right? Similarly, we will calculate for all the 4 of them. Let me put it together for all of you. So this is what happens here. Now, if I put in front of all of you, these were the 4 different variable I have: outlook, temperature, humidity, and wind, right? I am calculating the information gain for each one of them, and the information gain I got for outlook is 0.247. So if the information gain is highest in a particular feature, that feature will become your root node. You got my point? So therefore, we will pick it up outlook as our root node. Similarly, for when the tree gets started later on as a branch node also, your information gain will be calculated, and whichever feature is giving you more information gain, that will be picked up later in the your tree also. So this is how you will build your decision tree, and you will finally get a decision tree like this. Okay. So now what I will do is, like I will quickly show you how do we do the decision tree in your Python. Okay. So I'll show you how do you do this in Python, and then I will summarize for all of you that why decision trees or tree-based algorithms are better than your um other algorithm. Okay. So how do you choose? Basically that which algorithm you will select and when. Okay, so I'll describe you this, but before, let's jump on to Python and go there. So what I have done here is, like, I had built the decision tree in front, already. So quickly I will walk you through the commands. Okay, so what happens here is that in Python, as you would be well versed with this, that we generally import packages in Python. So I'm importing NumPy, I'm importing matplotlib for plotting the chart. I'm importing various packages from your sklearn, which is for machine learning purposes, right? So I am importing your label encoder, your decision tree classifier, classification report, and I'm importing your tree, right? So we have all this which I am importing, right? After I import, what I will do is I'm reading my data set. So I'm showing you this with the help of our iris data set, which is one of the very popular data set for building the a decision tree, right? For any particular source. So imagine that this is my data set, and I'm just showing you 6 rows of the data set where, I want to find it out whether a particular flower species will be Setosa, versicolor, or virginica. I have 3 different flowers which I want to predict, and on the basis of sepal length, petal length, sepal width, and petal width. So basically I have different dimensions of flowers length and width, and based on that I want to find it out whether the particular species will be Setosa, versicolor, or virginica. You got my point, right? So this is a data set. So what I will do is, as you know, with every machine learning data set, we play with the data set. So I'm checking the information here, what type of the data type it is. So sepal length, it is a float, petal length, it is a float, and species is a object. Why object? Because this is a categorical column. So after this, I'm also checking whether there is any null value present in the data set or not, because if there is any null value, then we have to get rid of that null value, or we have to replace that null value with some imputed value, right? This is what I'm checking here. Once I do that, I'm also plotting this because we usually do visualization, right, to understand the data set better. So what I'm doing here with the help of SNS, which is your SNS.pair plot, I'm plotting all the possible plots. So basically sepal length with sepal width, what type of the combination look like. So Setosa, versicolor, and virginica, there are 3 different species you can see in the data set. And this is what I'm getting a trend between your sepal length and sepal width. Similarly, this is basically from sepal width to petal length, right? So this is how I'm understanding the patterns, or I'm understanding the relationship between the variables in the data set. So this is what I'm understanding here. I am also checking whether there's a correlation or not. Higher the shade, it means there will be a strong correlation. So all of these things is being done as a part of exploratory data analysis before even you start your machine learning model, right? Once you do this, after that, what I have to do is, after that, what I'm trying to do is, I am taking your species column, what I want to predict, as my target variable, which is your dependent variable. And so this is the dependent variable, and with the help of what I want to predict will be my independent variable. So I'm calling X all my independent variable, and I'm calling target as my dependent variable. Once I do this, then you will also think about it that the variable which I want to predict is the flower species, right? But I want to convert this into 0 and 1 class, 0, 1, 2 class, because your computer cannot understand text, right? Computer can only understand the numbers. So what I'm doing here is I'm changing it to the class, right? So what I'm trying to do here is I'm saying wherever it is Setosa, it will become 0. Wherever it is Virginica, it will become 1, and it is versicolor as a third category it will become 2. So now imagine my data set, my label to predict becomes 0, 1 or 2 instead of 3 flower, which was Setosa, versicolor and virginica. This is what I am doing with the encoder here. Once I convert this and this become my target, what I will do is, as I told you, that I will split this data set into training and test data set. So basically 80% of the data is going into the training data set, and remaining 20% I'm taking as a test data set. Okay. Now I will call decision tree classifier. You know, like I want to make a decision tree and I want to fit this on my training data set and the test data set. And I will start building the decision tree, and with the help of, from so here is when I have created the decision tree, and here is when I'm checking the prediction, how accurate my decision tree is. So I got my precision, which is good. I got my recall, I got my F1 score, and I also get the support, right? So all these matrices are being used to calculate your how accurate your predictions are. So higher the precision, better the results would be, right? And finally, I'm showing to you that how does the tree look like. So I had tried to plot this decision tree in front of you. So basically it starts with petal length, and you can see the Gini index coming up here, or the information gain, which is information gain and Gini index are reciprocal to each other. If you want to use information gain, you will get that score. If you don't want to use information gain, you will get Gini index. So they are both reciprocal of each other. It is one and the same thing. You use Gini index or you use information gain. They are the two different metrics to build your decision tree. So you can see that based on a petal length, the tree gets splitted like this. Then based on the petal length of different dimensions, your tree further split, then it further split, then it further split, and finally you get to know that whether the particular species will be versicolor or virginica. Okay, so this is how your entire decision tree is built in Python. Okay, so this is how it's so simple. I know it takes time to build this thing, but once you are a good data scientist and you understand all these things, it is very simple to build all these things very easily in Python or R. Right? So now, finally, going back, how would you decide? How would you decide that which algorithm, which algorithm will be taken when? So what happens is, this is on the basis of scikit-learn. So it starts something like this. Okay, so it is on the basis of like this, that first of all you see here that whether how many samples you have, how many data points you have in the data set, right? If you have more than 50 samples, then you will go here. If you have less than 50 data point, then you will go here. So you will get more data set, right? So if you have more data, if you have greater than 50 data point, then you will go further, you split your data set. If it is not, then you just the kind advice it, get more data set. Okay, so then you will decide that what you want to predict. If you have a labeled data set, then you will go here, right, and do clustering. If you don't have the labeled data set, then you will see whether you want to predict a quantity. If yes, you will go in regression. If you want to predict, if you just want to do exploratory analysis, you can do dimensional reduction. If you have a labeled data set, for classification, you can do all this classification. So basically, this is a cheat sheet which we generally use to decide that what we have to do with the data set and when.
So now let's understand what is a random forest. So random forest is constructed by using multiple decision trees, and the final decision is obtained by majority votes of these decision trees. So let me make things very simple for you by taking an example. Now suppose we have got 3 independent decision trees. Here we are just taking 3 decision trees, and I've got an unknown fruit, and I want that these trees would give me a result of what exactly this fruit is. So I pass this fruit to the first decision tree, the second decision tree, and the third decision tree. Now a random forest is nothing but a combination of these decision trees. So the results are being fed into the random forest algorithm. So what it sees is that, okay, the first decision tree classifies it as peach. The second decision tree says that it is an apple. And the third one says that it is a peach. So random forest classifier says that, okay, I've got the result as 2 peach and 1 for an apple. So I would say that the unknown fruit is an peach. All right. So this is based on the majority voting of the decision trees. And that is how a random forest classifier comes to a decision of predicting the unknown value. Okay, so this was a classification problem, so it took the majority vote. Now suppose if it was a regression problem, it would have taken mean of it. Okay, so now let's move on further to understanding what is a decision tree. But before that, we should understand that random forest, the building blocks are decision trees. And that's why studying decision tree becomes important, because if we understand one decision tree, we can apply the same concept to random forest. So now let's move on forward and understand the important terms in random forest. And this will also help us consolidate whatever we have learned so far. So we've taken the same small decision tree of the previous example, and let's understand these are also the important terms which will be relevant to random forest also. So the first is the root node. Now here what happens is that the entire training data is being fed to the root node. And then we've got here that each node will ask either true or false question with respect to one of the feature. And then in response to that question, it will partition the data set into different subsets. That's what it is doing here based on the condition that if the body mass is greater than or equal to 3500, it asks a question either yes or no. And based on that, again, further partition is done. And if not, then it just classifies the species. And then again, what happens is that the splitting. Now, this is very important here. The splitting takes place either with the help of a Gini or entropy methods. And these helps to decide the optimal split. And we will be discussing about splitting methods very soon, right? Okay. And then we've got the decision nodes, which provide the link to the leaf nodes. And these are really important because then only the leaf nodes would tell us what actually the real predictions or to which class does the species belong. So now coming to the leaf node, and these are the endpoints where no further division will take place and we will obtain our predictions. Okay. So now coming up to another important thing here is working of random forest. So now for working of random forest, we will have to understand a few important concepts like random sampling with replacement, feature selection, and also the ensemble technique, which is used in random forest, and that is bootstrap aggregation, which is also known as bagging. So we will understand this with the help of an example, which will be very simple. And then we will go on understanding how feature selection is done in both the classification and the regression problem. Actually, how random forest select features for the construction of decision trees. Well, in random forest, the best split is chosen based on Gini impurity or information gain methods. So this also we will understand. Now let us first understand random sampling with replacement. Now what happens here is that we have got a small subset of the same penguin data set, wherein we have got some 6 rows and 4 features, that means 4 columns. And the arrows that you can see is that now we will be creating 3 subsets from this small subset, right? And these 3 subsets will become our decision trees. And then we'll be constructing decision trees from these subsets. So let us create our first subset. And you can see here that the subset is randomly being created. And for convenience sake, let me just also show you the different subsets here. Okay, so now for better understanding, let us understand this, that in the first subset, if we focus, we've got certain random rows here and we've got certain feature, but we do not know how this feature has been selected. We got island and we got body mass, but in the second subset, we got island and flipper length, and in the third subset, we got body mass and flipper length, right? Now let's look at the rows. Now, when I am talking about these features, I will say this is feature selection, and remember this term. Now coming to the second concept, that is random sampling. Now random sampling is nothing but selecting randomly from your subset. So I'm selecting randomly certain rows from my subset and creating further subsets. Okay, so what is replacement here? Replacement can be seen here and can be understood with this second subset. We see here that the 𝐶𝐵 species, this row is being repeated again. And this is replacement. That means that when we are working with repeated rows and this row can be repeated again in the second or the third subset, then this is random sampling with replacement. That means my random forest can use a row multiple times in multiple decision trees, right? So this is the basic concept of random sampling with replacement and feature selection in random forest. Another important term which I would like to bring into the notice is that when we are working with these type of small subsets, these are also known as a bootstrap data sets. And when we aggregate the results of all these data sets, it becomes bootstrap aggregation. So just filling in the gaps so that later on the concepts become more clear. So now let's move on to drawing decision trees of these subsets. Okay. So let's draw the decision tree of the first subset. Again, we are taking body mass as the first root node, and then based on a decision like if the mass is greater than or equal to 3500, then take a decision either yes or no. If it is no, then the species is chin-strap, and if it is yes, then again you partition based on island, and if it is 𝐑𝐺, then it is Adelie, and if it is visco, then it is 𝐁2 species. Okay. So this is how we will construct two more decision trees of the remaining subsets. So on the second subset, let us just again create decision tree. And here now we are taking flipper length. And then based on a condition that if the flipper length is greater than or equal to 190, then make a split. If it is yes, then the species become 𝐁2. And if it is no, that means again make a decision based on island. And if it is 𝐑𝐺, it is Adelie. And if the island is dream island, then it is a chin-strap species. So this is how the decision tree of the second subset is being created. And this is how it will take decisions, right? Based on the tree length, depth, and also the features it is selecting. Okay. So now let's create the third decision tree of the third subset. And we get a decision tree something like this, wherein body mass, if it is greater than 4000, and if it is yes, then clearly it is a 𝐁2 species. And if it is no, then again make a partition with respect to flipper length, another feature here. And then if it is again greater than or equal to 190, then the species would be Adelie, else it would be chin-strap. So this is how decision tree 3 will make a decision. Now let's just keep these decision trees with us, okay? And we will make sense of these trees just in a while, okay? But before that, let us understand how feature selection is done in a random forest. How am I selecting the columns? So for classification, by default, the feature selection is taken as the square root of total number of all the features. Now suppose I've got here 4 features. So it is a classification problem. I will take the square root of these 4 features, which becomes 2. So decision tree would be constructed based on 2 features each. If suppose I had 16 features, then it would be square root of 16. That would be 4. So 4 features would be taken in each decision tree. All right. And suppose if this would have been a regression problem, then by default, what would happen? The features would be selected by taking the total number of features and dividing them by 3. Okay. So this is how by default the feature selection is being done by a random forest. Okay. Now let us move on forward to consolidating our learning. So now we are coming to ensemble techniques, that is also known as bootstrap aggregation. Random forest uses ensemble techniques. And what is ensembling? It just means that you are aggregating the result of the decision trees and taking the majority vote in case of classification and the mean in case of regression problems and giving the output. Okay. So now we have again plotted all our decision trees here. And below we can see that there's an unknown data and I want to predict the species of this data. So what will happen is that again, let us just feed this problem to each of the decision tree and let's see what each decision tree makes the prediction. So I just feed this unknown data to decision tree 1 and it says that, okay, the species seems to be chin-strap. Okay. And then decision tree 2 says that based on the data, it has been found that the species is Adelie. And then decision tree 3 says that, no, I with my decision tree, this species is chin-strap. Okay, now all these data is being fed to random forest classifier. And it says that, okay, for chin-strap, I've got 2 votes. For Adelie, it's got 1 vote. So the new species would be chin-strap, right? So this is how the bootstrap aggregation is done based on the majority voting and the decisions taken by different decision trees. They have been combined together, aggregated, and we get an ensembled result in the random forest. Okay, so this was very simple concept of ensemble techniques which has been used in random forest. Okay, so now let's move on forward to splitting methods. So what are the splitting methods that we use in random forest? So splitting methods are many, like Gini impurity, information gain, or chi-square. So let's discuss about Gini impurity. So Gini impurity is nothing but it is used to predict the likelihood that a randomly selected example would be incorrectly classified by a specific node. And it is called impurity metric because it shows how the model differs from a pure division, right? And another interesting fact about Gini impurity is that the impurity ranges from 0 to 1, with 0 indicating that all of the elements belong to a single class, and 1 indicates that only one class exists. Now value, which is like 0.5, this indicates that the elements, they are uniformly distributed across some classes, right? Now moving on forward to information gain. Now this is another splitting method which random forest can use, and information gain utilizes entropy. So entropy is nothing but it is a measure of uncertainty. So information gain, let's talk about that first. So the features they are selected that provide most of the information about a class, right? And this utilizes the entropy concept. So let's see what is entropy. This is a measure of randomness or uncertainty in the data, right? So now let's move on to understanding the advantages of random forest. And we see here various advantages. So let's focus on firstly low variance. Now, since random forest overcomes the limitations of decision tree, and it also has the advantage of low variance because it combines the result of multiple decision trees. And each decision tree is being trained on limited data set that we have seen earlier also. So each tree was making its own subset of data and training the data on that limited length of the tree. So there's less depth, there's less overfitting, and low variance of the data. So coming to the next point, that is reduced overfitting. Again, since we were working with multiple decision trees, hence reduced depth of the tree, so we get reduced overfitting. That means the model is fitted well and it does not tries to learn even the noises, right? So we use the bootstrap aggregation or bagging here in random forest, and that is why we also get reduced overfitting in random forest. And this is one of the reasons that why is it so popular, because you don't have to worry about overfitting of the data, right? All right, now moving on forward to the another advantage is that the normalization is not required in random forest because it works on rule-based approach, right? And another advantage is that it gives really good accuracy, which we will also see in our hands-on. It really gives very nice predictions, either precision or recall, and generalizes well on unseen data as compared to other classifiers or machine learning classifiers which are present like naive Bayes or SVM or KNN. Random forest really outperforms other classifiers, right? So let's move on to understanding few more advantages of random forest. Is that it is suitable for both classification and regression problems, and also it works well with both categorical and continuous data. So you can use it well with any of the data sets, right? And it performs well on large data sets, right? So it solves most of the problem. That's why random forest is largely been used in machine learning problems. Now moving on forward to certain disadvantages of random forest. So the first disadvantage is that it requires more training time because of the multiple decision trees. If you've got a huge data set, you would be constructing hundreds and hundreds of decision trees, and that requires a lot of training time. And here comes one more disadvantage, is that the interpretation becomes really complex when you've got multiple decision trees. So decision tree interpretation is easy because it is an individual decision tree. But when you combine hundreds of decision tree to form a random forest, the interpretation is really very difficult to understand, and it becomes quite complex to apprehend what exactly the model is trying to predict and where the splitting occurs and what features are being selected and so on. And another disadvantage is that it requires more memory. So memory utilization is really heavy in case of random forest because we are working with multiple decision trees. And another disadvantage is that it is computationally expensive and requires a lot of resources because of the training of multiple decision trees and also storing them. All right, so this was all about random forest, the theory part of it. And now let us just move on to the practical demonstration or a hands-on on random forest. Okay, so now it's time for a hands-on on random forest. So let us just import a few basic libraries of Python in our Jupyter notebook. and we will run this. We will import pandas as PD, numpy as NP, and seaborn as SNS. Now seaborn is needed here because we want to load a data set, that is a penguins data set, with the help of seaborn. And this is already been preloaded in seaborn. This is already loaded data set, and seaborn has got multiple data sets, for practice for beginners. So it is a good way to practice for data sets. Now we can see this asterisk sign, that means it is telling us to wait. So let us just let it get loaded. So we got our data in an object called df, and we can see the first 5 entries here. And this data frame is shown in the form of a table, rows and columns. And we see here some species, island, bill length, bill depth, flipper length, body mass, and the sex of the penguin. So our task is to specify or to classify these species of penguins into the respective correct species, right? So we see the shape of our data, and we see that it is like 344 rows and 7 columns. And we will see the info. So we see df.info, and this gives us, along with the non-null count, we also get the data type of the values. So we have got species island as the object data type, whereas the bill length, bill depth, triple length, and body mass are in floating point, or you can say floating data type, and the sex is in object data type, right? So now moving on forward to calculating how many null values are there with the help of df.isNull.sum. So we get certain some around 2 null values in all these columns. As you can say, the features like bill length, bill depth, flipper length, and body mass, whereas there are 11 null values in sex feature, right? So what we do is, since they are very small null values, we can just drop it, or you can also ignore them. So here in this data frame, what I'm doing is I'm just dropping these null values, and let us just check whether they have been dropped or not with the help of, again, the same function .isNull.sum, and then we see that yes, they have been dropped from our data frame. Now let us do some feature engineering with our data. Now we have seen that we have got some object data type in our data frame, and before feeding it into algorithm, that is random forest, we have to transform the categorical data or the object data type into the numeric. So we are using here one-hot encoding to convert the categorical data into numeric. Now there are various ways in Python which we can do that, like one-hot encoding, or you can also use the mapping function in Python, but here we are using one-hot encoding. So let us just do that. And we find here, first of all, let us apply it on the sex column. And here we see that we have got 2 unique values in sex, that is male and female. And we use pandas here to get dummies. That is how we will apply this one-hot encoding, because this is how get dummies work. So what happens is here is that the new unique values are converted into the respective columns in the data frame. So we see here we have got 2 unique values, males and female, and they are being converted into the columns. Okay, so one thing to note here is that we also get a problem of dummy trap, because here we see only 2 unique values. Now suppose if I had 6 or 7 unique values and I do this one-hot encoding, I would have lots of features in my data frame, and that would lead to several complexities. So what I do is, to keep things simple, I can use one-hot encoding when my data frame or my unique counts are low, when my unique values are less. So since I had just 2 or 3, I can use it. So I'm using here. So what I do is, again, now one row, one column, as we can see here, that it is redundant, giving me extra information. So I will just drop it. So I drop this first column, and what I get in this data frame is only male. So let us just infer whether I can also infer females from this or not. So if the value is 1, that means the penguin is a male. And if the value is 0, that means the penguin is a female. Okay, so only one column is needed for this data frame. So I just kept one and dropped the another one. Okay, now apply again one-hot encoding to the island feature. So in island, if we check the unique values, we've got 3 unique values here: Togresen, Bisco, and Dream Island. And the object is the data type, right? So again, we will use pandas, pd.getDummies, and we will apply it on the feature island, and let's get the head of it. So we get here, again, the unique values were converted into columns, and we get here respective 3 columns. And then again, we will just drop the first column to get the remaining 2 columns. So here also we can infer that if the island is Togresen, if it is 1, then it is not Dream, neither Bisco, right? So this is how we can read it from the data frame and understand that. Now remember this thing, that these 2, island and here sex, these are 2 independent data frames. These are not yet included in the main data frame. So what we will do now is we will concatenate the above two data frames into the original data frame. So what we do, we again create a new data frame, that is new data, and let us just concat with the help of pd.concat function, and we will concat what? df, island and sex. And access is 1, that means in the column. Okay. So when we will run this, let's see the head of it. So everything gets concatenated in a single data frame, which is good for the feeding this data into or splitting the data into test and train data. So now we have this new data frame and we've got some repeated columns here which needs to be deleted. So what we do is we will delete sex and island here, which are just repeating because we've got here male and we have also got here dream and Togresen. So we do not require this island column, neither this sex. So we just drop it with the help of new data.drop and the column names x is 1 in place equals to true, right? And let's see the head of this data frame. Head of the data frame gives me 5 unique values, right? And now it is time to create a separate target variable. And what we'll do is we will store in a variable called y only species. So what we do is from this new data.species, we will just store the species in this y. And we see this y.head, that is the first 5 species. And we got the values here. That means another target variable is being created now. So, and you can also see the y.unique values as 𝐓𝐫𝐞𝐁𝐚𝐬𝐿, and so now we see here 3 unique values of the penguin, that is 𝐁𝐚𝐬𝐿, and 𝐵𝐴, and the data type is object here. So again, we need to convert this object into the numeric data type. So now what we are doing is we are using the map function in Python, and what we do is we map 𝐓𝐵𝐿 to 0, 𝐁𝐚𝐬𝐿 to 1, and 𝐵𝐴 to 2. So this is how we see then all the values are being mapped to numeric. This is another way to convert a categorical value into a numeric value in Python. Now what we do is let us just drop the target value species from our main data frame. So we just drop it and let's see our new data frame. So we see that we don't have any target species here, right? Okay. So in X, let's store this new data and perform the splitting of the data. So what we do is from sklearn.model selection, we will import our train test split and we will split our training data into 70% and 30%. So test data becomes 30% and training data is some 70%. And this random state is 0, which means that I'm not fixing any random state. And this is also used for the code reproducibility. Now suppose if I again run this code, I will get the same result. It will not change. You can set this random state to any of the random number as per your choice and the result would differ. Okay. So now let us print the shape of xtrain, bytrain, xtest and ytest. So we see here that it has been split into 70 and 30% and we get xtrain as 233 values here and 7 features, and xtest has 100 values and 7 features. Similarly, ytrain you can see 233 values and ytest has 100 values. That means the species. Okay. So that has been perfectly splitted into 70 and 30%. Now what we do is we will train the random forest classifier on the training set. How do we do it? We will import the random forest classifier from sklearn.ensemble. So we've already dealt with what is ensemble. And then in classifier, we will store this random forest, and this n estimator is nothing but decision trees. So we are creating some 5 decision trees here, and the criteria is entropy. And again, random state is set to 0. So let's see. And then we will fit this X train and Y train. So this has been fitted and the criteria is entropy here. All right. So now let's make some predictions and let's create a variable called yPredict. And we will just predict it on xtest. And we have also printed this y prediction. And now let's print the confusion matrix to check the accuracy of random forest algorithm. And what we do is from matrices, sklearn matrices, we will import classification report and confusion matrix and also the accuracy score. So we will just import them, and then in CM variable, we will print the confusion matrix of ytest and y predictions. So we will print it and we see here the accuracy score also, which is 98%. So our random forest classifier is giving us a very good accuracy of 98%. And you can see a confusion matrix that only 2 cases have been misclassified. Rest all the cases have been correctly classified by random forest classifier. Okay, so now let's move on to printing the classification report of ytest and y prediction. Let's see. And we get the precision as 96%. That means the true predictions by the algorithm is 96%. The recall or the true prediction rate is 100%, which is very nice. And F1 score is also good, which is 98%. So this is giving us a good result. But what if we change the criteria from entropy to Gini? So let's just experiment with that too. So let's try this with the different number of trees and change the criteria to Gini coefficient. So now again from sklearn.ensemble, we will import random forest classifier and fit it, okay? And here what we are doing is just we are using 7 trees. Previously we used 5. And now in the criteria, we will use Gini coefficient and random state is 0. So let's run this and see whether there is a change in accuracy or not. And let's predict this. And let's check the accuracy score. What is the accuracy score for this random forest classifier with 7 trees? So we get 99% accuracy with changing the criteria and changing the number of trees. So you can just experiment with different number of trees and different number of decision trees. Let's just experiment with 12 decision trees and see what happens. So you can see the accuracy reduced to 98%. Okay, with 7 we were getting 99. So let's just keep 7 because it is giving us really good accuracy. So this is about random forest classifier and how it works with several trees and different criteria to give us very good accuracy on our training and test data.
What is KNN algorithm? So as we said, KNN algorithm is K nearest neighbors algorithm, and it is an example of supervised learning algorithm where basically you try to classify a new data point based on the neighbors of that data point, which is basically which data points are closer to it. For example, here as you can see, on one side you have dogs and on the other side you have cats, right? Now if a new data point is given to us, there is a picture of a new animal, and if it is lying somewhere here, right, then we know that it is nearer to the cats, right, and therefore we will classify it as cat. Whereas if it is sort of nearer to the dogs, then we classify it as dog, right? So that's the neighborhood for the dog, and therefore we sort of classify it, that new animal or the new picture, as being that of a dog. And this is quite this is something which is we even see in our regular day-to-day life, right? We have had examples where our parents keep telling us, okay, don't play with those kinds of children or something because they are not good in their studies, or probably they are not so good in their behavior, because you would become like them, right? So it's again an example from real life of classifying a particular person based on the company that they keep, right, or from the with the kind of people that they are. So that's sort of the example. And now let me actually go back. Okay, what are the features of K nearest neighbors algorithm? Okay, so let's talk about the features of KNN. So as I said, KNN is a supervised learning algorithm. Typically, it is used for supervised learning kind of problems. It's very simple, as we mentioned. Intuitively, you can it's about what kind of neighbors do you have. So your class is predicted based on your nearest neighbors, as the name suggests. And then it's a non-parametric technique. So I would like to spend a couple of minutes here to discuss about what we mean by non-parametric. So typically, the supervised machine learning algorithms are of two kinds, right? One is the parametric types, and the second one is the non-parametric type. When we say parametric, what we mean is basically that the machine or the algorithm assumes that there is an underlying function or a distribution that is known of the particular data set. Like, for example, the linear regression would assume that the relationship between two things x and y is linear in nature, right? And similarly, for a distribution, a Gaussian distribution, it would assume a normal distribution of the data points, and so on. So a lot of the supervised machine learning algorithms, they assume some kind of function association between the predictor, which is basically the root causes which help you in predicting, and the variable that you are trying to predict. Whereas there are certain algorithms like the KNN or the Parson window, or the linear discriminant analysis, which is of the kind which is called non-parametric, because it does not assume any particular kind of distribution or any particular kind of functional relationship of the data that you are trying to predict, or you're trying to learn the pattern of. So KNN is one of the kind. As I said, Parson window is another one, which is basically where you in Parson window, essentially, the volume of the data set or the area that the data set covers is known, whereas you're trying to find the k there, which is the number of data points within that area or the volume, right? Whereas in case of non-parametric technique like KNN, it's the opposite, where the k is known, which is basically you would like to associate the class of the data point that you're trying to predict based on the k number of neighbors around it. Now k can be 3, 4, 5, whatever, right? 10, 20, and so on. Essentially, the difference between Parson window and KNN is that in KNN, you already know the k, and then from the k you try to find out the volume, and therefore then you try to find the probability or the density underlying distribution. And then there is the discriminant analysis, which is of, again, two kinds: linear discriminant and multiple discriminant analysis, where basically what you do is you transform the underlying data, the features, into a higher dimension, and in such a way that in the new feature space, after you have transformed the data, you now try to apply a parametric approach. Like, for example, you will try to project the features onto a line, or if it is on a subspace which is higher dimension than a line, then essentially it becomes multiple discriminant analysis. So basically, those are the three kinds of non-parametric techniques. So even if you were not able to sort of get the full hang of what these three types are, what you need to keep in mind is that non-parametric technique does not assume any kind of distribution or any kind of functional relationship of the underlying data, and therefore it gives us a lot of flexibility. Whereas the parametric techniques, they basically assume some kind of functional relationship between the data points, or they assume some kind of distribution. So where would you use a non-parametric versus a parametric technique, right? So basically you would use non-parametric technique, where you do not know about the functional relationship. That is one. Second is that, there is maybe, let's say, large amount of data and so on. And thirdly, non-parametric technique like KNN does not work in a very high dimensional data. So you would also use parametric techniques in that case. Whereas if you have, smaller data sets, you would use, typically non-parametric techniques. And then also, if you understand that the relationship between the data points might be, for example, linear or something like that, you would use a parametric technique. So you are assuming that there is some kind of relationship, like a linear relationship or something like that between the data point. So that's where you will use the parametric technique. So again, just to summarize, basically non-parametric is an approach where you do not assume any kind of distribution or functional relationship, whereas parametric assumes a functional relationship or basically a distribution between the data points. The other feature of KNN is that it is a lazy algorithm. So what do we mean by lazy algorithm? Actually, in most of the supervised learning algorithms, you basically train your model on the training data set, then you have your model, and then you apply this particular model to the test data set to then classify or predict, for example, whether a new image is that of a cat or a dog, right? So this can be, some kind of algorithm like support vector machine or regression or logistic regression or whatever, right? So you run this logistic regression or you run this regression or support vector machine on the training data set, and it learns the features or it learns the parameters of the model from that data set, and then applies this learned model on the test data set. Whereas in case of KNN, actually there is no training step at all. That's why it's called a lazy algorithm, because what it does is, at the time that you are actually now want to predict, at that point in time, actually, it will go and it will do all the calculations of the distance of the new data point, like for example, the new image of the cat or dog from all the other data points that you have. So it will calculate all the distances, and then we'll check for those data points which are, or the k data points which are nearest to this. So that's why it's called lazy algorithm, because nothing happens till the point, or no calculations happen till the point you are actually trying to predict something. So there is no training step involved. Okay, and then it's used for both classification and regression, as we just mentioned. So it can be used to predict the values as well as be able to classify something like, okay, whether it is a cat or dog, or if you're trying to, let's say, predict some value, some forecast or something, that for that also you can use it. And then it is based on feature similarity, which is basically, what do we mean by feature similarity? So feature can be things like, if for example, you are looking at classifying cats versus dog, right? So is the eyes like a dog? That can be one of the features. How do the ears look? That can be one of the features. What about the tongue, the face, and so on? So there can be multiple such features, and how similar these features are between two data points, which is used basically by the KNN algorithm. And then, as I said, there is no training step involved. So these are the features of KNN algorithm. And therefore, now let's look at actually just some simple examples of how it works. So as you can see here in this slide, we have two classes of data. So one is all these blue data points, and there is another one which is the orange data points. Now, if you have a new data point, which is this pink one here, which class should it belong to? Should it belong to class A or should it belong to class B? So what you would do is you would actually start calculating the distance of this pink data point from every square or blue triangle data point. And then you will decide, you will have to assume a particular K. Let's say K is 3, right? Which is, I'm looking at the nearest 3 data points. And in that case, basically, as you can see, if we draw this circle, right, then we see that 2 of the nearest data points within that circle is of the square orange kind. So basically, we will predict that this particular new data point belongs to class A. Whereas K value was 7, right, as in this particular example now. You would see that 4 out of the 7 is actually of the blue triangle kind, and therefore we will now classify it as belonging to class B. So essentially this prediction changes, as you can see here, depending on what is the K value. So therefore the question is, what should be the value of K, right? And typically what happens is you run a trial and error, and basically you come up with, okay, what is the best K value? But essentially what one needs to understand is that as the value of K increases, basically the partition line starts moving towards becoming more and more linear. So it starts becoming less flexible, and it starts assuming some kind of a linear dividing line or something like that. So what happens is that as you increase the K, your bias basically increases, but your variation reduces. So we know that in classification problems or in machine learning problems, bias and variance are two things that we are trying to manage, right? Bias is basically how close you are to the actual class or to the actual value, whereas variation is how much variability is there in your prediction. So as the K increases, the bias sort of increases, but the variance reduces. And then it is vice versa. So if your K decreases, let's say at K is equal to 1, where you are only looking at just one nearest neighbor and then predicting based on that, actually the bias is the least, which means it is the most flexible. K is equal to 1 will give you the most flexible sort of demarcating line or function, whereas the variability will be the maximum. So that's the sort of the trade-off, and that's how we actually determine K. So we have to get a K value in such a way based on trial and error that sort of maximizes our or reduces the bias as well as the variance. And And that's the kind of optimization we are trying to do. Okay, so how do we calculate the distance itself, right? And distance typically can be of many kinds. So, the example here is of the Euclidean distance, but you can have other kinds of distances like Manhattan distance or Mahalanobis distance, and you can look up references for other kinds of distances. Now, Euclidean distance is calculated for the point P1 and P2 as given here. Essentially, Euclidean distance is nothing but the square root of sum of the x coordinates of these 2 points P1 and P2, and then y coordinate square of these 2 points P1 and P2. And this is just an example of one kind of distance, and other kinds of distances like Manhattan or Mahalanobis are also there. And then calculating this distance becomes quite challenging, especially in cases where you are trying to, for example, calculate, let's say, how close two LinkedIn profiles are, right? Or trying to classify the category of electrocardiogram and so on and so forth. So there we have to bring in more creativity to just decide what kind of distance to use. Okay, now let's move ahead. We will now talk of some use cases where KNN can be used, and this is an example of how KNN can be used for book recommendation. So if you have purchased books on Amazon or wherever, right, some of these recommendations are based on KNN algorithm. And then as we said, KNN is like based on features, right? So maybe let's say what will be the nearest neighbors of a particular book. It can be based on who is the author, what is the topic, and so on and so forth. And then there are other use cases like I mentioned. So for classifying satellite images, for classifying handwritten digits on image analytics, or for classifying electrocardiograms, etc. Typically KNN can be used. Okay, so now actually we will get into some hands-on. Okay, so to start the hands-on session, I'll go to this Jupyter notebook that I already have installed on my system, and I have a certain code written which we will take 2 examples. Both the examples are based on data sets which are available in the open source, so you can easily get access to that data. So what we do is we start by importing the necessary libraries. So we import pandas, Seaborn, NumPy, and Matplotlib. Basically, pandas and NumPy are there for doing the data manipulation and also for storing data as matrices or as arrays, and be able to perform some mathematical procedures on them. And then Seaborn is basically used for plotting, and Matplotlib for plotting as well. And this line here, get IPython, just helps us to run the images that we'll be creating in line with Jupyter Notebook instead of opening up a new window. So let's run this, and what it will do is it will import all these packages for us which we are going to use. And then we will first import the breast cancer data that is available in your scikit-learn datasets. So we import that, and then let's just initialize that data into a variable here called cancer. So cancer here represents all the breast cancer data. And now let's actually look at what this data is. It's a bunch of attributes in this dictionary here. So you have data, the target, which is basically nothing but whether it is a cancer or not. So whether it is malignant or benign. Malignant means it's a bad cancer, and benign means, well, it's just a tumor, it's not cancerous. Target's name, description, feature names, which is basically the features that will tell us whether a particular case belongs to cancerous or non-cancer, or malignant or benign. And then actually let's just print the description of this particular data here. So as you can see, we can use this command to print the description here. And then we see that there are 569 data points with about 30 attributes. And these attributes are radius, texture, parameter, etc. And the max and min values of those are given here. And then now let's look at some of the feature names. So these are the feature names, radius, texture, and so on. And now let's actually set up a data frame of this particular data here using pandas, this function here. So there are 569 data points, and all these are basically your features as we talked about. And let's look at the target variable, which is nothing but whether it is telling us whether a particular data point belongs to malignant or benign. So 0 is cancerous and 1 is non-cancerous. And then we convert the target into a data frame as well. And then let's look at the couple of examples of how the data points look like. This is, one row of the data points with all the several feature values that we have. So basically we use this package called standard scalar from scikit-learn for pre-processing and for standardizing the variables. And we initialize this standard scalar into a variable called scalar. So standardizing is nothing but, basically bringing all the samples to essentially the same range, right? Because what might happen is some of the data point, like for example, temperature might be from 0 to 100, and some price might be from, let's say, 1,000 to 100,000 or whatever, right? So the absolute values can lead to some issues with respect to the prediction. Therefore, we have to standardize it or bring it between, let's say, -1 and 1. So, and then a mean of 0, right? So we have to bring everything to the same scale to be able to compare the samples. So we first of all, we fit this standardization or normalization on the data set we have. And that is, we calculate the variance and the means, and then we actually apply it on the data set to transform it to the actual values. And then if we look at the scaled values now, so let's look at the scaled values. And this will give an example of the top 5 rows here. So we can see now the values are between -1 and 1, or rather it is standardized essentially with a normal distribution. And then we divide this data into test and train. So basically we will train the model and then we will test it on a separate data set. If you use the same random state, you should be able to get the same result. Otherwise, you may get a different result here. And essentially, we are keeping the testing size to 30, which means that we are dividing the entire data set into 2 parts. The train part, which is having 70% of the data, and the test part, which is having 30% of the data. And again, we are using this package called train test split from the scikit-learn package. So we get the X and the Y's, which are basically nothing but your train, and the X's are your predictors and Y is your predicted variable, whether it is cancerous or not. And then now let's import the k-nearest neighbors classifier. This is the actual algorithm, which we are importing from scikit-learn package. And now we initialize this particular algorithm, and then we fit it on the data. And some of the parameters, as you can see, is basically what is the leaf size and so on and so forth. The nearest n neighbors we are taking. So we are taking k is equal to 1 here, basically, as of now. We will see the results based on that, and then we will change it and see how the results vary. And we now run it on we now try to predict it. And then we will now try to evaluate what the results look like. So we have imported the classification report and confusion matrix, which is basically trying to see whether we were able to correctly classify the cancerous as cancerous and non-cancerous as non-cancerous or not. So we can see that this is the actual and this is the predicted. So basically some data points here, 5 and 4, are classified wrongly. Otherwise, all the others are classified well. So if we look at the accuracy, calculated accuracy actually, so we see that the precision, which is true alarm, right, which is basically from the cancerous samples, how many were you able to actually predict as cancerous? So if you see, the accuracy is quite high, almost 94-95%. And then the recall, which is from all of the cancerous samples, how many were you able to actually predict accurately, is about, again, 94-95%. And F1 score is nothing but a combination of both precision as well as recall. and that's quite good as well. So with k is equal to 1, we are able to get already some good results. Now let's try to see how to choose the k value, right? So this is basically nothing but a bunch of code that actually runs the k value from 1 to 40 and then tries to check the accuracy. And this is just like doing a trial and error to see where we get the best results so that we can then use the best k value. So if you can see this particular plot here, after we plot the result from the running the trial and error from 1 to 40, we see that the error actually starts decreasing, and somewhere around this k is equal to 21 we get the minimum value of error. So for us the best k value is 21. So now if we compare the results between k is equal to 1 and k is equal to 21, we should be able to see the prediction result. So as you can say, this was the result with k is equal to 1, which is we get about 94-95% accuracy. And then with k is equal to 21, we will see whether the accuracy improves, right? So we see that yes, the accuracy has now gone up to almost 99%, which is, we earlier had 9 misclassified data points out of all of the points, and then here we have just 2 data points which are misclassified from the test data set. So now this was one example of applying KNN on the cancer data set, which is available freely. And now let's look at another example, which is the iris data set, and again available freely as well. So iris is a type of flower, and we will see what flower is it. So just give me a moment here. So we again start by importing the necessary libraries, and then we'll look at what this iris data set is. So the iris data set comprises of 50 samples of 3 species of iris flower, which is iris setosa, iris virginica, and iris versicolor. These are the 3 types of iris flowers. And if you run this, basically we will find that, okay, sorry, we did not copy the code here, so it was giving an issue. Let's just run it again. Okay, so we see that it is this particular flower, which is iris setosa. So the iris setosa you can see. And now let's look at the other 2 kinds of flowers here. So which is iris versicolor. So this is iris versicolor, and then you have the iris virginica. So we see that this one is iris virginica. So essentially we now will import the sort of data set. We have already done that, and we will now use the Seaborn package to actually plot some of this data and see how it looks like, which is basically do some kind of exploratory data analysis. So if we look at the data itself, so this is the top 5 rows from the data, right? So essentially the data consists of basically what is the sepal length, sepal width, petal length, and petal width. And this is nothing but basically your petal is your this colored part of the flower, and the sepal is basically your green part here, right? So it is talking about what is the sepal length, sepal width, and petal width of each of the species, whether it is setosa, virginica, or versicolor. And we will see whether we can use KNN to actually classify these flowers into the data points into these categories of flowers. So let's do some quick exploratory data analysis on this. So we are running a pair plot on the data set, and in the meantime I'll just copy another part of the code here. Okay, so now the plot has come up. So as we can see that the green is basically your setosa flower, and we can see that this pair plot actually just plots the sepal length, sepal width, and the petal length, petal width of each of the samples of setosa, versicolor, and virginica. And we see that the green dots, which are the setosa flower, is actually quite separable from the others. It's when you plot, let's say for example, sepal length and petal length, right? We see that this is quite separate from the other data points. So let's see whether we can actually be able to classify it using KNN or not. And here we are running a kernel density estimation function on the setosa flower to check what kind of distribution it has. So this is the kernel density estimation plot using the SNS package. So only for the setosa flower. So if we plot the sepal length and sepal width, we get something distribution like this. So essentially we see that the maximum centered around here, and then there is a distribution as you can see here. So there's some kind of a linear relationship here. Okay, so now we will again do the same standardization of the variables that we had done in the cancer dataset case. So we are importing the standard scalar function from the scikit-learn pre-processing. So we will initialize that. So we are again basically doing the standardization or normalization of the data. And we will do the standardization on everything except the species, which is a categorical value, right? So it's categorical whether it is which kind of flower it is. So we have removed that, and then we have done the standardization or normalization on rest of the data. So we now convert this into a data frame, a pandas data frame. And if we look at the top 5 rows, now it's all converted or transformed. So the values are now normally distributed basically. Okay, so now we divide the data again into train and test. And we again have a training of about 70% and test data set of about 30%. So we are dividing that entire data set into these 2 buckets, and we will now use KNN to see if we can use KNN to classify them. Again, the same n k is equal to 1, and we will check the results, and then we will do a trial and error to check what is the best value of k. So here k is equal to 1, and now we are going to predict on the test data set and look at the results. So we are now importing the classification report and the confusion matrix. So if we look at the confusion matrix, we see that kind of already we are getting quite good prediction. So just 2 misclassified points. And if we look at the accuracy, we see that the accuracy is quite high, around 96% already. Now we have to see what is the best value of k. So essentially we will again run k is equal to 1 to 40 and check which is the best value. So let's plot the errors when we vary the k from 1 to 40, and we see that actually the error decreases and then increases. So basically the error is minimum with k is equal to, let's say, 3 or even 5 or maybe 11. So let's choose one of these values. So let's say k is equal to 3, and let's see how the results look like. Does it improve the accuracy or not? So we now see that even the 2 data points which were misclassified earlier is now classified properly. So the accuracy improves to 100%. So that's the example of how you can choose k. So we have covered the hands-on, and now we will look at some of the references. So some of the references are basically these 3 textbooks here, which I found quite good. Some of them are even available online, so you can refer to them if you want to learn more about KNN. And also they are quite good references for some of the other techniques as well.
So let us now talk about what is naive Bayes. Okay, let us understand naive Bayes with an example. Here I just cannot seem to figure out which are the best days to play football with my friend. Can you please help us out? All possible conditions are given to us. There is summer, monsoon and winter, which is nothing but the outlook. Am I correct in saying that? Summer, monsoon and winter is nothing but the outlook. Then we have sunny or not sunny. So that basically is the humidity, right? And then we have windy or no windy. That speaks about the winds. How are the winds, right? So if you look at these combinations, okay, we will look at this using navy Bayes on how do we decide whether we can play or not. So if I have noted down all the days it was good, bad to play football and the combination of weather matrices on that day, that will be perfect, right? That is perfect, and we will be able to do navy Bayes classifiers using that. Now, Navi-Bayes classifier comes from the Navi-Bayes theorem, and Navi-Bayes theorem is purely and purely based on the assumption of independence. So what does it mean? When I say independence, what it means is that this variable has no relationship, no association with this variable. Now, when I talk about this in a linear context, obviously in summer you will see that we have more sunny days. Yes. So if you look at it from the correlation area, from the linear algebra concepts, linearly these two are correlated to each other. Am I correct in saying that? Obviously in monsoon we have less sunny days, in winter we further have less sunny days. Yeah. So although there is a relation, Navi-Bayes theorem says that all these variables are independent of each other. What does that mean? If this is causing any kind of an effect, if this is causing any kind of an impact, this should not matter. Okay, there is going to be no relationship. Summer, monsoon, winter, it has its own weightage. Okay, and it has nothing to do with the other conditions. Every condition is equally significant. All right. So what happens in Navi-Bayes is we estimate the posterior probability of every event happening. Here we calculate the posterior probability of an event happening. Okay. So here if you see, if you look at the sunny conditions, what we have done, sunny conditions, we have this distribution that there is no play happening in summer, there is play happening in monsoon, there is play happening in winter, right? So base of the season, we are figuring that out. Similarly for windy conditions, we are doing that, right? Again, then we do it for a combination, right? Whether when windy conditions are yes and no, what happens to play? Okay. So here, what at the end of the day, what gets selected is the one which has a posterior probability of greater than 5. Now, when I talk about posterior probability, what do I mean by posterior probability? Let me have a blank slide. Here you go. Actually, it's given, so I need not show you that. What is the simplistic probabilistic classifier here? What is the probability of an event A happening given B? So if you look at our problem context, what is it that we are trying to figure out? We are trying to figure out what is the probability of play happening given the outlook is sunny, comma, the winds are normal and there is no rain. On any given day, when there is no rain, there is no wind, and the outlook is sunny, whether play will happen or not. So what we end up doing is we calculate the posterior probability of play happening given these conditions. We also calculate the posterior probability of play not happening given these conditions, and then we normalize these probabilities. Mathematically, we do all of these calculations to figure out Navi-Bayes. Okay. Now here, see, here we are talking about one event. Here we have three events. We have outlook, we have winds, and we have rains. So what this becomes is probability of three independent events. So what we will do, we figure out what is the probability of play happening given outlook is sunny. We also figure out what is the probability of play happening, multiply this with the probability of wind as no, given no, Then probability of play happening given rain is no. We figure out all the three independent probabilities, multiply it. All right. This is what we do mathematically. This is what is done mathematically in Navi-Bayes theorem. Ultimately, the posterior probability of an event A happening given B conditions is calculated by first calculating the class probability. What is the class probability here? Probability of it raining given play was happening in that day. This is multiplied by the total probability of play happening and divided by the total probability of sunny conditions. Here, as you see, this is the posterior probability. This is the class probability. Here is the predictor's probability. This is the outlook. X is the outlook. C is what we are trying to predict, right? And here is the likelihood. So how is this formulated into our table? Now, if you correlate this to our graph, what will be the likelihood? What will be the likelihood of sunny conditions given play happens? Sunny conditions, play happens. 2 divided by 3 out of, sorry, how many sunny conditions do we have? 6 conditions. In 6 conditions, how many days does play happen? 2 days. 2 by 6, 1 by 3. What is the class probability? So of all the events that are given to us, how many days does play happen? Okay, this is how this is calculated. So here you see what we have done is, let me go back to the previous slide. Here you go. Okay, here what we have done is we have calculated this table. Now it speaks about a data set. Where can you get this data set? You can look for golf play days data set online. You can look for golf play days data set. Okay, in this data set you will find all the data which is required for this particular example to be done. So what I will be doing is I will be doing this example, this Navi-Bayes classification with you in Python. All right, so whatever calculations are being done here, okay, I will do the same activity in Python with pen and paper, and instead of doing this in a numeric way where I'm doing a lot of probabilistic calculations, I will achieve this simply in very limited lines of code, with Python. Once I have done that, I will come and explain this probability table to all of us. I'm going to use some basic libraries. All right, so here what I will be doing is using some very basic libraries for this activity. All right, done. Now let me quickly go and read the data set. So for that, what I will do is quickly change my working directory. And now let me quickly go and read my data. So my data frame is pd dot. Here you go. This is my data set, right? So if you look at this data set, in this data set, you have 14 days. In these 14 days, you have the outlook, overcast, rainy and sunny. You have temperature. Temperature is hot, cool and mild. You have humidity, you have wind, and you have play, right? So I will not be using, okay, let us use all 4. In this example, they are using only 3 variables, but in our hands-on, okay, in this hands-on, what I will be doing is I will be using all 4 variables. Let us do that. Okay. So before I do that, let me convert everything into a category. If you look at your data frame right now, it's not, everything is not into a categorical variable. Here you go, see. Okay. So let me quickly go and convert everything into a category. And once I have done this, let me create a new data frame in which I have everything as a category code, so that I have numbers. I'll show you what do I mean by this. So let me execute this. Here you go. See, now I have 2 data frames. In the first data frame, I have all these values. These are now categorical variables. But in the second data frame, I have all ones and zeros. So wherever you see there is sunny conditions, now I have a code 2. Rainy conditions, code 1. Similarly, when play happens, I have a 1. When play does not happen, I have a 0. This is what I have done. This data frame is available online. Okay, you can get this data frame online. All right, now my data frame is ready. So now what I'm going to do is I'm going to divide my data frame into training and testing. I have 14 records. So let's take 10 records for training. I will give 10 records as an input, and I will give 4 records, last 4 records, as my test data frame. All right. So now I will need to create my X and my Y. So how I will do that is I'll say Y underscore train is equal to, from train, I don't want the play variable. That play variable should be my Y. As simple as that. And I will say X underscore train is equal to train. Okay, and I will do the same thing for my test data frame also. Now those who are new to Python will find this a little bit strange. Please bear with me. But these are the only calculations, only steps which need to be performed every time you are trying to achieve Navy bias algorithm or any kind of an algorithm. Right? So here, now you see, this is my training data frame in which play variable is not there. Play variable is not there. This is my Y, in which only play variable is there. This is my training data set. So both of them have 10 records with the matching index. Similarly, test data frame, 4 records with the matching index, right? So that we know which data frame is where. Now, multinomial Navy bias. Very simple, 3 lines of code and my model will be done. Okay, first I initialize my model. Here you go, I have initialized my model. In this model, I fit my data. In this model, I will fit my data. So to do that, what I say is fit X underscore train comma Y underscore train. Done. Your model object is now ready. And now you can simply get the classification outcomes. So we have in our test data frame, if you look at our test data frame, this is our test data frame. We have 4 conditions. All 4 are sunny, high temperature, low humidity, and windy, right? And if you look at their outcomes, these are their outcomes. On the first 2 days, play is not happening. On the next 2 days, play is happening. Let us look at what is the prediction of our model for this. So to do that, what I simply do is X out is equal to model.predict. To this, I give my X underscore test. Here you go. Okay. Now you have your y out variable. So this is the prediction for all the 4 inputs that you give, and this is the prediction. First day, we say play does not happen. Let us match it. Let us try to match it with our here. See, out of 4 records, 3 records we are predicting correctly. 3 records we are predicting correctly. If you want to check the accuracy, what is the accuracy of your model? What you can simply do is print. Let us print the accuracy on both training and testing. Training accuracy. How do I get the training accuracy? Very simple. Model.score, and here I give my x underscore train comma y underscore train, and then we do the testing accuracy also. Here you go. So here you can see for our model training we have 80% accuracy, and for testing we have 75% accuracy. Okay, so this is the advantage of doing this activity in Python. But what is happening in the backend? Now let us go and also understand that in terms of naive Bayes classifier. We have successfully implemented the naive Bayes classifier in Python programming language. But here, let us try to understand Bayes theorem, what is happening. So from this data set, all the tabulated data, frequency tables are calculated. Once the frequency tables are calculated, they are substituted in our formula to calculate the probabilistic scores. So what is the probability of summer given it is playing conditions? Total, how many playing conditions are there? Total, there are 9 playing conditions. 9 days play happened. That becomes our denominator. Out of those days, how many days was summer is our numerator. That is how for this we get a probability of 0.33. Then we calculate the class probability, where we look at how many days was it summer. Out of total 14 days, 5 days was summer, so that's the probability, and the class probability is 0.64. Put everything into our equation, and this is what we get. Okay, so we do this for each and every condition. So here we calculated for winter. All right, once we have done it for all 3 days, winter, sunny and windy days, we substitute those here, and that gives us the probability which is more than 0.5. Thus now we can say that if it is winter, sunny, and conditions are sunny and there are winds, conditions are not sunny and there are winds, play can happen. Look at another example. If a single card is drawn from a standard deck of playing cards, the probability that card is a king is 4/52, since there are 4 kings in a standard deck. King is the event. This card is a king. This is the event. The prior probability of this is 1/13. If evidence is provided, for instance, someone looks at the card that the single card is a face card, then the posterior probability can be calculated using Bayes theorem. Okay, since every king is also a face card, the probability of face happening given you getting a face card given it's a king is 1. Since there are 3 face cards in each suit, all right, it's actually 4. Ace is also a face card, so it's jack, king, queen, and ace. The probability of the face card is 4/13. Okay, so if you combine these 3 likelihoods, what you get is 13/4. So using Bayes theorem, this is the probability that you get.
What is support vector machine? Now, as you have seen already, support vector machine comes under supervised machine learning, and we use it specifically for performing the task of classification. So support vector machine is a discriminative classifier that is formally designed by a separate hyperplane. Okay, it is a representation of examples as points in a space that are mapped so that the points of different categories are separated by a gap as wide as possible. So in this case of this support vector machine, let's say I have some data points. So there are some data points of X and there are data points of circle. Now this support vector machine is a type of machine learning algorithm where if I have the collection of points, so here in this data points I have two classes, one is X and the another one is circle. Now given this kind of data points, okay, given this kind of binary classification problem, so the expectation is, in case of support vector machine, I'm going to draw a hyperplane which separates as much as possible. Okay, so I'm going to draw a hyperplane which separates these two classes as much as possible. So it says that I'm going to draw a hyperplane and it will be separated by a gap as wide as possible. So that is the intuition behind support vector machine. Okay, now that you have an intuition behind what is support vector machine, let's understand as how does this SVM, that is support vector machine, would work. So in case of support vector machine, so here there is one more example. I have this set of points which is green color, and I have another set of points which are in red color. So these two points are belonging to the different classes. Now what I'm going to do is I'm going to draw a hyperplane which separates these two classes data points as much as possible. And when I'm drawing the hyperplane, I'll make sure that this hyperplane is equidistant from my support vectors. Now the support vectors is nothing but the point which is closer to my hyperplane. Now here in this example that you're seeing, this data point and this data point are called as support vectors because these are the data points which are nearest from my hyperplane that I've just drawn. If I'm trying to make use of this SVM model, it is going to draw this kind of hyperplane to make sure that it is separating two classes. The two classes that we have over here in this example is red and green. It's going to separate these two classes as much as possible, and it will be equidistant from my support vectors, and the support vectors are nothing but the nearest point to my hyperplane. And that is how I'm going to separate between two classes when it comes to support vector machines. Now here in this example that you're currently seeing, the hyperplane that I've just drawn, so this is a simple linear hyperplane. This is like a straight line that I'm trying to draw if I want to separate two classes of data points. Now, apart from drawing this straight line, we also have other kind of lines as well which we can draw. So let's see how we can do that. So the types of line that we can draw, or the hyperplane that we can draw, is called as SVM kernels, that is support vector machine kernels. The example that we have seen, it's an example for linear SVM kernels. So let's see what are the other types of kernels that we have. So when it comes to SVM kernels, we have linear kernels, radial basis function kernel, and along with that, we also have polynomial kernel. Now, in case of linear kernel, I'm going to draw a hyperplane which is like a straight line. In case of polynomial kernel, I can draw my hyperplane on the basis of polynomial function that I have created, on the basis of number of variables that I have and the degree that I have over there in case of polynomial. And in case of radial basis function, so I'll make use of radial basis to separate my data points. Okay, so these three are the important kernels that we have in SVM, and this is one of the commonly asked interview question when it comes to the topic of support vector machines. Now, let's look at some of the use cases or the way we can do, where we can use this SVM to work, or let's look at some of the use cases where we can use this SVM. Okay, so we can use this SVM on many of the use cases. So to name a few, we can use it in face detection. We can use it in text and hypertext categorization. We can use the SVM if I'm trying to classify any images. I can make use in bioinformatics. And if I'm trying to detect something, so I can, in an example here, remote homology detection, handwriting detection, or In general, we can make use of this generalized predictive control. So wherever we are dealing with the task of classification, we can use this SVM model. Okay, now that we have a theoretical understanding as what is SVM and how it is actually going to look like and how it will be, let's have a quick walkthrough as how we can implement this SVM. Now, to implement this SVM, these are the common steps that we are going to follow. We are going to load the data, we'll explore the data, and once we have explored the data, we are going to split the data into two parts. The reason is simple. When I have training, so I'll be making use of my training data, and once my training is complete, I'll check how my model has been trained with the help of my test data. So I'm going to split the data. Now once that is complete, we are going to train this SVM model, and finally we can evaluate the model and observe as how model is working. So this is the overview of the implementation of support vector machines. So let's do one thing. Let's work it out and let's create the notebook in Google Colab and let's see it in action as how we can implement this SVM. I'll come back to my Google Colab. So this is the notebook that I have already prepared, and I'll give you a walkthrough as we proceed along. Now here in my first cell, I'm importing my NumPy library, pandas library, and along with that, for creation of plots, I'm importing my matplotlib library. Now if you are comfortable with Seaborn, you can use the Seaborn library as well. So in my example, I'm just making use of matplotlib because we are not interested in creation of visualization, but we want to understand as how model is being working. Okay, and I'm going to execute this cell. So this is going to take care of necessary imports. I'm importing my necessary libraries. And once that is done, here I'm importing this SVM. So this SVM model is available inside my sklearn library. So I've mentioned as sklearn.svm, and from sklearn.svm, I'm importing my SVC. Okay, so I'm importing my SVC. So I'll show you what is this SVC. SVM SVC. So it's C means support vector classification. Okay, now here when I'm instantiating this SVC, I can mention what is the kernel that I want to use, and if I'm working with any polynomial kernel, then I can also mention what is the degree of polynomial that I want to use while performing the fit for my data set. So I'm importing my SVC, and along with that I'm also importing the data sets. So in the sklearn library itself, we have a data set. So sklearn host already, like it actually, sklearn has many toy data set which will actually help us in our learning journey. So we are going to use one of the data set, the famous iris data set. We use that for multi-class classification. So I'm going to load that iris data set, and I'm just going to extract only two features. So the two features that I'm extracting is petal length and petal width, because I don't want to complicate it. I just want to visualize the data. So in order to help me in visualization, I'm just getting only two features of my given data, and I'm separating my y as iris target. So whatever the target variable that I had, I'm assigning to my variable of y. Then I'm going to do this check whether it is setosa or versicolor. That means this default data set, which is in multi-class classification, I'm just going to convert it into a binary classification task. You'll get a better understanding once I execute this next cell. So this is going to prepare my data set, and once the data set is prepared, if I create a scatter plot, so I'm just creating the scatter plot to show us what and how my data set looks like. So this is how my data set looks like. On my x-axis, I think I'm having petal length. On my y-axis, I'm having petal width. And here, the blue points refers to the class 0, and the orange points refers to the class of 1. Okay, so this is how my data set looks like. you can clearly see that I have one set of points in one region and I have another set of points in another region. Now this is a classic example to understand about the SVM. How does it draw a hyperplane? So we have the data set ready, and as I mentioned already, in order to fit this model, so when I say support vector machine, I'm going to draw a line. This line that I have drawn, it will be equidistant from my support vectors. Now here in this example, the support vector is this because this is the only point which is nearest to my line. And here I think this is the data point which is nearest to my SVM line, that is this fisted line, hyperplane line. So I'll be placing this hyperplane such that it is equidistant from the support vectors. That is how I'll be drawing this support vector line. So we now have an intuition. Let's see whether we get the same outcome as we are expecting. So here I'm initializing my model. So for initialization, I'm saying it as SVC. Use the kernel as linear because I'm able to draw a line effectively. We just seen, and I'm using the C as infinitive. That means it should be a hard classifier. So hard classifier means I want the 100% result. I mean, I don't want any loose ends. I want to draw a line which clearly separates two classes. So I'm saying it as C as infinity to mention this as a hard classifier. And once I initialize any model, here in this scenario SVM model, I am performing the fit on my data set. Now this is the common flow that we follow whenever we are performing the fit. So we'll initialize the model and then we perform the fit on a data set. Now since this SVM being a supervised machine learning model, I have to specify both my input X as well as my output Y. Hence SVM classifier.fit X, Y. So this is going to perform the fit for my data set. I'll just execute this. So this has performed the fit, and here it is giving me the confirmation as this is the parameter that are being used to perform the fit. Okay, now once I have drawn and once I have found this fit, next if I want to display the weight terms, so I can say it as SVM classifier dot coefficients. So these are the weight terms. And if I want to display my bias term or the intercept, it is minus 3.78. Now this means the line that I have just drawn, so that line has the C term as, or the W0 term as minus 3.78, and W1, W2 are 1.29 and 0.82 respectively. So that's how that data is distributed for us. That's how the values has been found for our scenario. Next, in order to get the better visualization, here I have created a function that is called as plot SVC decision boundary, and this takes my SVM model, the Xmin and the Xmax. Now W and B I'm extracting from the coefficient and the intercept parameter that we have over here. So we are extracting from this attributes that we have from this model. And now if I want to draw a decision boundary, so I need the set of points. So in order to get the points, I'm saying it as x0 is equal to nb dot linspace xmax comma xmin comma xmax comma 200, and I'm specifying as how does my decision boundary should look like. My decision boundary is given by w0 into x0 plus w1 into x1 plus b is equal to 0. So this is what my decision boundary would look like. So I know what is x0, I know w0, I also have w1, and I also have b. So the only term that I do not have is my x1. Okay, so the only term that I do not have over here in this example is x1, and the x1 if I want it, so I just have to substitute it. So x1 is equal to minus w0 divided by w1 into x0 minus b divided by w1. Now I'm specifying the same equation over here for my x2. So my x0 and the decision boundary will give me the pair of input and output. Okay, now along with this, there is a property in SVM. Okay, so the property is given by whenever I have a margin, so that margin is given by 1 over w1. Okay, so the margin is nothing but the distance between my hyperplane and the support vector. So that is given by 1 by W1. Hence, I have mentioned as gutter up and down. Gutter up means one line, or the one line where the support vector lies. So that is given by decision boundary plus margin, and one line below my below my hyperplane, that is where another support vector would lie. So I have mentioned as decision boundary minus margin. Okay, then I'm defining where exactly my support vectors are present. My support vectors, I can access the support vector coordinates by saying it as, by accessing the attribute of my train model, support underscore vectors underscore. Now I'm specifying where exactly those support vectors are present with the help of a simple scatter plot by highlighting my support vectors. And I'm specifying where exactly my decision boundary is present. And I'm also mentioning where is my line that is gutter up and gutter down. So let's do one thing. I'll just execute this. This is going to create me a function. I'm going to call my function support vector machine classification, and I will specify my range of x and y as here, yeah, x min and x max as 0, 5.5. I'll just execute this. So what we have done just now is we have created this hyperplane. So the middle one, the solid line that you're seeing over here, so this solid line is called as your hyperplane. And these points that you're seeing over here, so these 2 points which are highlighted, these 2 points are actually called as support vectors. Okay, so this dotted line that you're seeing, so this dotted line refers to my gutter up and gutter down, which I've found right here. Let's do one thing. I'll add some labels so that you'll get some more visualization in the plot itself. I'll say label, and I'll mention it as hyperplane. Okay, and there is one more, yeah. These are support vectors, and I'll say pld.legend. So this clearly says which are all my hyperplane and which are all my support vectors. So this is the intuition behind support vector machines. So we'll be drawing a hyperplane which separates the points that we have. Okay, and whichever the point which is nearest to my hyperplane, we call that point as a support vector. Now to access that support vector, we make use of the attribute. So let's do one thing. Let's explore the attributes. svm dot support underscore vectors underscore. So this is going to tell me where exactly my support vectors are present. So one point is given by 1.9.0.4. I think this is the point that I'm talking about. And the another support vector that we have is at the location 3, 1.1. So 3 and 1.1. This is where we have another support vector. So using all these attributes, we have been able to create this visualization. Okay. Now, whenever we are working with the support vector machines, it's very important that we scale the data first. If I do not scale the data, I'll not be able to get a better fit of my SVM model. So here I've given one more example where I have my X is given as 1, 50, 5, 20, 3, 80. As you can clearly see, it's not scaled. Okay. So I'm going to execute this cell. So this is going to tell me and give me a visualization as how the fit will be in case of scaled and unscaled. See, if it is unscaled, if it is not scaled, okay, that means if it is unscaled, we can clearly see that the hyperplane that I'm drawing and the distance from my hyperplane, it's very close to each other. And whenever I'm working, it will be difficult for me to separate those two data points. But if I scale them correctly, now here for scaling, I have made use of a scalar and standard scalar. Now if I scale it correctly, then in that scenario, it will be easier for me and it would actually work better when I have scaled data. Okay, so this is about using the linear SVM model to perform the fit on my given data set. Now, if I go below, we have some more examples about nonlinear classifiers as well. Now, in order to test out the same, here I'm creating an example data set, and that data set that I'm generating is called as make moons data set, and this has been generated with the help of sklearn dataset generator. Now, as you can clearly see, I cannot make use of linear classifier. So linear classifier is nothing but a classifier, okay, which is an SVM model where I'm drawing or where I'm using a straight line to split my data points. I can clearly see that wherever I join or wherever I try to draw a line over here, I cannot split the data in an effective manner. Now this brings us the challenge. Now if I have a data set in this way where I cannot linearly separate it, how can we go about and perform the fit on our SVM model? So in order to save us, we have a model that is called as SVM model, and from that SVM model we can actually create a polynomial kernel. So we can make use of polynomial kernel, and using that polynomial kernel I can actually create it like this. I mean, using polynomial kernel I can perform polynomial regression, or I can draw a line like this. Now to show you how it works, I'm getting some data like this. So this is some random data, and I'm making use of pipeline. So this pipeline is going to take care of my standard scalar as well as kernel. I'll do one thing, I'll just come below. So this is what we are currently interested in. So here I'm importing the polynomial features, and I'm generating the polynomial features for my data. I'm performing the fit and transform my polynomial data. That means I'm just modifying my existing data and I am sending it for my x. Okay, so this is how my pair of input x and y looks like. Now I'll use my x. I'm going to transform it with the help of my polynomial features, and then I'm going to scale it with the help of my standard scalar, and I'm going to send it inside my classifier, that is SVM classifier. Okay, so I'm going to combine it together like this. Now observe what would happen. And once that is complete, see, with the help of my polynomial features that I have applied on my given linear data, so I have increased the degrees by which my model can learn. Now instead of straight line, my model is also having the ability to learn this complex representation as well, because I have increased the model complexity by adding my polynomial features. And while doing it, to make sure that we follow a clear path, so I have defined this sklearn pipeline. So if you're new to data science machine learning, I highly recommend you to learn this concept of sklearn pipeline. Now this sklearn pipeline helps us to combine multiple operations in a single call. So here we have created a pipeline. This pipeline is going to add some polynomial features for my input data, and on top of it, this is going to perform scaling, and then I'm going to perform this binomial classification using this SVM. And finally, I'm performing the fit on my data set. See, when I perform the fit, it takes my input x and it's going to do all these activities. It is going to chain all these activities together, and then it is going to perform the fit for my data y. Once the fit has been complete, so we can validate how my model is performing.
So what is a clustering technique? Clustering technique is something that we will use it for grouping purpose. So especially there is a very easy way to understand what is clustering technique. You would have seen such while we are going through an COVID-19 situation, the government has came up with creating some containment zones, as all of you must be knowing. So how, on what criteria government has taken that, okay, which area is supposed to be a containment zone, or which area is supposed to be applied with some restrictions, or which areas can be considered as normal, on what criteria that they have created. So that's what using clustering technique. Which means the governments, or when I say government, means that the people who will be taking the final decision in such criteria, either prime minister, either the chief ministers of that particular state will be taking decisions whether to go for a lockdown, whether to not to go for lockdown, or which areas has to be considered as containment zones or non-containment zones. So those high-level decisions are something which will be taken based on the clustering technique output which is generated by these algorithms, based on a number of inputs. Okay, what is the population in a particular area? How many number of people are affected? How many number of hospitals which are present? How many number of people who are been recovered? So likewise, based on these multiple criteria, people will do some clustering technique on top of the data, and according to that, people will be segregated, or the areas will be segregated. So that saying that, okay, these are the observations which belong to one cluster, these are the observations which belong to one cluster, like that, so that people can cluster them, which can make organizations to take decisions on a very high level. Okay, that's what is our clustering technique. Which clustering technique output will contain the different groups. It itself will group the different components based on whatever the number of clusters that you want to generate. That may not give the direct output. On top of the generated output, people will be taking business related decisions. That's what is all about clustering techniques. Okay, so now what we will do, let's take an example of within clustering techniques, what are the different types of clustering techniques we have. So there are multiple types of ways based on the type of output that we want to produce. There are multiple different types of clustering techniques we have, but out of which let's try to understand about what are the very famous and most widely used clustering technique algorithm, out of which we have something called K-means clustering algorithm is one of the very famous and most widely used. More than 90% of the people will end up with using K-means clustering algorithm, which is very famous in clustering techniques. So what are these clustering techniques? As I said, how this clustering technique will work. By default, K is nothing but you are supposed to, as a user, you are supposed to provide what is the input of K, which means wherever you see there are multiple techniques that we have in machine learning, like K-means clustering technique, K nearest neighbor is one of the algorithm, K-fold cross validation. Likewise, wherever you see a notation called K, what does a K means? It's an input that you are supposed to provide. Always remember this. It's an input that you are supposed to provide to your algorithm. Your algorithm cannot identify that K value. Of course, everything else will be taken care by your algorithm. But whenever you see K, which means in K-means clustering, what is the meaning of K-means clustering? How many number of clusters that you want to provide? That is something that you have to input it to your algorithm. Here, the meaning of K is how many clusters that you want to generate. So how many clusters that you want to generate? Okay, when you have 1,000 observations which are present, when you have 1,000 input records which are present in your historical data, how many number of clusters that you want to produce? Do you want to go for one cluster? Obviously, one cluster means that the entire data set will be considered as is. Do you want to create 2 clusters out of the data? Do you want to create 3 clusters out of the data, 4 clusters, 5 clusters, or 10 clusters? So how this can be done? There are multiple steps that are involved in generating K-means clustering algorithm. So you can see, choose the number of clusters. This is what is nothing but your first step. It means you need to decide what is your K is nothing but number of clusters that you want to produce. And then there is an initialization of centroids will happen as a one-time activity, right? So there is an initialization of centroids which will be declared, that will be used as your initial step for your machine, and then assign the clusters, move the centroids, and optimization, and then converge all the clusters into one component. Yes, I know it will be very difficult to understand by looking at this thing. So let me show you a very simple example how exactly it will be done. Maybe let me take a simple diagram for you to show how exactly that's going to work. Okay, so let's say, for example, I'm going to take some historical data just to explain you on how exactly the K-means clustering algorithm will work. So what is that it is written in the first step? So the choose a number of clusters. Now, which means, say for example, we need to take some historical data. I'm considering some historical data here. Let's assume this is the historical data that we have. So as you could see, there are multiple historical data points. So as you could see, the first step, choose number of clusters, which means, let's assume, to make this thing simple, I'm going to choose that we want to have 2 clusters generated. Okay, so this is, which means we want to have 2 clusters created. So because my number of clusters that I want to generate is 2, I'm going to consider that there are 2 centroids which are present. This is my first step. How this algorithm will do? How algorithm will come with the number of clusters? So this is how it will happen. So first step is to choose the number of centroid and then initialize your centroid. That's the second step. So now what is the third step? Let's assume this is observation number 1. This is our data point 1. So now what is the next step? We will take the distance from every observation to every centroid and every observation to every centroid. Now this observation is more closer to red color. So now what happens? What is the next step? The algorithm will assign this particular observation 1 as a red color for now, as considering that this belongs to red color. Likewise for the second observation, when the second observation appears, what is the distance from the second observation to both the centroids? Now which one is more closer? I see green color is more closer. So now I'll mark this as green color. If the distance is same equal, so then the algorithm will force any of the observation to get into any of the centroid. So number of clusters, number of centroids that you will choose based on the k value, as I said. Now you're going to likewise you will repeat the same process, and whatever the observation which is more closer to whatever the centroid it is, you will mark them as with their so-called mark like this. Now you are going to initially mark them as observations either into green color, either into red color. So now these observations are now considered as green color observations, and these observations are now considered as red color observations. This is step number 1. What is the step number 2? Step number 2 is segregate all these red color observations and take the average value of x and y coordinates, and repeat the same process for calculating average coordinates of x and y coordinates for the green color observations. Take the average of all these observations, calculate average, and take all these observations, take the average. You end up with getting a new centroid positions called xy, which means now you ended up with getting a new centroids. In the initial step that we have taken random centroid, now you got the centroids that you can use based on the previous iteration. Now you ended up with getting a new centroids. Again you repeat the same process, take the distance from every observation to every centroid and assign the observation based on the nearest distance, and continue to mark every observation either into red color or either green color or whatever it is, and you repeat the process until you will be able to see there will be no change applicable for your clusters. You repeat the process, which means in every step you might end up with changing your centroid. Every step will continue to change your centroid. Now the centroid might become like this, then later your centroid will become like this. Likewise, your centroids will be keep on moving. Initially you are taken it like this, but it might continue to move like this. Somewhere it will be fixed, and after that there will be no change that you will notice if you are repeating the same process. At this particular stage, whatever the observations which are grouped into green color, you will say like these are the green color observations. Whatever the observations which are marked into red color, you will mark them as these are the observations which belong to red color. Likewise, you will segregate all these observations either into red color or green color. So that's how we can generate these clustering technique. That's how the K-means clustering algorithm will generate these algorithms output of using this algorithm. So now likewise there are multiple algorithms that we have. So like when we talk about machine learning, so there are multiple types of algorithms that we have. So like how does the K value will occur? So you're going to choose some randomly generated K value, and you will be choosing the number of Ks over here, and you can see that it will assign them based on the number of this most nearest distances, and according to that you will change your centroids. Once you change your centroids, you will repeat the same process until you will able to change that your centroids don't move further, and then once it has been finalized, you will say like this is the final cluster output that we can generate out of this. So likewise, we also have different types of clustering technique, and the second type of clustering technique that we have is fuzzy or C-means clustering. So what is fuzzy or C-means clustering? The output will remain same. So C-means clustering means that there are places that one or two observations can belong to one or two different clusters, right? One or two different clusters, which means usually the primary difference between your C-means and K-means clustering technique is in case if there are any observations which are having equal amount of distance, usually in K-means clustering what we will do, we will force this observation to be part of any of the cluster. But in C-means clustering, based on the distance that we see, there are chances that an observation can go to or can belong to 1 or 2 clusters. So it purely depends on the business use case, who is going to decide to either to go for k-means clustering or c-means clustering based on our business outcome. So if people are going to decide whether to go for c-means clustering or k-means clustering. So there are a number of observations which might, it's not mandatory, which might can belong to 1 or more clusters that can happen. So the third is agglomerated clustering. So which is the third type of clustering technique that we have. So now, what is this agglomerative clustering? So this is what we also call it as hierarchical clustering. These clustering techniques are built using H clustering. So what are this? So based on the type of algorithm, they will try to, there is a mathematical expressions which are involved in it. So considering the way how the data points are been segregated, it will build a kind of dendrogram. So on top of this dendrogram, your observations can be classified here like this, as you could see on the screen. You need to understand one thing. When we are talking about unsupervised learning algorithms, as I said, you may or may not have clarity on the data, which means your assumption is that at the least level, you don't have clarity on the data. When you don't have clarity on the data, how can you say this is an outlier or this is not an outlier? When you have clarity on the data, especially when you're working on supervised learning algorithms, you can, but you don't have output column also. How you will be able to evaluate, because this is not been classified properly, this is not been clustered properly based on the historical data, because there is no output column. So those type of concepts are something which you don't need to worry about when you are working on unsupervised learning. They will be constrained when you are working on supervised learning algorithms. And of course, in case if you see that there are outliers which are present, obviously it will be considered as any of the cluster, it belongs to the data. But anyhow, that's the characteristic of the data. You don't need to, you don't be taking care, because you might be killing the actual original values which are present in the data, but you cannot expect that outlier can be recognized out for all the cases that you have in unsupervised learning. So the next type of clustering technique that we have is division clustering. So what is this division clustering? As the division clustering is also creates the data in a form of dendrogram. But the difference is, you can see that it starts with all data points in one cluster, splits the root into child recursively based on the dendrogram, and stops when there is a singleton clusters which are created, which means that for every cluster there will be one observation which belongs to. So likewise, the clustering technique will work. Now there is one more technique that we have in terms of building a clustering technique. That's what we call the mean shift clustering. So what we will do, we'll take an average of every cluster that we have. What we will do, we'll end up with reducing their means into a single density of items, and then we'll continue to repeat the process to see to that which observations mean will belong to the same cluster, and according to that we'll continue to identify which observation will belong to a cluster, a particular cluster. So likewise, we can apply different types of clustering technique that can help us to cluster the data, which is part of unsupervised learning. So now let's jump into something called a small hands-on. Okay, let's take a small Python example, and we will see how do we build that particular clustering technique on top of the data using one of the simple data that we have. The Jupyter notebook, let me open. You can use scikit-learn using one of the example. Let me show you a data set that I'm going to use as well. So what I'm going to do is I'm going to take this movie metadata information. Let me open this data set. I'm going to take this example of movie metadata information where this data set has got a number of observations which are present. Okay, let me open this. Okay, you can see that there are a number of movies related information. As you can see, the movie names. So Avatar, Pirates of the Caribbean, Spectre, The Dark Knight, Star Wars, etc., John Carter, Spider-Man 3, Tangled, or etc. We have a lot of movies. And about every movie, we got a lot of information which is present, like who is the director, who is the actor, what are the director Facebook likes, what are the actor Facebook likes. Likewise, we got a lot of information which is present as part of these particular every observation. So now what we will do, we will try to cluster these data points. You can see a lot of observations which are given. What is the gross of the movie? What is the number of reviewers? What is the IMDb rating? What is the so-and-so called IMDb score? What is the movie span? What is the gross? What is the budget and everything? So now what I'll be doing, I'll be reading this data set using one of the pandas library that we have. I'll be using something called pandas. As you can see, read.pandas.csv. I'll be reading this data set where you can see that this is the data set that I am able to read. I got a number of observations that are present. I can see that director Facebook likes and actor 3 Facebook likes. So now what is that I want to do is, instead of building this clustering technique on top of every observation, so what I will do is, I will take these columns called number of Facebook likes on director and number of actor Facebook likes versus director Facebook likes. So where you can see that if I want to select a director Facebook likes alone, I'll be able to choose this director Facebook likes alone. You can see for every movie, you got the number of director Facebook likes which are present. So if there are more number of Facebook likes, what does it mean? The director is famous person. Or either if there are more number of Facebook like the actor has got, which means that the actor is very famous person. So that's what you can understand. So now we can see that I'll try to extract these independent components that we're talking about. I will extract all the records in all the director Facebook likes versus actor Facebook likes, where I'm just going to form an object called new data by applying some I location as a filter. ILOC stands for index location, where I can filter out what are the records that I wanted to, what are the columns that I wanted to, using this I location function. Now I got all the so-and-so called number of director Facebook likes versus actor Facebook likes which are present as part of this. Okay, so this is being loaded into an object called new data. So now what is that I'll be doing? After that, I'm importing something called sklearn-𝐶 cluster. So this algorithm is available as part of this scikit-learn algorithm. In scikit-learn library, there is a Python library called scikit-learn which has got most of the algorithms present, and we will be importing this k-means clustering algorithm. And for this k-means clustering, I'm providing the c is equal to number of clusters is equal to 5. So here, if you are aware of object-oriented programming using Python, you will be able to correlate. I'm importing this k-means clustering, which is implemented as a class here, where I'm creating an object called k-means clustering by providing an input called n number of clusters is equal to 5, which means that what is the meaning of 5? I want to build 5 clusters out of this. So where once you create an object using k-means, I'm calling this method called fit method by providing new data as my independent variables. Fit is a method that's going to invoke what's supposed to be the process that needs to be executed. That's going to build my clustering technique algorithm by taking number of clusters is equal to 5. So now I'm able to generate my algorithm where by looking at my model, I'll be able to extract what are the centroids that I got, final centroids, because initially you'll be taking some random centroids, but at the end you'll end up with getting a final centroid position somewhere fixed to it. That is nothing but a center point for every cluster that we got. These are the final centroids that we got. Even if I want to print what is the labels which are generated, labels is nothing but it will extract the outcome. You can see that these are the label numbers which are added here. Out of 5,000 movies, we got the labels which are added as an array, but we won't be able to see it like that. What is it I'm trying to do? I'm trying to get all the unique values present in these labels with respect to counts. Now you can see that my data is now clustered into 5 different clusters. As you see, cluster number 0 has got 4,700. Most of the observations are moved into cluster number 0. 104 movies went into observation number 1. 11 movies are moved into cluster number 2, and 87 movies are moved into cluster number 3, and 67 into cluster number 4. So the data properties are being distributed, and that's how the clustering technique has divided the data into 5 clusters. Now we can see what is that I'm trying to do. I'm trying to put this into a new data of cluster, which means whatever the labels that are generated here. This is my output column. I'm going to create this into as a new column in my new data, where I'm using this lm plot that will print whatever the column that I have called director Facebook likes versus actor Facebook likes. And I'm choosing this data is equal to new data that will help me to identify what column can be considered as Q, so that I'll be printing it in a cool warm type chart. You can see that palette type is equal to cool warm type, which will help me to identify based on the cluster that you have created. Now if I print this, you can see that pretty much every observation is now categorized into individual cluster. You can see this is the graphical representation that we are using to see how these movies are being segregated. I can see these movies are nothing but cluster number 0. You can see there are a few more movies which are extracted over here. This is nothing but based on the color indication. This is cluster number 3, and these movies are created as a cluster number 2. These movies are something which are created as cluster number 1, and these movies are created as cluster number 4. 0, 1, this is nothing but 2, cluster number 3, cluster number 4, like this. Now you can clearly see that how the k-means clustering has came up. The movies which are made by new people with new directors, new actors, or new directors are making film with new actors. You will see more number of movies will fall into this category, because you will end up with getting new people into the film industry most of the cases. A lot of movies are being made with new directors with new actors. And you can see that these movies are the clusters which are being segregated very clearly. The famous actors are making films with new directors. Very famous actors are making films with new directors. And these movies are something where average fame directors are making films with some new actors. You can see these movies are nothing but very famous directors are making films with very new actors. Very famous directors are making films with very famous actors. Like Spielberg might be making a film with Tom Cruise or something like that. So likewise, you can clearly see that where instead of if you do this activity manually, it might take a little longer time for you to segregate each and every component. But within 5 minutes, we're able to cluster this activity. So that's what the beauty with algorithms. You don't need to manually do this activity, where you can provide your data automatically based on the properties of the data. Your algorithm will build this clustering output out of the data. It's very simple to do. So that's how we will be able to build a clustering technique on top of the given data. So that's what we have as part of one of the hands-on example. Okay.
So it's a phenomenon called as the impulsive buying, and big retailers take advantage of machine learning and a priori algorithm to make sure that we tend to buy more. And that's what we have defined as a market basket analysis. Now, first of all, let's discuss on that. So in today's world, the goal of any organization is to increase the revenue. And can this be done by pitching just one product at a time to the customer? The answer is clearly a no. Hence, the organization began mining data related to frequently bought items. So market basket analysis is one of the key techniques used by large retailers to uncover associations between items. So they tend to find out the associations between different items and products that can be sold together, which gives assisting in right product placement. Typically, it figures out what products are being bought together, and organizations can place products in a similar manner. Now, let's understand this better with an example. Let's say we have people who buy bread usually buy butter too. So the marketing team at retail stores should target customers who buy bread and butter and provide them an offer to them so that they buy the third item that we have, eggs or any kind of jam as well. Correct? So if a customer buys bread and the butter and see a discount or an offer on eggs, they will be encouraged to spend more and buy the eggs. So this is what market basket analysis is all about. So this is a small example. Let's say if we take 10,000 items data of our supermart to our data scientist, just imagine the number of insights we can get out of it. And that is why association rules mining is also important to understand. So if we talk about association rule mining, then association rules can be thought of as an if-then relationship. Suppose we have an item A. So item A is bought by the customer, and then the chances of an item B being picked by the customer too under the same transaction ID is found out. So here we have simple if and then relationship. So there are two elements of these different rules. First of all, we have the antecedent as an if. So this is basically an item or a group of items that are typically found in the item sets or data sets. And then we have the consequent, that is then. So here we have then. So then is basically used for, then it comes along as an item with an antecedent, or we can say a group of antecedents that we are seeing. And antecedent we have discussed, it is basically an item or group of items that we found in item sets of data sets. Now, here comes a constraint. Suppose we made a rule about an item used, we still have around 9,999 items to consider for rule making. As we discussed, we are going to make use of 10,000 items. So this is where a priori algorithm comes into play. So before we understand the a priori algorithm, let's understand the main mathematics involved here. So there are three ways to measure the association. We have support, confidence, and then we have lift, through which you can measure the association here. We have support, confidence, and lift. So support gives the fraction of transactions which contain item A. Suppose if we talk about support here, it is basically the fraction of transactions which contains item A and B. So basically, support tells us about the frequency, we can say frequently bought items, or the combination of items bought frequently by using the support. So with this, we can filter out the items that have a low frequency. Then we have confidence. So it tells us how often the items A and B occur together, given the number of times A occurs. So typically, let's say when we work with the a priori algorithm, we define different terms accordingly. But how exactly we have to decide the value? That's the main question. And to be honest, there is not a specific way to define these terms. Suppose we have assigned the support value as 2. Now, what exactly this means is until and unless the item frequency is not 2, so here we define support as 2. So until and unless the item's frequency is not 2%, we will not consider that item for the a priori algorithm. So this makes sense, as considering items that are bought less frequently is a waste of time. Because let's say if only 2% of users are buying this item along with the item that they have bought, then obviously we cannot use it. We cannot even consider it for the a priori algorithm that we are going to work on here. Now, suppose after filtering, we still have around 5,000 items left. Now, creating association rules for them is a practically impossible task for anyone. And this is where the concept of lift comes into play. So basically, lift indicates the strength of a rule over the random occurrence of A and B, and it basically tells us the strength of any given rule here. So for finding that out, we have to simply divide by the support of A and then support of B. So focus on the denominator. It is the probability of the individual support values of A and B and not together. So lift explains the strength of a rule. So more the lift, more is the strength. Let's say A, suppose we can say for A is to B. So if A, if then relationship, so if we talk about if then relationship for AB, then the lift value is 4. So first, let's say for this relation, the lift value is 4 here. That means if you buy A, then the chance of buying B is 4 times. If the lift value is 4, or we can say it's 4 times. If the value here is 2, then it is 2 times, and so on, as a part of the lift values defined. So let's get started with the a priori algorithm, and now let's see how exactly it works. All right, so now let's discuss on the this is what we discussed here, the transactions at our local market. And here we have ABC for in transaction 2, we have ACD. In transaction 3, we have BCD. In transaction 4, we have ADE. And then we have in transaction 5, we have BCD. So let's say here, if you find out the entire rules here, then if A, then again, they are going to purchase D. If they buy C, again, they have the option of going for A. If they buy A, then they have the option of going for C. And if they buy B and C together, then they are going to buy A as well. And then same way, we can find out the support. So again, for if A is, for those who are purchasing A, the probability of buying D, it is in terms of support, it is 2 by 5. In terms of confidence, it is 2 by 3. In terms of lift, it is 10 upon 9. Whereas for C, again for A, that means what is the possibility that those who have purchased C will be buying A. So you can find the support as 2 by 5, confidence as 2 by 4, and lift as 5 by 6. Same way for C, and same way for BC and A. So we can see how the probability is going to be distributed as we find out the possibility of one product to be bought over the other. All right, so now let's assume further on the a priori algorithm part. So a priori algorithm uses frequent item data sets. Okay, so item sets or data sets to generate the association rules. So it is based on the concept that a subset of a frequent item set must also be frequent item set, must be a frequent item set. And frequent item set is an item set whose support value is greater than a threshold value that we have support. So we're getting what exactly a frequent item set is. It's an item set whose support value is greater than a threshold value. All right, so now if we talk about a simple example, now here we can, let's say we have the following data of a store here. So we have the transaction ID here, and then we have 9 items. So here we have these one are transaction IDs, and here we have the items. So in transaction 1, we have 134, 235, 1235, 25, and 135. So if we talk about the first iteration, now let's assume the support value is 2, and then we can create the item sets of the size 1 and calculate their support values, as you can see here. So as you can see here, the item 4 has a support value of 1, here, which is less than the minimum support value. So we are going to discard 4 in the upcoming iterations, and we have That's how we can have the final table defined here as the fn. So here we are going to discard the value as 4, and then we are going to have the final value to be given to us. So the item sets with support value less than minimum support value, that is 2, are going to be eliminated. Next, we are going to create the item sets of size 2 and calculate their support values. So all the combination of item sets in F1 are used in the iteration here. So here we have C2 and then we have the F1 here. So basically, here we are going to make use of the entire iteration here, and item sets having support less than 2 are eliminated again. And in this case, we have 1 and 2, right? So let's now understand what exactly we mean by pruning and how it makes a priori one of the best algorithms for finding the frequent item sets. So if we talk about pruning, then we are going to divide the item sets in C3 into subsets and eliminate the subsets that are having a support value less than 2 from this given item sets here. So here we are going to work on the third iteration. So we will discard 1, 2, and 3. We are going to discard 1, 2, and 3, and 1, 2, and 5 as well. So they both contain 1 or 2. And this means again, and this is the main highlight of the a priori algorithm here. So again, here we are going to discard 1 and 2. And this is the main highlight of this entire algorithm here, because again, the 1 and 2 is a common thing available in these both data sets, right? So this is the main highlight of a priori algorithm here. And then if you talk about the fourth iteration, so as you can see, if any of the subsets of these items that are not in F2, then we are going to remove that particular item sets. And then in terms of the fourth iteration, let's suppose here we have the transition ID, and here we have the item set and support available. So since the support of this item set is going to be less than 2, so we will stop here, and the final item sets will have is the F3 one. And now, still now we have not calculated the confidence value yet. So again, this is something that we have to keep in mind. So with F3, we get the following item sets. That means for 1, we have 1, 3, and 5. And subsets are 1, 3, 1, 5, 3, 5, 1, 3, and 5. Whereas for item sets 1, again, we have 2, 3, 2, 5, 3, 5, 2, 3, and 5 itself for the other item sets available. So for 1, we have 1, 3, 5. These are subsets of 1, 3, 1, 5, 3, 5, 1, 3, and 5. Whereas 2, 3, 5 are subsets of 2, 3, 3, 5, 2, 5, 2, 3, and 5, right? And for every subset of I, we have to define the output rule. Now, when we are going for applying rules here, so we will create the rules and apply them on item set F3. So now let's assume a minimum confidence value is 60%. So for every subset of that we have S of I, so the output rule is going to be S is going to be recommended. So S is going to simply recommend IS, and then we hit support, it is I, and then we can simply divide this by the support cell, and to find the minimum confidence value is going to be 135. So here rule 1 here is 1, 3 is again a subset. That means 1 and 3 will result to 5. That means if a user is purchasing 1 and 3, both the items, then we have a good possibility of the customer going for the 5th item as well. So here the confidence is going to be support 135 divided by support 13. That is 2 by 2. That is 66.6%. That is 60%. So here rule 1 is going to be selected. And in rule 2, we have 135 minus 15. That means if someone is purchasing 1 and 5, then they are going to have a good possibility of going for 3 as well, where we are going to see the confidence. And for finding the confidence, we are simply going to again subtract support for 135 by support of 15. That's 2 by 2, and this is going to simply be translated at 100%, and which is much greater than 60% as well. And same way in rule 3, we have 35, 135, 3.5. That means here, if someone is going for purchasing 3 and 5, then they are going to high possibility of going for 1 as well. So here the confidence is support 135 divided by support 35, that we get as 66.66%. And here the rule 3 is going to be selected here, as you can see here. Now, upright. Now, if you talk about the application of rules here, now when we are talking about this rule here, we can see whenever the confidence is going to be more than 60% defined here, then this rule is going to be selected. As you can see here in this rule 5, where those who are purchasing 3, they have a possibility of going for 1 and 5 both. So here the confidence is less than 60%, which is why this is going to be rejected. Same way for rule 6 as well. Same here for rule 6 as well, because here the confidence is going to be less than 60%. Then that's why this is going to be rejected here, correct? Because again, here we have assumed a minimum confidence level for 60%, and wherever we are going to get the confidence less than 60%, we are simply going to reject that particular model here. All right. So first of all, that's how we had seen how we can create rules in Apriori algorithms here. And the same steps can be implemented for these items set 2, 3, 5. And then we are going to try it and see which rules are accepted and which rules are going to be rejected, and how we can implement the a priori algorithm in Python. All right, so let's fetch some sample data sets here that we are going to work on. So to get started working on the actual analysis here, we are going to make use of the PyCharm ID. So we can use any of the ID, or we can also make use of the Python common IDLE to get started. So we are going to make use of PyCharm. In this file, we'll be having the access to the invoice number. We have the stock code, we have description, quantity, invoice date, unit price, customer ID, and then we have the country. So this is the data point, that this is a file that we are going to work on. All right, so in the meantime, we are also going to install PyCharm as our main IDE. So in case you want to work on Python, then we can make use of PyCharm IDE, which is one of the most popular IDEs for getting started. And PyCharm is also offered as a free tool. That means here it is also offered as a community tool here. So you can use it as a community tool in order to get started. So once we have the access to it, we can open this up. All right. So here we can get started. First of all, we are going to work on the pandas library. So here we are going to import pandas and MLXten libraries imported and to import and read the data sets. So here we are going to use import, and then here we are going to find import pandas, and from pandas as PD. So here we go to import pandas as PD, and then we are going to use from MLXten, we are going for frequent patterns. We are going to import a priori, and then we are going to use the same from MLXten frequent underscore patterns. We are again going to import association rules. We're going to import association rules, and then we are going to create a data frame where we are going to make use of pandas library as pd.read, and here we are going to read Excel file. If it is a CSV file, then we define it as read CSV, and here we can define the path. Suppose here the file is currently available in our users location, and under users we have it in downloads, and by the name of online underscore retail dot xlsx. So this is the library that we have currently imported here. And in case suppose some libraries are currently missing here, so we can import these libraries as and when required here. Suppose if something is missing here, we can simply import these libraries in case they are not properly installed. So for installation of any new library here, we can go to File, under Settings. Here we have to go to Project Interpreter. In case you want to add any specific library here, then we can simply click on plus, and then we can choose which all library we want to add here. We can simply see the entire list of all the libraries currently installed here. And now if we want to start with more, then we can simply add more libraries, and then we can start deploying it one by one. So for example, suppose if we want to install any specific library here, so here we can, let's say here we want to install the a priori here. So we can see here we can also import the MLXten. So if this library is currently available, we can simply click on install package, and this is going to be installed and stored in a system as a library. Same way, if you are looking for Apriori here, so here we can also use, because again at the end we are going to use Apriori from the ML that we have imported. So here we are going to install the other package as well. So the first package for ML has been installed, and now if you want to install the other packages, then we can also install it. So in case we have missing some kind of library, then we can simply install it, or in case we have not used those libraries yet, then we can simply use them one by one. So once we are done, we can simply come out. So as you can see now, once the libraries have been properly installed, then we will be able to see there is no error being shown here. And this is the path of the file where we have stored online retails.xls file here. So just to confirm, we can confirm that we do have the file by the name of online retail.xls available here in our downloads directory. So once we have specified the file here, and then we are going to simply use dataframe.head. So in case we want to see the first few entries of the current data set that we have imported, so here we can simply define df.head, and then from the given path, the first few head is going to be returned back as a response. Now once we are done, we can simply start applying it. Now once we have the access to the data set here, next step is going to be focus on data cleaning, which will include removing spaces from some of the descriptions that we have. And for that, we are simply going to specify here we can, now instead of using the data frame head here, so now we are going to use the data frame, and then from here we are going to add a short description. So here we can add a short description here. So basically we are going to work on data cleanup, which includes removing spaces from some of the descriptions, and then we are going to drop the rows that don't have invoice numbers and remove the credit transition as well. For example, suppose we have some rows where we don't have where we have blank transactions itself, right? So we have some blank invoices, and then we have invoices numbers, and remove the credit transaction where we don't have any kind of invoice number placed here. All right. So here we have to work on removing those kind of anomalies. So here from the data frame, so here we can add parameter as description. Now under description, we are going to use a string function as string.strip. So string function is available under string. We're going to make use of it. And then same way from data frame, we are going to work on dropping. There we can find the values for x is equal to 0, and then the subset where what kind of values we have to drop. Do we have to define that parameter where the invoice number is going to be in place, is going to be true. And then from data frame we can define the invoice frame, the invoice number, and then we can define it to be a data frame where invoice number, again we are going to convert that to a string itself. So here we can define data frame and then the invoice number type. So here we have invoice number dot the AS type, and then we are going to the SD type here, but again here we can keep it to AS type. So here we can define to be a string value. So here we can define to be a string, and then we can create a data frame where we can define data frame should be a value closer, or okay, so value closer to data frame where we are going to define the invoice number. So here we have invoice number, and then we can define this as a string point based on the, so here we have string dot contains, and then we can define wherever the value is C, wherever the value is C as a part of definition defined here. And then we are going to simply save it as a part of given data frame. So after we are done cleaning up, we need to consolidate the items into one transaction per row with each product. So for the sake of keeping the data small, we are only going to be looking at the sales for any specific country. So now once we are done, we are going to create and consolidate the items into one transactions per row with each product. And for the sake of keeping the data set small, we are going to look at the sales for a specific country. So for that, let's say here we want to focus on one country data set here. So here we can use basket, And then in the basket part here, we can define multiple data frames. For example, first of all, we can define data frame. And here we are going to use the same data frame, and then we are going to segregate it further based on the country itself. So here we can define country, and then under country, we can define which country we want to focus on. The country should be, suppose, let's say France as a single country. So here we can define France as a country that we want to use for consolidation. And then we are going to group. So here we can use group by the invoice number. So here we are going to define the invoice number for it. So here we have invoice number. And then we can add a short description here. So here we can add description. And then after we are done defining the description here, we can then define the quantity here. So here we can define quantity. And then after quantity, we can define sum. Let's put this underline just to avoid the confusion. So here we can define sum. And then we can define unstack dot reset. We missed one other parenthesis here. So here we have to define sum, and then we have to define unstack, and then we have to define dot reset, and then the index value here with the final NA, with the final, or okay, so with the simple fill color, with the simple fill, and then we can define the value to be a simple 0. And then we can use set underscore index, where we can define for the invoice number. So here we have invoice number defined. And then we can define this for a basket. So basically here we are going to define the consolidation for the items into one transaction per row with each particular product. And to keep the number of transactions low, we have focused our attention only for a single country itself, as in France. So after we are done with that part, next we have to work on removing all the zeros. So basically there are a lot of zeros in the data, but we also need to make sure that any positive values are converted to a 1, and anything less than 0 is also set to 0. So for that, we are going to make use of this. So basically here we are now for converting that, here we are going to go ahead and perform the encoding as well. So here we can define encoding units. So if x is less than or equals to 0, then we are going to return 0. And if x is greater than or equals to 1, then it is going to return 1. Where we are going to define the basket sets and the basket apply map encode units. And then we are going to simply use the drop postage and in place setter to be true here. So basically here we are going to simply work on, first of all, removing all the anomalies here. And then if there are a lot of zeros in the data, we also have to make sure that any positive values is converted to 1, and anything less than 0 is also set to 0. That's what we have done here. And then we are going to generate a frequent item set that have a support value of at least 7%, and this number is chosen so that we can get close enough and we don't observe any kind of errors, or we don't get any errors thrown. And here we can generate the rules with the corresponding support, confidence, and lift. So for doing that, we can make use of frequent item sets. So here we are going to define frequent item sets, where we are going to define the a priori from basket set. Minimum support should be 0.7, and the call length that are going to be used should be true. And the rules here defined should be for association rules, where we want to define the metric as lift and the minimum threshold to be set to 1. And then we are going to filter the data frame using standard pandas code for a large lift and high confidence value as 0.8. And then if we run this, and we'll be able to see the output directly in the section altogether. So here we can simply run the rules, and then if we run rules here, we can define rules for lift. It is going to be defined as a value greater than 6, and the rules where confidence value is going to be 0.8 altogether. So that's how we can make use of the a priori algorithm here.
let's look at some of the examples and let's define what reinforcement learning really is. So guys, reinforcement learning is a part of machine learning where an agent is put in an environment and he learns to behave in this environment by performing certain actions. Okay, so it basically performs actions and it either gets rewards on the actions or it gets a punishment and observing the reward which it gets from those actions. Reinforcement learning is all about taking an appropriate action in order to maximize the reward in a particular situation. So guys, in supervised learning, the training data comprises of the input and the expected output. And so the model is trained with the expected output itself. But when it comes to reinforcement learning, there is no expected output. Here, the reinforcement agent decides what actions to take in order to perform a given task. In the absence of a training data set, it is bound to learn from its experience itself. All right. So reinforcement learning is all about an agent who's put in an unknown environment and he's going to use a hit and trial method in order to figure out the environment and then come up with an outcome. Okay. Now let's look at reinforcement learning with an analogy. So consider a scenario wherein a baby is learning how to walk. This scenario can go about in two ways. Now in the first case, the baby starts walking and makes it to the candy. Here the candy is basically the reward it's going to get. So since the candy is the end goal, the baby is happy. It's positive. Okay, so the baby is happy and it gets rewarded a set of candies. Now another way in which this could go is that the baby starts walking but falls due to some hurdle in between. The baby gets hurt and it doesn't get any candy and obviously the baby is sad. So this is a negative reward. Okay, or you can say this is a setback. So just like how we humans learn from our mistakes by trial and error, reinforcement learning is also similar. Okay, so we have an agent, which is basically the baby, and a reward, which is the candy over here. Okay, and with many hurdles in between. The agent is supposed to find the best possible path to reach the reward. So guys, I hope you all are clear with the reinforcement learning. Now let's look at the reinforcement learning process. So generally, a reinforcement learning system has two main components. All right, the first is an agent and the second one is an environment. Now, in the previous case, we saw that the agent was the baby and the environment was the living room wherein the baby was crawling. Okay, the environment is the setting that the agent is acting on and the agent over here represents the reinforcement learning algorithm. So guys, the reinforcement learning process starts when the environment sends a state to the agent and then the agent will take some actions based on the observations. In turn, the environment will send the next state and the respective reward back to the agent. The agent will update its knowledge with the reward returned by the environment and it uses that to evaluate its previous action. So guys, this loop keeps continuing until the environment sends a terminal state, which means that the agent has accomplished all his tasks and he finally gets the reward. Okay, this is exactly what is depicted in this scenario. So the agent keeps climbing up ladders until he reaches his reward. To understand this better, let's suppose that our agent is learning to play Counter-Strike. Okay, so let's break it down. Now, initially the RL agent, which is basically the player one, let's say it's the player one who is trying to learn how to play the game. Okay, he collects some state from the environment. Okay, this could be the first state of Counter-Strike. Now, based on this state, the agent will take some action. Okay, and this action can be anything that causes a result. So if the player moves left or right, it's also considered as an action. Okay, so initially the action is going to be random because obviously the first time you pick up Counter-Strike, you're not going to be a master at it. So you're going to try with different actions and you're just going to pick up a random action in the beginning. Now the environment is going to give a new state. So after clearing that, the environment is now going to give a new state to the agent or to the player. So maybe he's crossed stage 1, now he's in stage 2. So now the player will get a reward R1 from the environment because it cleared stage 1. So this reward can be anything. It can be additional points or coins or anything like that. Okay, so basically this loop keeps going on until the player is dead or reaches the destination. Okay, and it continuously outputs a sequence of states, actions, and rewards. So guys, this was a small example to show you how reinforcement learning process works. So you start with an initial state, and once the player clears that state, he gets a reward. After that, the environment will give another stage to the player. And after it clears that state, it's going to get another reward and it's going to keep happening until the player reaches his destination. Alright, so guys, I hope this is clear. Now let's move on and look at the reinforcement learning definitions. So there are a few concepts that you should be aware of while studying reinforcement learning. Let's look at those definitions over here. So first we have the agent. Now an agent is basically the reinforcement learning algorithm that learns from trial and error. Okay, so an agent takes actions like, for example, a soldier in Counter-Strike navigating through the game, that's also an action. Okay, if he moves left, right, or if he shoots at somebody, that's also an action. Okay, so the agent is responsible for taking actions in the environment. Now the environment is the whole Counter-Strike game. Okay, it's basically the world through which the agent moves. The environment takes the agent's current state and action as input, and it returns the agent's reward and its next state as output. All right. Next, we have action. Now, all the possible steps that an agent can take are called actions. So like I said, it can be moving right, left, or shooting, or any of that. All right. Then we have state. Now, state is basically the current condition returned by the environment. So whichever state you are in, if you're in state 1 or if you're in state 2, that represents your current condition. All right. Next, we have reward. A reward is basically an instant return from the environment to appraise your last action. Okay, so it can be anything like coins or it can be additional points. So basically, a reward is given to an agent after it clears the specific stages. Next, we have policy. Policy is basically the strategy that the agent uses to find out his next action based on his current state. Policy is just the strategy with which you approach the game. Then we have value. Now, value is the expected long-term return with discount. So value and action value can be a little bit confusing for you right now, but as we move further, you'll understand what I'm talking about. Okay, so value is basically the long-term return that you get with discount. Okay, discount I'll explain in the further slides. Then we have action value. Now, action value is also known as Q value. Okay, it's very similar to value, except that it takes an extra parameter, which is the current action. So basically here you'll find out the Q value depending on the particular action that you took. All right. So guys, don't get confused with value and action value. We'll look at examples in the further slides and you'll understand this better. Okay, so guys, make sure that you're familiar with these terms because you'll be seeing a lot of these terms in the further slides. All right. Now, before we move any further, I'd like to discuss a few more concepts. Okay, so first we'll discuss the reward maximization. So if you haven't already realized it, the basic aim of the RL agent is to maximize the reward. Now, how does that happen? Let's try to understand this in depth. So the agent must be trained in such a way that he takes the best action so that the reward is maximum. Because the end goal of reinforcement learning is to maximize your reward based on a set of actions. So let me explain this with a small game. Now in the figure, you can see there is a fox, there's some meat, and there's a tiger. So our agent is basically the fox, and his end goal is to eat the maximum amount of meat before being eaten by the tiger. Now, since the fox is a clever fellow, he eats the meat that is closer to him rather than the meat which is closer to the tiger. Now, this is because the closer he is to the tiger, the higher are his chances of getting killed. So because of this, the rewards which are near the tiger, even if they are bigger meat chunks, they will be discounted. So this is exactly what discounting means. So our agent is not going to eat the meat chunks which are closer to the tiger because of the risk. All right. Now, even though the meat chunks might be larger, he does not want to take the chances of getting killed. Okay, this is called discounting. Okay, this is where you discount because you improvise and you just eat the meat which are closer to you instead of taking risks and eating the meat which are closer to your opponent. All right. Now, the discounting of reward works based on a value called gamma. We'll be discussing gamma in our further slides, but in short, the value of gamma is between 0 and 1. Okay, so the smaller the gamma, the larger is the discount value. Okay, so if the gamma value is lesser, it means that the agent is not going to explore and he's not going to try and eat the meat chunks which are closer to the tiger. Okay, but if the gamma value is closer to 1, it means that our agent is actually going to explore and it's going to try and eat the meat chunks which are closer to the tiger. All right. Now, I'll be explaining this in depth in the further slides, so don't worry if you haven't got a clear concept yet. But just understand that reward maximization is a very important step when it comes to reinforcement learning because the agent has to collect maximum rewards by the end of the game. All right. Now, let's look at another concept which is called exploration and exploitation. So exploration, like the name suggests, is about exploring and capturing more information about an environment. On the other hand, exploitation is about using the already known exploited information to heighten the rewards. So guys, consider the fox and tiger example that we discussed. Now here the fox eats only the meat chunks which are close to him, but he does not eat the meat chunks which are closer to the tiger. Okay, even though they might give him more rewards, he does not eat them. If the fox only focuses on the closest rewards, he will never reach the big chunks of meat. Okay, this is what exploitation is about. You're just going to use the currently known information and you're going to try and get rewards based on that information. But if the fox decides to explore a bit, it can find the bigger reward, which is the big chunks of meat. This is exactly what exploration is. So the agent is not going to stick to one corner. Instead, he's going to explore the entire environment and try and collect bigger rewards. All right. So guys, I hope you all are clear with exploration and exploitation. Now let's look at the Markov's decision process. So guys, this is basically a mathematical approach for mapping a solution in reinforcement learning. In a way, the purpose of reinforcement learning is to solve a Markov decision process. Okay, so there are a few parameters that are used to get to the solution. So the parameters include the set of actions, the set of states, the rewards, the policy that you're taking to approach the problem, and the value that you get. Okay, so to sum it up, the agent must take an action A to transition from a start state to the end state S. While doing so, the agent will receive a reward R for each action that he takes. So guys, a series of actions taken by the agent define the policy, or it defines the approach, and the rewards that are collected define the value. So the main goal here is to maximize the rewards by choosing the optimum policy. Alright, now let's try to understand this with the help of the shortest path problem. I'm sure a lot of you might have gone through this problem when you were in college. So guys, look at the graph over here. So our aim here is to find the shortest path between A and D with minimum possible cost. So the value that you see on each of these edges basically denotes the cost. So if I want to go from A to C, it's going to cost me 15 points. Okay, so let's look at how this is done. Now, before we move and look at the problem, in this problem, the set of states are denoted by the nodes, which is A, B, C, D. And the action is to traverse from one node to the other. So if I'm going from A to B, that's an action. Similarly, A to C, that's an action. Okay. The reward is basically the cost, which is represented by each edge over here. All right. Now, the policy is basically the path that I choose to reach the destination. So let's say I choose A, C, D. Okay, that's one policy. In order to get to D, I'm choosing A, C, D, which is a policy. Okay, it's basically how I'm approaching the problem. So guys, here you can start off at node A and you can take baby steps to your destination. Now, initially you're clueless, so you can just take the next possible node which is visible to you. So guys, if you're smart enough, you're going to choose A to C instead of A, B, C, D or A, B, D. Alright. So now if you're at node C, you want to traverse to node D. You must again choose a wise path. Alright. You just have to calculate which path has the highest cost or which path will give you the maximum rewards. So guys, this is a simple problem. We're just trying to calculate the shortest path between A and D by traversing through these nodes. So if I traverse from A, C, D, it gives me the maximum reward. Okay, it gives me 65, which is more than any other policy would give me. Okay, so if I go from A, B, D, it would be 40. When you compare this to A, C, D, it gives me more reward. So obviously, I'm going to go with A, C, D. Okay, so guys, this was a simple problem in order to understand how Markov decision process works. All right. So guys, I want to ask you a question. What do you think I did here? Did I perform exploration or did I perform exploitation? Now, the policy for the above example is of exploitation because we didn't explore the other nodes. Okay, we just selected 3 nodes and we traversed through them. So that's why this is called exploitation. We must always explore the different nodes so that we can find a more optimal policy. But in this case, obviously, ACD has the highest reward and we're going with ACD. But generally, it's not so simple. There are a lot of nodes. There are hundreds of nodes to traverse and there are like 50, 60 policies. Okay, 50, 60 different policies. So you make sure you explore through all the policies and then decide on an optimum policy, which will give you a maximum reward. So guys, this is our code and this is executed in Python. And I'm assuming that all of you have a good background in Python. Okay, if you don't understand Python very well, I'm going to leave a link in the description. You can check out that video on Python and then maybe come back to this later. Okay, but I'll be explaining the code to you anyway. But I'm not going to spend a lot of time explaining each and every line of code because I'm assuming that you know Python. Okay, so let's look at the first line of code over here. So what we're going to do is we're going to import NumPy. Okay, NumPy is basically a Python library for adding support for large multi-dimensional arrays and matrices. And it's basically for computing mathematical functions. Okay, So first we're going to import that. After that, we're going to create the R matrix. Okay, so this is the R matrix. Next, we're going to create a Q matrix, and it's a 6 into 6 matrix because obviously we have 6 states starting from 0 to 5. Okay, and we're going to initialize the value to 0. So basically the Q matrix is going to be initialized to 0 over here. All right, after that, we're setting the gamma parameter to 0.8. So guys, you can play with this parameter and move it to 0.9 or move it lower to 0.8. Okay, you can see what happens then. Then we'll set an initial stage. Okay, initial stage is set as 1. After that, we're defining a function called available actions. Okay, so basically what we're doing here is, since our initial state is 1, we're going to check our row number 1. Okay, this is our row number 1. Okay, this is row number 0, this is row number 1, and so on. So we're going to check the row number 1 and we're going to find the values which are greater than or equal to 0, because these values basically represent the nodes that we can travel to. Now, if you select -1, you can't traverse to -1. Okay, I explained this earlier. The -1 represents all the nodes that we can't travel to, but we can travel to these nodes. Okay, so basically over here, we're checking all the values which are equal to 0 or greater than 0. These will be our available actions. So if our initial state is 1, we can travel to other states whose value is equal to 0 or greater than 0. And this is stored in this variable called available act. All right. Now this will basically get the available actions in the current state. Okay, so we're just storing the possible actions in this available act variable over here. So basically over here, since our initial state is 1, we're going to find out the next possible states we can go to. Okay, that is stored in the available act variable. Now next is this function chooses at random which action to be performed within the range. So if you remember over here, so guys, initially we are in stage number 1. Okay, our available actions is to go to stage number 3 or stage number 5. Sorry, room number 3 or room number 5. Okay, now randomly we need to choose one room. So for that, we're using this line of code. Okay, so here we're randomly going to choose one of the actions from the available act. This available act, like I said earlier, stores all our possible actions, okay, from the initial state. Okay, so once it chooses an action, it's going to store it in next action. So guys, this action will represent the next available action to take. Now next is our Q matrix. Remember this formula that we used. So guys, this formula that we use is what we're going to calculate in the next few lines of code. So in this block of code, we're just executing and computing the value of Q. Okay, this is our formula for computing the value of Q. Current state, comma action, R current state, comma action, gamma into the maximum value. So here basically we're going to calculate the maximum index, meaning that we're going to check which of the possible actions will give us the maximum Q value. All right, if you remember in our explanation over here, this value over here, max Q of 5,1, 5,4 and 5,5, we had to choose a maximum Q value that we get from these three. So basically that's exactly what we're doing in this line of code. We're calculating the index which gives us the maximum value. After we finish computing the value of Q, we'll just have to update our matrix. After that, we'll be updating the Q value and we'll be choosing a new initial state. Okay, so this is the update function that is defined over here. Okay, so I've just called the function over here. So guys, this whole set of code will just calculate the Q value. Okay, this is exactly what we did in our examples. After that, we have the training phase. So guys, remember, the more you train an algorithm, the better it's going to learn. Okay, so over here, I've provided around 10,000 iterations. Okay, so my range is 10,000 iterations, meaning that my agent will take 10,000 possible scenarios and it'll go through 10,000 iterations to find out the best policy. So here exactly what I'm doing is I'm choosing the current state randomly. After that, I'm choosing the available action from the current state. So either I can go to stage 3 or stage 5. Then I'm calculating the next action and then I'm finally updating the value in the Q matrix. And next we just normalize the Q matrix. So sometimes in our Q matrix, the value might exceed. Okay, let's say it exceeded to 500, 600. So that time you want to normalize the matrix. Okay, we want to bring it down a little bit. Okay, because larger numbers we won't be able to understand and computation will be very hard on larger numbers. That's why we perform normalization. You're taking your calculated value and you're dividing it with the maximum Q value into 100. All right, so you're normalizing it over here. So guys, this is the testing phase. Okay, here you'll just randomly set a current state and you won't give in any other data because you've already trained a model. Okay, you're going to give a current state. Then you're going to tell your agent that, listen, you're in room number 1. Now you need to go to room number 5. Okay, so he has to figure out how to go to room number 5 because we've trained him now. All right. So here we've set the current state to 1, and we need to make sure that it's not equal to 5 because 5 is the end goal. So guys, this is the same loop that we executed earlier. So we're going to do the same iterations again. Now, if I run this entire code, let's look at the result. So our current state here we've chosen as 1. Okay, and if we go back to our matrix, you can see that there is a direct link from 1 to 5, which means that the route that the agent should take is 1 to 5. Okay, directly it should go from 1 to 5 because it will get the maximum reward like that. Okay, let's see if that's happening. So if I run this, it should give me a direct path from 1 to 5. Okay, that's exactly what happened. So this is the selected path. So directly from 1 to 5 it went, and it calculated the entire Q matrix for me. So guys, this is exactly how it works. Now let's try to set the initial stage as, let's say 2. So if I set the initial stage as 2, and if I try to run the code, let's see the path that it gives. So the selected path is 2, 3, 4, 5. Now it chose this path because it's giving us the maximum reward from this path. Okay, this is the Q matrix that it calculated, and this is the selected path.
So guys, let us understand deep learning with an analogy. So how do you think our brain is able to identify the difference between a dog and a cat? So the reason is, since the day we are born, we are actually seeing different types of cats and dogs in our day-to-day life. And because of that, we are able to identify the difference or spot the difference between the two, that is dog and a cat. Even if we see different types of cats and dogs, we still know which is a cat and which is a dog. So this is because we have seen a lot of cats and dogs in our entire life. But what if I want a machine to do that task for me? So how will a machine identify whether the given image is of a dog or a cat? So one way of doing that is we can train our machine to a lot of images of different cats and dogs, that is different breeds of cats and dogs. And then what will happen once our training is done, we can provide it with an input image. Then we'll manually extract certain features. Features like nose, whiskers, colors, edges, it can be anything. The important features which actually helps us in classifying whether the input image is a cat or a dog. Then we make a machine learning model with that. And once it is done, our machine learning model is able to predict whether the input image is of a cat or a dog. But if you notice here, one very big disadvantage with this is we have to manually extract features. Features such as nose, whiskers, all those features we have to manually extract it and provide it to our machine learning model. And trust me guys, in every scenario it is not possible. If you have large number of inputs, you cannot do that. You cannot manually extract the features, or basically you can say columns which are important for you in order to predict what the object is, right? And that led to the evolution of deep learning. So what happens in deep learning? We skip the manual step of feature extraction. So what we do, we directly take the input image and feed it to our deep learning algorithm. And because of that, what happens, whatever features are we already manually provided, apart from that, there might be many other features which are important. For example, if our features don't include the length of the neck, and that is one of the major features in order to identify or classify whether it is a cat or a dog. Now what will happen, our algorithm will automatically determine that feature and will take into consideration, and then it will classify whether the input image is a cat or a dog. So what happens here, we provide an input image of a dog, and then it will automatically learn certain features even if we don't provide it with those features. And after that, it will give us the probability, and according to this particular scenario, it says 95% chances of being a dog, 3% chances of some other animal, similarly 2% chances of some other animal. So since the highest probability goes with the dog, so the prediction says that the object or the input image is nothing but a dog. Fine guys, so we'll move forward and we'll understand how exactly deep learning works. So the motivation behind deep learning is nothing but the human brain. As we have seen in the previous analogy as well, what we are trying to do, we are trying to mimic the human brain. We are trying to mimic the way we think, the way we take decisions, the way we solve problems. We are trying to make sure that we have a system that can mimic our own brain. So obviously the motivation for deep learning has to be our brain, and how our brain works with the help of our brain cells, which we call neuron. Now let us understand how a neuron works, and let me tell you guys, this is what we think how a neuron works. This is what our studies tell us. So yeah, so these are called dendrites. So dendrites receive signals from other neurons and then it passes those signals to the cell body. Now this cell body is where we perform certain function. It can be a sigma function. That's what we believe. We believe it performs a sigma function that is nothing but sums all the inputs. Then through axon, what happens? These signals are fired to the next neuron. And the next neuron is present at some distance, and that distance is nothing but synapse. So it fires only when the signals coming from the cell body exceeds a particular limit. Then only the cell or this neuron will fire the signals to the next neuron. And this is how the neuron or the brain cell works. And we take the same process forward and we try to create artificial neurons. So let us understand why we need artificial neurons with an example. So I have a data set of flowers, say, and that data set includes sepal length, sepal width, petal length, and petal width. Now what I want to do, I want to classify the type of flower on the basis of this data set. Now there are two options. Either I can do it manually. I can look at the flower manually and determine by its color or any means, and I can identify what sort of a flower it is. Or I can train a machine to do that. Now let me tell you the problem with doing this process manually. First of all, there might be millions of inputs that will be given to you. And for a human brain to perform that particular task is next to impossible. And at the same time, we always get tired at some point of time, right? So we cannot just continue working for a long period of time in single stretch. And the third point is human error risk, which is always there. So these are a few limitations with the human brain. So what we can do, we can train a machine to do that task for us, or we can put our brain inside a machine so that it can classify the flowers for us. So with this, what will happen? The machine will never get tired and it will make better predictions as well. So this is why we create artificial neurons, so that there's a system present that can mimic our brain. And this is what exactly happens. So this particular artificial neuron can actually classify the flowers, or you can say can divide the flowers on the basis of certain features. In our case, it is sepal length, sepal width, petal length, and petal width. So on that basis, it can classify the two flowers. So what we need here, we need some sort of a system that can actually separate the two species. And what is that system is nothing but an artificial neuron. So we need artificial neuron, and one type of artificial neuron is a perceptron. Now let me explain you perceptron with the flow diagram that is there in front of your screen. Now over here, what happens, we have set of inputs like x1, x2, dash, dash, dash till xm. Now these inputs will be multiplied with their corresponding weights, which is w1, w2, w3 till wn in our case. Now these weights actually define how important our input is. So if the value of weight is high, we know that this particular input is very, very important for us. After multiplication, all of these are summed together and then it is fed to an activation function. Now the reason of using activation function is to provide a threshold value. So if our signal is above that threshold value, our neuron, or you can say our perceptron, will fire, else it won't fire. So that is the reason why we use an activation function. There can be different types of activation function. There can be sigmoid, there can be step function, sign function. Depending on our use case, we define the activation function. Now the main idea was to define an algorithm in order to learn the values of the weights, which are w1, w2, w3 in our case, to learn the values of the weights that are then multiplied with the input features in order to make a decision whether a neuron fires or not. In context of pattern classification, which is in our case flowers, so we are trying to classify the two species of flowers, such an algorithm could be useful to determine if a sample belongs to one class or one type of a species or another class or another type of the flower. We can even call perceptron as a single layer binary linear classifier, to be more specific, because it is able to classify inputs which are linearly separable. And our main task here is to predict to which of the two possible categories a certain data point belongs based on a set of input variables. Now there's an algorithm on which it works, so let me explain you that. So the first thing we do is we initialize the weights and the threshold. Now these weights can actually be a small number or a random number, and it can even be 0. So it depends on the use case that we have. Then what we do, we provide the input and then we calculate the output. Now when we are training our model or we are training our artificial neuron, we have the output values for a particular set of inputs. So we know the output value. But what we do, we give the input and we see what will be the output of our particular neuron. And accordingly, we need to update the weights in order to reduce the loss, or you can say in order to reduce the difference between the actual output and the desired output. So what happens, let me tell you that. So we need to update the weights. So how we are going to update the weights is we can say the new weight is equal to the old weight plus the learning rate. Learning rate, we'll discuss about it later in the session. But generally, we choose learning rate somewhere between 0.5 to 0.01. After that, what happens? We find the difference between the desired output and the actual output. And then we multiply it with the input. So on that basis, we get a new weight. So this is how we update the weights. And then what happens? We repeat the steps 2 and 3. So we are going to repeat the steps 2 and 3. That is, we are going to apply this new weight. Again, we are going to calculate the output. Again, we are going to compare it with the desired output. And if it matches, then it's fine. Otherwise, we are going to update it again. So this is how the whole perceptron learning algorithm works. Fine, guys. So we'll move forward and we'll see the various types of activation functions. So these are the various types of activation functions that we use. Although there can be many more activation functions, again, I'm telling it depends on your use case. So we have a step function. So if our output is actually above this particular value, then only our neuron will fire, or you can say the output will be +1. Or if it's less than this particular value, then we'll have no output, or we'll say 0 output. Similarly for the sigmoid function as well, and same goes for sine function. So let us move forward and we'll focus on various applications of this perceptron. Now, as I've told you earlier as well, it can be used to classify any linearly separable set of inputs. Now, let me explain to you with the diagram that is there in front of your screen. So we have different types of dogs and we have horses. And we want a line that can separate these two. So our first iteration will produce this sort of a line. But here we can notice that we have error here. As we have classified one of the horses as a dog and a dog as a horse. So error is 2 here. Similarly, now what happens? We have updated the weights. Now after updating the weight, what happens? Our error has reduced. So what happens now? We have actually classified all the horses correctly, but one dog we have classified wrong and we have considered it as a horse. So our error becomes 1. Once again, what will happen? If you can remember, the step 2 and 3 of our perceptron learning algorithm will be done. And then after that, our weights will be updated and our desired output will become equal to our actual output, and we get a line something like this. So what we have now, we have properly classified dogs and horses. So this line separates both of them. This is how we can actually use a single layer perceptron in order to classify any linearly separable set of inputs. Now we can even use it in order to implement logic gates, that is OR and AND. Now let me tell you how you can do that. First we'll look at OR gate. Now in OR gate, what happens here is the truth table. Truth table, according to that, we have 2 inputs, x1 and x2. So if both are 0, we get a 0. If any one of the input is high or any one of the input is 1, we get the output as 1. So what we need to do is we need to make sure that our weights are present in such a way that we get the same output. So how we have done that? When the value of weight is equal to 1, and then we provide the input x1 and x2, after passing through this activation function, we get this sort of a graph, which is the graph for our OR gate. Now we have x1 and x2 as inputs. So we provide first input as 0, x1, and this also as 0. So 0 into 0 is again 0, 0 into 0 is 0. And then we pass it through this activation function. Now we need to make sure that whatever value that comes here should be greater than 0.5, then only our neuron or the perceptron will fire. But since this value is actually less than 0.5, so the neuron won't fire and our output will be 0, as you can see it over here. Now let's take the other set of inputs. Now our x1 is 0 and our x2 is 1. So 1 into 1 will be obviously 1. Now in this case, our output is bigger than 0.5. Then what will happen? Our neuron will fire and will get 1, the output 1 here, as you can see it in the graph. Similarly, when my x1 is 1 and x2 is 0, in that case also, our output is greater than 0.5, our neuron will fire and we'll get this sort of a graph. When I talk about 1, 1, then our output will be 2, which is greater than 0.5. So we get an output that is 1. And this is how we get the graph. And now if you notice, with the help of the single layer perceptron, we are able to classify the 1s and 0s. So this line, anything above this line is actually 1, and anything below this line, we have 0s. So this is how we are able to classify or able to implement OR gate. Similarly, when I talk about AND gate as well, so there's a difference in the truth table of AND gate. In AND gate, what happens? We need to make sure that both of our inputs are high in order to get a high output. If any of the input is low, we get a low output. And that's the reason we choose an activation function that is 1.5, which means that if our value or the output is above 1.5, then only our neuron will fire and we'll get 1 here. And there is only one case, that is when both the inputs are high. So when both the inputs are high, so x1 is 1, x2 is 1, we get something which is 2, which is obviously greater than 0.5. This is how it is. Yeah. So 1 plus 1, 2, which is obviously greater than 0.5. So what we get, our neuron fires and we get 1 here. But for the rest of the inputs, all will be less than 1.5. So that is why our neuron doesn't fire and we get a 0 output. So this is how we can implement AND and OR gate. So let's move forward, guys, and we'll actually understand with a use case that is of MNIST dataset. The reason for using MNIST dataset is because it is already clean and will be a perfect example for this. Now what this MNIST dataset contains, it basically contains handwritten digits from 0 to 9, and in that dataset we have 50,000 training images along with 10,000 testing images. So we will train our model with those 55,000 training images, and then we are going to test the accuracy of a model with the help of those 10,000 testing images. And for all of this, we need to understand first what exactly is TensorFlow. So let's move forward, guys, and understand what exactly is TensorFlow. Now, what is TensorFlow? As I've told you earlier as well, we use this TensorFlow library in order to implement deep learning models. And the way the data is represented in the deep learning model is called tensors. Now, what are tensors? Now, tensors are just the multi-dimensional arrays, or you can say an extension of two-dimensional tables, matrices, to data with higher dimension. Now, let me explain to you with the examples that are there in front of your screen. So this particular data is nothing but a tensor of dimension 6, because we have 6 rows and we have only one single column. Now over here we have 4 columns as well as 6 rows, so this becomes a tensor of dimension 6, 4. Similarly over here as well, so we have another dimension, that is the third dimension, in which we have 2 values. So we consider this as a tensor of dimension 6, 4 and 2. So this is nothing but a way of representing data in TensorFlow. Now if you consider the TensorFlow library, at its core it is nothing but a library that performs matrix manipulation. That is what TensorFlow is. Now let us move forward and understand TensorFlow in a bit detail. So as the name tells that it consists of 2 words, tensor as well as flow. Now we understood what exactly tensor is. Now when I talk about flow, it is nothing but a data flow graph. So let me just give you an example that is there in front of your screen. So we talked about weights and inputs. So we provide these weights and inputs and we perform a matrix multiplication. So weight is one tensor, X input is one tensor, then we perform matrix multiplication. After that we add a bias. Then what we do, we add all of these. So what is this? This is nothing but the sigma function in the perceptron that we have seen. Then we pass it through an activation function, and the name of that activation function is RELU or RELU, or you can say it, and then our neuron will fire. So this is nothing but a flow, or you can say a data flow graph. Now let us understand few code basics of TensorFlow. So we'll move forward and understand the code basics of TensorFlow. Now the TensorFlow programs actually consist of 2 parts. One is building a computational graph and another is running a computational graph. So we'll first understand how to build a computational graph. Now you can think of a computational graph as a network of nodes, and with each node known as an operation, and running some function that can be as simple as addition or subtraction, or it can be as complex as, say, some multivariate equation. Now let me explain it to you with the code that is there in front of your screen. So the first thing you do, you import the TensorFlow library. Then what do? You define 2 nodes, and these nodes are constants. So we'll call that function, we'll call it as tf.constant, and we'll provide a value that is 3, and it is nothing but a float number of 32 bits. Similarly, we defined one more node, which is a constant, and it contains value 4. So these are nothing but your constant nodes. So this is basically what computational graph is. So basically we have built a computational graph, and in this graph each node takes 0 or more tensors as inputs and produces a tensor as an output. And one type of node is a constant that I've told you earlier as well. And these TensorFlow constants, it takes no inputs and it outputs a value which is stored internally. Now what I'll do, I'll actually execute this in my PyCharm. So for that I'll open it. So this is my PyCharm, guys, and I've already installed TensorFlow. So the first thing that I need to do is import the TensorFlow library. For that I'm going to type in here import TensorFlow as TF. So if you're familiar with the Python basics, you know what it means actually. So I'm importing TensorFlow library, and in order to call that, I'm going to use the word TF. So after that, I'm going to define my node 1 and node 2, which are constant nodes. So for that, I'm going to type in here node 1 equal to TF.constant, and then I'm going to define the constant value in this. So it'll be 3, and it'll be a float value of tf.float of 32-bit. All right. And now I'm going to define my second constant node. So I'll type in here node2 tf.constant. I'll put 4 in here and 4. That's it. And so the tf.float 32 will be present implicitly. I don't need to do that again and again. So I have created a computational graph here. So what if I print it now? So let us see what will be the output. Node 1, comma, node 2. Let's go ahead and run this and see what happens. If you notice here that printing the nodes does not output the values 3 and 4. You might be expecting that, right? That it should print 3 and 4. But instead they are nodes that when evaluated would produce 3 and 4 respectively. So to actually evaluate the nodes, what we need to do is we need to run this computational graph. So let me show you that. For that, I'm again going to open the slides. So since I've told you earlier as well, we need to actually run this computational graph within a session. And what is this session? Its session actually encapsulates the control and state of the TensorFlow runtime. Now the code that is there in front of your screen, what it will do, it will actually create a session object, and then it invokes its run method to run enough of the computational graph in order to evaluate node 1 and node 2. And how it does that? By running the computational graph in a session. So now let me show it to you practically how it happens. So again, I'm going to open my PyCharm. This is my PyCharm, guys. So let me first comment this print statement, and now I'm going to run a session. So for that, I'm going to type in here ses equal to tf.session, and now I'm going to print it. So for that, I'm going to type in print ses.run, and what I want to run node 1 and node 2. So I'm going to type in here node 1, comma, node 2. That's all. And now when I run this, it will actually give me the value 3 and 4. And yup, it does. It gives me the value 3 and 4. So what we did, we first built a computational graph. We first saw how to build basically a computational graph. And then we understood that these all are nodes. So in order to get their value, we need to evaluate those nodes, and how we can do that by running the computational graph inside a session. And when finally, when we run that session, we get the output 3 and 4, which is nothing but the values of those nodes. And the one thing that you must have noticed here is that it will always produce a constant result, right? So how to actually avoid that? So we saw how to run a computational graph as well. Now let me explain it to you with one more example. So this is one example in which we take 3 constant nodes A, B, and C, and we perform certain operations like multiplication, addition, and subtraction. And then we run the session, and then we finally close it. And this is the diagram how it looks like. So we have 3 constant nodes, C, B, A. A contains value 5, B contains 2, similarly C contains 3. So first we add C and B, then we add B and A. Then we get 2 other nodes, that is E and D. And then from that E and D, what we are going to do is we are going to subtract both of them, and then we get the final output. Now let me go ahead and execute this practically in my PyCharm. So this is my PyCharm again, guys. First thing I need to do is import TensorFlow as TF. Then we are going to define the 3 constant nodes. So first is A equals to tf.constant, and the value that will be there in A will be 5. Then I'm going to define one more constant node, that will be B tf.constant, and the value that will be there in it will be 2. And then I'm going to define the last constant node, and tf.constant, the value that will be there is 3. Alright, so we have 3 constant nodes, and now we are going to perform certain operations on them. For that, I'm going to define one node, let it be D, which will be equal to tf.multiply. So the 2 nodes that we want to multiply, so that will be A comma B. And then there'll be one more node in order to perform some operation, that is addition. So tf.add C and B. And then we're going to define one more node, let it be F, and inside that node we're going to perform the subtraction operation, tf.subtract D and E. So we have built a computational graph. Now we need to run it, and you know the process of doing that. Ses is equals to tf.session. Then we are going to define a variable, let it be outs, whatever name that you want to give in, and just type in a ses dot run f. Let's see if that happens or not. And then we're going to print it. So for that, I'm going to type in here print out. Let's go ahead and run this and see what happens. So we have got the value 5, which is correct.
So now let's move on and discuss a couple of questions that every non-programmer usually has, right, about data science and machine learning. Now guys, data science, artificial intelligence, and machine learning might seem intimidating, but it isn't actually as complex as you might think, right? Many of the tools that have been developed over the last decade or so have all helped to make artificial intelligence and machine learning more accessible to engineers with varying degrees of experience and knowledge, right? Today we've got to a stage where it's now accessible even to people who have barely written a line of code in their life. Now that's very exciting, but if you're completely new to the field, it can be challenging to know how to get started. Now, as a beginner, it's natural to have a lot of questions regarding data science and machine learning. So I'll be addressing the top 3 frequently asked questions by beginners or by non-programmers. What exactly do I mean by non-programmers? Right, so a non-programmer can be anyone from a software tester who's basically working on an automated tool. It can be a product manager, it can be a researcher who's creating content, it can be a content writer, it can be a student who has just graduated or somebody who's still studying. It can be a marketing consultant. Basically, you can be from any background and still take up data science and machine learning. Now, if you want to get into the depth of the field, then obviously you do require programming languages. But however, if you just want to start off and you cannot do programming at all, there are a couple of tools that I'll be discussing today. And these tools do not require you to have any prior programming knowledge. Now, in the further slides, you will see me discuss about these tools. I'll be mentioning a couple of features to y'all. Now, let me answer a couple of questions which are very frequently asked. The first question that I usually get is people tell me that I'm looking to make a career in data science, but I have no prior programming experience. Do I need to know programming for machine learning and data science? Now, in a nutshell, let me tell you that the answer to this question is yes. Okay, if you want a career in machine learning, then having some form of programming knowledge always helps. But let me tell you that programming is just a part of machine learning. So if you're looking to make a career out of it, I'd say that it is important for you to know the different programming languages like Python, at least to get started. But due to recent breakthroughs, there are a lot of machine learning and data science tools that do not require you to have the programming necessity, right? You do not have to know programming languages. But if you ask me personally, then I'd say that you still have to learn programming languages, because only then you know how the entire process works. You'll know how machine learning really works because you're implementing it through code. Now, another question is, are there any tools that can help me with data science and machine learning without knowing any programming language? Okay, the answer to this is a simple yes. Now, there are a lot of tools in the market these days that will help you get started with machine learning. So these are especially useful for business applications of machine learning like predictive modeling, statistical analysis, and so on. So there are a lot of tools, and I'll be discussing a lot of those tools in the upcoming slides. And so don't worry, we'll talk more about the tools in the further slides. Another question is, do I need to know advanced mathematics or do I need to know advanced statistics in order to learn data science and machine learning? Now, this question depends on what exactly you're looking for. Right? If you really want to go in depth into the field of data science and machine learning, and if you want to understand the why behind the working of machine learning algorithms, which is very fundamental to understanding machine learning, then I'd say that yes, you do need to learn mathematics. Advanced mathematics is basically you have to have really good understanding of statistics, because statistical analysis plays a very important role in machine learning and data science. So a lot of topics under mathematics, which include probability, of course, there is statistics and linear algebra. These topics can help you know more about machine learning algorithms and about data science and about the different methods and techniques that are used to derive information from data. Now, not knowing advanced math is not an excuse to not learning machine learning. So to sum it up for you, if you want to go in depth into machine learning and data science, then knowing advanced mathematics is a prerequisite because it will help you understand the algorithms, the formulas, how the learning is done, and many other machine learning concepts, right? So for now, let's move on and let's look at why exactly anybody should go for these data science and ML tools. Right, so we just looked at a couple of questions that non-programmers have. Now let's look at how you all can get started and why you should go for data science and ML tools. Now, the first reason is that you don't require programming skills to use data science and machine learning tools. Now, this is especially advantageous to all of you non-IT professionals who don't have experience with programming in Python or in R. Another reason is that they provide a very interactive user interface, which is very easy to use, and you can learn very quickly by using that UI. Now, another reason is that these tools provide, you can say, a very constructive way to define the entire data science workflow, and then you can implement it without worrying about any coding bugs or any errors, right? So given the fact that these tools don't require you to do any sort of coding, it's faster and easier to process data and to build strong machine learning models. Also, all the processes that are involved in the workflow are automated and they require minimal human intervention. So basically, all the processes are mostly drag and drop, right? Whatever you want, whatever model you want, it's just basic drag and drop in these tools. All you have to do is drag the modules that you want in your workflow. Now, another reason is that many data-driven companies have adapted to these data science tools and they've started looking for professionals who are able to handle and manage such tools. A lot of companies that are taking up professionals who have knowledge of ML tools like IBM Watson and so on. So guys, those were a couple of advantages of using data science and machine learning tools. Now let's take a look at the top tools that any non-programmer can use in order to get started with data science and ML. So guys, note that this list is in no particular order, right? I've not ranked them according to the tools. So the first tool is RapidMiner. Now, it's no surprise that RapidMiner made it to this list. One of the most widely used data science and ML tools preferred by not only beginners who are not well equipped with programming skills, but it is also preferred by experienced data scientists. RapidMiner is the all-in-one tool that takes care of the entire data science workflow from data processing to data modeling and even deployment. So if you're from a non-technical background, RapidMiner is one of the best tools for you. Right? It provides a very strong and a very interactive UI that only requires you to dump the data. There is literally no coding required, right? So all you have to do is you just have to dump the data into the tool and it will build predictive models and machine learning models that use complex and convoluted algorithms in order to achieve precise outputs. Now let me discuss a couple of features of RapidMiner. So like I said that it provides a powerful visual programming environment, right? You can perform a lot of data visualization through this tool. It also comes with an inbuilt RapidMiner Hadoop that allows you to integrate with Hadoop frameworks for data mining and analysis. Right, so having Hadoop support is very important because it helps in big data analytics. So you can dump all your data into the Hadoop framework and then perform analytics and all of that through RapidMiner. Apart from that, it supports any data format and it also performs top class predictive analytics by expertly cleaning the data. Right, so data cleaning and data wrangling is done very easily through RapidMiner. Right, it uses programming constructs that automate all the high level tasks such as data modeling. So data modeling is also automated on RapidMiner. You don't have to code a single line. You just have to dump the data into the tool and do a couple of drag and drops and that's it. Right? So RapidMiner is known as one of the best tools for data science and ML. So now let's look at our next tool, which is DataRobot. Now, DataRobot is an automated machine learning platform which builds precise predictive models in order to perform extensive data analysis. Right? It is known as one of the best tools for data mining and feature extractions. So professionals with less programming experience go for DataRobot because it is considered to be one of the most simple tools for data analysis. So just like RapidMiner, Data Robot is also a single platform that can be used to build an end-to-end data science solution. Right? It uses the best practices in creating solutions that can be used to model real-world business cases and can be used to solve real-world complex problems. So coming to the features of Data Robot, it automatically identifies the most significant features and it builds a model around these data features. Right? So data modeling is done very easily when it comes to Data Robot. Right? So guys, data modeling basically involves you to build a model that can help in predicting your output. Now, this model basically takes in all the important features that are needed to predict your output. This entire process is automated in Data Robot. Another thing is that it runs the data on different machine learning models and it'll check which model provides the most accurate outcome. Right? So basically it uses test cases. It has different models and it tests where your accuracy is maximum. Also, it is very fast in building, training, and testing predictive models, in performing text mining, data scaling, and so on. These are other additional features. It can also run large-scale data science projects, and it is also known for incorporating model evaluation methods like parameter tuning and so on. Right? So model evaluation is also easily carried out on Data Robot. So basically your end-to-end data science process and machine learning process is covered by this single tool. Now let's move on and discuss another tool, which is BigML. So BigML, you can say that it eases the process of developing machine learning and data science models by providing readily available constructs that help in classification, regression, and clustering problems. Right? It incorporates a wide range of machine learning algorithms and it helps to build a strong model without much human intervention. This lets you focus on important tasks like improving your decision making process and so on. Right? So some features include that it is a very detailed and a comprehensive machine learning tool that supports the most complex machine learning algorithms, involving full support for supervised and unsupervised learning, which basically involves anomaly detection, association mining, regression, clustering, and classification. Another feature is that it provides a simple web interface and APIs that can be set up in a fraction of the time that it takes for traditional systems. So comparatively, it's extremely fast. It also creates visually interactive predictive models that make it easy to find correlations among the different features in your data. Right? So data visualization is also a pretty important role in data science, and BigML really helps in creating such visualizations, which help you understand the dependencies between your features in your data. Apart from that, it also incorporates bindings and libraries of the most popular data science languages like Python and Java. Right? So it has support for all of these languages. So that was about BigML. Now let's look at another tool called MLBase or machine learning base. So MLBase is again an open source tool that is one of the best platforms used to create large scale machine learning projects. Now, before I tell you the features of MLBase, let me tell you that there are three main components in this tool. So there's something known as ML optimizer, and the main purpose of this optimizer is to automate the entire machine learning pipeline construction. After that, we have something known as MLI. Now, MLI is an API that is focused on developing algorithms and performing feature extractions for any sort of difficult or any sort of high level computation. Then another component is the MLlib or machine learning library. It is Apache Spark's very own machine learning library that is currently supported by the Sparks community. So it basically supports Apache Spark's machine learning library. Right, so now let me tell you a couple of features of MLBase. So like I mentioned, it provides a very simple UI for developing machine learning models, predictive models, and all of that. Right? So guys, having a good user interface is actually pretty important when it comes to these tools, because you need to easily understand and you need to easily grasp what exactly is happening, how exactly you're going to build a model, how you're going to add data, what features you're going to select in order to build the model, how you're going to make your model better through parameter tuning, cross validation, and all of that. So it's important to have a very simple UI that will make everything look easier and more understandable. And that is easily achieved through ML base, right? I think it has one of the simplest UI among a lot of other tools. Now, another feature is model evaluation, right? So it basically learns and it tests this data on different learning algorithms to find out which model gives the best accuracy, right? So basically it compares our accuracy on different models. It runs your data on different models. Another feature is easy to use. So like I said, that the UI of this tool is extremely simple and extremely understandable. So non-programmers who are new to data science or who are new to this whole machine learning process, they can easily scale data science modules because of how easy and how simple the tool is to use. Apart from that, it can scale more large and more convoluted projects much more effectively than any other traditional system. So that was all about ML base. So now let's discuss the next tool, which is Google Cloud Auto ML. Now, Google Cloud Auto ML is a platform of machine learning products that allows a lot of professionals with limited experience in data science to train high-end models which are specific to their business needs. So this Cloud Auto ML tool is one of the best machine learning platforms with over 10 years of trained Google research constructs to help you build predictive models. So let me discuss some of the features of the tool. So first of all, professionals with minimal experience in the field of machine learning, they can easily train and build high-level machine learning models. So it's very easy to use for people who do not have experience in ML and data science. Right? It comes with a lot of documentation, it comes with a lot of tutorials. So one of the best features of this tool is that any person with minimal expertise or limited information in the field of machine learning, they can easily use the tool and build high-level machine learning models. Right? So this tool has a lot of documentation. It comes with a lot of tutorials. So it's one of the easiest tools to use, and it supports a lot of people from different backgrounds, right? So if you're not very aware with data science and ML, it has a very detailed and a very comprehensive approach to the entire process. So this is one of the best tools for a beginner, I would say. Also, apart from that, it has a fully fledged integration with many other Google Cloud services, which will help you in data mining and data storage. Right? These are very important parts of data science and ML. It also generates a REST API while making predictions about the output. Right? So having APIs also help you connect with other tools. It also provides a very simple UI to create custom machine learning models that can be trained, that can be tested, improved, and deployed through the same platform. Right? Again, it's an end-to-end solution to data science. It provides the entire data science workflow, and it is quite easy to use. Moving on to the next tool, we have AutoVika. Now, this is one of my favorite tools when it comes to machine learning and data science. Right? It is an open source UI-based tool which is ideal for beginners because it provides a very intuitive interface for performing all your data science related tasks. So apart from having a simple UI, it supports automated data processing. It performs very extensive EDA, supervised and unsupervised learning algorithms. All of this is covered in the tool, right? I think this is one of the best tools for beginners. And also if you want to go in more depth about data science and ML, I feel like this is one of the best tools. Right? It's perfect for newbies who are just getting started with data science and ML. Also, it has a huge community of developers who were kind enough to publish tutorials and research papers about using this tool. So actually, this tool is preferred by a lot of developers as well. So I'm aware of a couple of data scientists who use Python and R and who also use AutoVika because they find it extremely easy and they find it a very strong tool for building machine learning models. Now, let me tell you a couple of features of the tool. So Vika provides a huge range of machine learning algorithms. So you can perform classification, you can perform regression, clustering, anomaly detection, association mining, data mining, and all of that. Right? It also provides a very interactive graphical interface to perform a data mining tasks, to perform data analysis and EDA and so on. Another feature is that it allows developers to test their models on varied set of possible test cases, and it helps in providing the model that gives the most precise output. right? So like a lot of the other tools that I mentioned in this list, this tool also helps in model evaluation, right? Basically, it tests your data on different models and it chooses which model is the most accurate or gives you the most precise output. Apart from that, it also comes with a simple yet a very intuitive command line interface to run basic commands, right? So guys, these were a couple of features of Edureka. Now let's move on and look at the next tool, which is IBM Watson Studio. So we're all aware of how much IBM has contributed to this AI-driven world. So IBM is actually known as the #1 contributor in contributing a lot of tools, concepts, technologies which revolve under AI and data science. And so like most service provided by IBM, IBM Watson Studio is again an AI-based tool which is used for extensive data analysis. It is used for machine learning, data science, and so on. Right, there are a lot of organizations actually which make use of IBM Watson. It also comes in a lot of healthcare sectors. There's also a particular tool created by IBM. I'm not sure of the name, but it's used for weather forecasting. It's used for predicting any sort of storms and earthquakes and so on. Right, so IBM has majorly contributed in the field of AI and data science, I'd say. Apart from being extremely recognized in the market, let's take a look at a couple of features of IBM Watson. Right, one feature is that it provides support to perform data preparation, exploration, and modeling within a span of a few minutes, and the entire process is automated. Right, so it's a very quick tool which can perform your entire end-to-end process in a couple of minutes. It also supports multiple data science languages and tools such as Python 3 notebooks. It supports Jython scripting, SPSS modulars, and data refinery. So it provides support for all these languages. Now for coders and data scientists, it offers integration with RStudio, with Scala, with Python, and so on. You can say that IBM Watson is a more advanced tool, right? So a lot of data scientists and a lot of coders actually make use of this tool. Right, apart from being automated, it also provides support for the different programming languages like R and Python. Another feature is that it uses the SPSS modular that provides a drag and drop functionality. And this is quite simple because it lets you explore data and build strong models very easily. Right, all you have to do is drag and drop. Right, so guys, those were a couple of features of IBM Watson. So I'd say IBM Watson is a more advanced tool. It provides support for all the different languages that come under data science, right? It has a really good data analysis support. So the EDA that is performed in this tool is really good. It helps in extracting the most significant variables and then it builds a model on that variable. So guys, that was a little bit about IBM Watson Studio. Now let's look at our next tool, which is Tableau. Now, Tableau is known as the most popular data visualization tool in the market. It allows you to break down raw, unformatted data into a processable and understandable format. This tool is mainly focused on data visualization, right? You can also perform a lot of data analysis also on the tool, but it is one of the best tools for data visualizations. A lot of high-end companies, a lot of data-driven companies make use of this tool to see their business growth and to visualize and analyze their data. So let me tell you a couple of features of Tableau. The Tableau desktop feature, it allows you to create customized reports and dashboards that help you get real-time updates. Right? It can also connect to multiple data sources and it can visualize a huge amount of data to find a lot of correlations and patterns in data. Right? So that's what data visualization is important for. It's for understanding the correlations in your data. So it can connect to different data sources and then it can perform data visualization. So apart from this, Tableau also provides cross-database join functionality, which allows you to create calculated fields and join tables. Basically, this entire process will help in solving complex data-driven problems. Right, so guys, this is a very advanced tool for data science. It goes in depth with the entire data and it tries to bring out the best features and the most significant features in your data through graphs and through plots. Now, apart from that, it is a very intuitive tool which uses the drag and drop feature to derive useful insights and perform data analysis. So those were a couple of features of Tableau. Now let's move on and discuss Trifactor. Now, Trifacta is an enterprise data wrangling platform that help you understand what exactly is in your data and how it can be useful for different analytic explorations. The key to identifying the value in your data. So Trifacta is actually considered the best tool for performing data wrangling, data cleaning, and analysis. Right? Data wrangling and cleaning is one of the important features of Trifacta. So let's understand a few features of Trifacta. So basically, Trifacta allows you to connect to multiple data sources irrespective of where the data lives. Right? So you can have connections with various data sources. It also provides a very interactive UI for understanding the data to not only derive the most significant data, but also to remove unnecessary or any sort of redundant variables. Apart from that, it provides visual guidance, machine learning workflows, and feedback that will guide you in assessing the data and performing any sort of data transformation. It is also very good at monitoring your data. So it monitors the inconsistencies in data and it removes any sort of null values or any missing values and makes sure that data normalization is performed so that you avoid any sort of biasness in the output. Right, so it's mainly for data preparation. I would say Trifacta is very good tool for data preparation, data wrangling, and so on. So that was all about Trifacta. So now let's discuss the last tool for the day, which is 𝐸𝐼. Now again, 𝐸𝐼 is an open source data analytics platform which is aimed at creating out of the box data science and machine learning applications. Right, so building data science applications involves a lot of tasks, right? It involves data processing, data wrangling, EDA, and all of that. So this tool basically makes sure that this entire process is fully automated. Right, it provides a very interactive and a very intuitive user interface, which makes it easy to understand the whole data science methodology. A few features of 𝐸𝐼 include that it can be used to build an end-to-end data science workflow without any coding. So you just have to drag and drop the modules. It also provides support to embed tools from different domains, including scripting in R, in Python, and it also provides APIs to integrate with Apache Hadoop. Right, so it has support for all the important tools that are needed in data science. Apache Hadoop, it also provides support if you want to code in R and Python. It is also compatible with various data sourcing formats, which include simple text formats such as CSV files, PDF, XLS, and so on. It is also compatible with unstructured data formats, including images, GIFs, and so on. Another feature is that it provides full-fledged support for performing data wrangling, feature extraction, normalization, data modeling, model evaluation, and it even allows you to create interactive visualizations. So like I said, it covers the entire data science process end to end. 𝐸𝐼 is actually one of my favorite tools as well. Right, it is used for the entire data science workflow, and actually it's a very understandable tool. It performs data analysis in a very in-depth manner, and I feel like the fact that it supports machine learning languages is very good because not only can non-IT professionals and programmers go for this tool, even data scientists can go for this tool. There are actually a lot of data scientists that make use of 𝐸𝐼 in order to perform EDA and all of that. So guys, those were the top tools for data science and machine learning if you are a non-programmer.
So let's start with the questions here directly. We'll in the beginning start to focus on some of the fundamental questions, which is more for you to understand what is data science than like a particular interviewer asking you that question. For instance, many people wonder what data science is all about, right? Though there are many online sources and blogs which describes data science in a very nutshell, this is what it boils down to, right? A person who is very good in understanding the computer algorithms, a person who understands the statistics and mathematical ideas, and applying these two knowledges from the computer science and mathematics into a particular application, right? A business application where somebody sees a value coming out from the data. So how do you apply that? So that's how kind of data science approaches. So when you combine these two powerful concepts coming in from computer science and mathematics on a real world application, the sort of outcome that comes from particular data science project goes in a direction where people see a return on investment, right? So the people you bring in, the technology you bring in, the ideas you are working on, all of it should kind of give you some return on the investment you have put in. So that's where industries are started to looking at data science. So various subjects which are very important for you to know: statistics, computer science, applied mathematics, and then subjects like linear algebra, calculus, and a few more, right? So fundamentally, from computer science, algorithms and data structures might be very useful. From the mathematics or statistics and things like calculus, linear algebra, matrix factorization, and concepts like that. And from the application, it is more from your experiences from the industry. If you have worked for retail, you know how the business process in retail works, right? So people often also ask, from the technology end, do we need any sort of experiences in Python language, right? Python, or like, for example, R programming as well. So Python is one of the most looked out for kind of programming skills, particularly when you want to build solutions in data science domain. And with availability of libraries like NumPy, Pandas, Python has now established its ground very strongly in giving a very robust framework for designing data science solutions, right? And in particular, things which it has, like list, dictionaries, tuples, and stats, are one of its own one of its capabilities, which sets Python in its own league of programming languages suitable for coming out with data science solutions. So there are many more other libraries as well apart from this for building machine learning algorithms, but these are some common libraries that you would normally find people using it. And also with distributions like Anaconda, Python has shown its capabilities even for a production grade solutioning, right? Wherein you make sure that all the dependencies that one particular library has for building a data science solution is all in one place. So quite a popular programming language in the recent kind of happenings. Though R programming is also equally good in terms of producing a quick prototype for most of your modeling tasks, but Python is moving itself into a production grade where things can be deployed after the sort of prototype into a production environment, and it can face the customers from day one. So that sort of capabilities are coming up with Python, right? So let's talk something a bit more specific with the data, right? So when people are doing any sort of data analysis, they normally face something that we know by the name selection bias, right? So what is actually a selection bias? The fundamental place where you start doing a data analysis is by selecting a representative sample, right? So that's where we normally start doing any analysis. So when you working for a company which has, let's say, 1 billion records in their databases, 1 billion is very, very large number, which represents various customers data, or it might also be depending on which feature you are working on and so on. So if you collect all of those, it might very easily come to 1 billion records, which is nothing but in a structured form number of rows. So with that an enormous amount of volume in the data, any analysis that you take up might have to have a lot of filters, like saying, I only want to analyze a particular feature in my products, let's say, right? And I only want my customers from XYZ region, which is, let's say, top 4 region or top 5 regions. So you might put many features or filters like this. But later on, if you would like to do a kind of an analysis which covers most of your customer base, right? There comes the tricky situation of not being able to use the entire volume of 1 billion records. At the same time, you want to do a really good study or analysis based on what data you have. So in statistics, we normally use this idea of doing a kind of a randomized selection, right? So with this randomized selection, we make sure that out of these 1 billion records, we are choosing a small subset, let's say of 1 million, which is a true representation of the entire population, right? But what happens with this is, while we do this 1 million record selection in a randomized way, there are chances that you might have certain bias in the analysis, obviously because you are not using the entire population. So selection bias is this particular sort of a characteristics while you are doing a sampling on a large population of data. Very common example for this is if you want to do a exit poll analysis of particular election, even before the election results are coming up, and you have not chosen a representative sample for doing that exit poll analysis, right? By that I mean you only have asked some questions for a selective few from the particular constituency and they have an opinion towards one candidate, but that doesn't represent the entire opinion of the population in that constituency. So selection bias is like very important to handle, and most of the time people employ things like randomized selection or selection sampling techniques like stratified sampling and so on. So by that you can minimize this selection bias. So these are some very generic questions. So let's start with some sort of statistical questions and also how to deal with different types of data. Okay. So doing any sort of data with a structured information. So structured information, I mean, there are many rows and like many columns, and it looks more like a tabular data, right? So with such a data in place, there are like these two different formats, one saying the long and the wide. So let me like show you an example here. You have a record of two customers, right? And you store just two values, which is the height and the weight. So these are like in columns. So with these two customers, these height and weight being a separate column is one format, like a long format. Let's say transform this by having only one particular column, which will say attribute, right? By that, I will bring in these two columns as one column by calling that as an attribute and put the values in one column. So this sort of format is called the long one. So what really happens is, instead of having two separate columns for two of your attributes, you put both of those into one column. And by doing that, there are a lot of benefits with respect to the task you have in your hand, particularly in data visualization. Certain data visualizations would need you to not put your attributes as a separate column, but rather as one column which can have the attribute names. So which might then go into building your legends, right? So these kind of techniques are kind of very common formats between like the long and the wide, and very frequently will people like deal with both these data formats, so depending on what task they are doing, particularly when we are building visualization dashboards. Okay, talking a bit more on the data analysis perspective, people like know that in stats, normal distribution kind of is that one like the godfather of the distributions. You have many distributions which normally people try to see if is present in my data or not. But the moment people kind of see normal distribution coming up in any data, things are kind of bit easy to understand. And in typical case, any distribution, any data distribution that you would like to find out given data for analysis, it gives us a lot of characteristics around what the data is about. If I'm, let's say, analyzing the salaries of the employees in my company, right? I might see that there are some employees who are in that, like that thick crust in the center, where majority of the people are sitting with a moderate level of salary ranges. And then there are these sort of extremes on the left and the right. So you are like very commonly people refer whenever you talk about salaries to a bell curve, right? And then they start talking about top 25% of the performers in my company, the bottom 25, and the middle one, which you like are sort of the normal performance. So this sort of bell curve distribution is very commonly understood and as well as used in doing many data analysis. So is the other distributions as well. But normal distribution has its own significance. So when somebody asks you around anything around normal distribution, the first thing you should visualize is the symmetrical bell-shaped curve, right? And the moment you get that bell-shaped curve in your imagination, start thinking of certain properties. Like what is the mean of a normal distribution? What is the standard deviation of a normal distribution? And in particular, a special case of normal distribution, which we call the standard normal distribution. So in that standard normal distribution, we know the mean is exactly 0 all the time, and the standard deviation is exactly 1, right? So there are different places where normal distributions are kind of used. And if you are comfortable with ideas like central limit theorem or the law of large numbers, you might want to relate that as well to normal distribution, particularly the central limit theorem, right? But the idea is a distribution which is symmetrical around the mean. So that's what a normal distribution is. So depending on which variable you are trying to analyze, even a given data set, whether it could be like an employee's salary or your sales for a business of yours, right? Or your number of, let's say, interactions of the customers on your product. So any variable that you define can have a symmetrical bell-shaped distribution, which we normally refer by normal distribution. And the moment we understand that something follows a normal distribution, all these properties of that distribution is like revealed. So that's sort of the importance of doing any analysis around the distribution of data. And normal distribution, like very common one. And in many statistical techniques, in even model building exercises, if you have anything in a normal distribution, many other possibilities of applying certain modeling techniques comes out evidently there. And also there are many other modeling techniques in stats and machine learning where there is a fundamental assumption that things should follow a normal distribution. If it is not following, then the model is wrong. So there are many use cases of knowing what normal distribution is. But in simple terms, it's a symmetrical bell-shaped curve. Right. A/B testing. So quite a popular approach, people particularly who are working with product, right? And what happens is when you are as a company having many features inside a product. For instance, if LinkedIn is a company which has a web page, right? It has a lot of features inside that. You have some jobs portal in LinkedIn. You have places where you can connect to your professionals in the similar industry. You can also read about the posts people are doing in the portal and so on. So there are different places in the website with many features. So what happens is if LinkedIn as a company is looking for some changes, for instance, changing the entire website's design and aesthetics, or changing one particular feature inside their website, right? So these changes are normally accompanied by a sort of a process called A/B testing. So what happens as an analyst, you might be working with LinkedIn and say, on a fine day, they might come out with a new feature, new design, or new sort of changes in their website. So you as a person would tell, okay, this is my framework for testing this new change by defining a metric. So my metric would be in simple terms saying, if I change this website from A to B, is my number of footprints on the website going to go down or not? So this is my metric. And if I successfully establish the fact that after rolling out this new website, my number of customers who are going to visit my website is not going to go down, I can be confident that, okay, fine, this works. Now roll out this new feature. So in this framework, we normally have two set of users to identify the particular risk associated with getting this new feature into the platform, and in which we in a randomized way put one user group and expose them to an older website, and another user group and expose them to the new features, right, or the new website. And when we compare the results of a particular metric, like the number of clicks or the number of purchases and so on, we should be able to see that these two groups are either exactly the same or quite different. And if it is on the negative side of the difference, we say the feature is not good. And even if when the difference is not at all there, we say even if we bring this new feature, nothing is going to happen. So this A/B testing framework is quite robust in its own way, right? And a very common question, if you have like worked as data analyst, or if you are expecting to be like sitting for this data analyst kind of a role, knowing A/B testing framework is very important. Okay, so sometimes also when you do these kind of A/B testing sort of analysis, people normally come out with sort of saying what should be the sample size of my users whom I should be getting to participate in my A/B testing framework. Or also when you are building some models, you might see that there are certain statistical measures which has to be evaluated by the end of model building exercise. Like if you're building a machine learning model, let's say, and you want to see if those metrics on which I'm evaluating are really good or not, right? So in that, sensitivity is one of those methods or like metrics which we normally evaluate. And I'm going to show you something that we normally refer by the name confusion matrix. So I'll spend some time explaining this and then come to what do we mean by like sensitivity. So let's say you are building a model, right? A model for predicting whether a particular customer is going to purchase from my platform within 1 month or not. Right? So very simple problem statement, which might include many variables that we would bring in and then finally build this model saying, okay, this is my final model which says with 90% accuracy whether my customer is going to buy from my platform, let's say an online e-commerce platform, within next month or not. So this is my model. So now without going into the details of the model, let's assume that after you build the model, you have got the results. So while we analyze and evaluate what the result is all about, we might come out with a confusion matrix. So what it says. So obviously when you are building a model which follows a supervised way of learning, you will see from the historical data after people have purchased in the platform within next 1 month whether they are buying or not. So I can obviously create a really good training data set, right, which will contain the information after people let's do the first transaction with me in next 1 month whether they are buying the next product or not. So with that data set I train my model, and the way confusion matrix puts that is by saying my actual data says something and you have predicted something, right? So let's kind of get into the details of that. So this particular box which says my actual data says the customer will buy and you are also predicting the same. So this we call the true positive. The prediction is actually true, right, in a positive direction, saying the purchase happened. Now like move diagonally opposite to this TP, which is this TN, which is true negative, which means the prediction of your model saying the customer will not buy is actually matching with the actual data as well, right? So both of these values, the true positive and the true negatives for the two cases, is the right predictions from your model. But consider the off diagonal elements, the false negative and the false positive. And these two cases, this is sort of an error. Why? Because your actual data says the customer is not going to buy in this case, let's say, but your prediction says he is going to buy. So the prediction is actually positive, whereas the actual data is on the negative side. So this is a false prediction, right? So you have your, in this case, your FP, which is the false positive cases. And on the off diagonal element, if you look at this one, which is FN, which is your false negative, for the cases where you are predicting the customer is not going to buy, but in the actual data it says that customer actually has bought the product. So in this case the model is wrong. So the type 1 and type 2 errors needs to be taken care of when you are building any machine learning model. If these errors are low, then your model is going to move towards that 100% accuracy mark. But normally any machine learning model has its own limitations. So particularly there is one metric which we refer by calling sensitivity. So what happens is these true positives and true negatives needs to be controlled, right? If my model is very good in true positive ones, like the positive cases of when the customer is buying, but it is doing very bad job when the customer is not buying, the cases in which the customer is not buying, then the model has some sort of issues, right? It is doing only good in one place but doing very bad on the other case. So I need to find out that by some metric. So sensitivity help us to find that out, which is in simple terms is a ratio between the true positive. In the denominator we have all the cases of positive predictions. So imagine now if the type 1 error is going to grow, my sensitivity is going to come down. So if my true positives are like very high, the sensitivity will also be high. So this is sort of what we call the statistical power. If this sensitivity is really good, I would say that my positive cases are predicted well. And the exact opposite of this sensitivity is what we know by specificity. So we need to make sure that in a very good machine learning model, sensitivity and specificity both are balanced, right? So in very simple terms, this is what we like mean here, the ratio of true positive by the total positive events there. And as I mentioned, both of these sensitivity and specificity play a good role when you want to evaluate a model's output, right? And one more common problem. So these questions might be immediately following one another. When people ask you about sensitivity and specificity, as you know, it's about the machine learning model's output, right? When the model is done, you understand whether the model is good or not. So in those cases, we also come across some kind of issues like overfitting and underfitting given machine learning model, right? So these words are very common. And the idea is, depending on the complexity of your model, you might see that you want to adapt very sort of exactly to your data points, or you might want to do a generalization. So for instance here, if I have these red and blue dots here, right? And if I draw a curve like this, which separates the red from the blue, and when this separation happens, I am building actually a classifier using some sort of modeling technique. But now imagine by drawing a smooth curve like the one which is given in black, you might be over generalizing it, right? by which I mean there might be some red dots on the other side of this boundary. You can obviously see that. But the moment I am kind of a bit more flexible by drawing this green boundary, which actually covers all that issues which is coming out with these red dots on the other side of the boundary. So this green boundary has like taken care of that. But the problem, when we are building any model, right, the idea is you need to generalize to the pattern found in the data. So if you don't do that generalization well, you are underfitting. But if you do that generalization like too specific, you are overfitting. So this curve might be represented by some polynomial, right? But that zigzag kind of a polynomial might be a bit more complex than a smooth curve like the one which is shown in the black. So you need to be very careful when you are building a model, particularly in the cases of regression models, where it is represented by a line and a polynomial. You need to make sure that the polynomial is not so complex, at the same time not so simple. Then you will either end up in an overfitting situation versus an underfitting situation. So we need to have a good balance between these two. Right. So in summary, when kind of statistical questions comes in, it would mostly covering things like some basic statistical properties, as you would be like very aware of, like things like standard deviation, averages, how to interpret median, how to interpret quartiles, right? The first quartile, second quartile, and so on. And what do you mean by percentiles, right? These are some basic questions. A bit more complex in nature might be discussions around sensitivity, overfitting, underfitting. These are like statistical ideas. So you want to prepare maybe from a basics level using the properties like standard deviation, mean, and so on, till things like overfitting, underfitting, statistical, the sensitivity and specificity kind of ideas. So that will like make your ground a bit more stronger when you are going for the interviews. And these are at least the bare minimum for you to understand in the statistical concepts, right? Even anything less than that, you might like face some difficulties in the interview. Okay, but let's also talk about now questions which are related a bit more on data analysis. So let's see what kind of data analysis questions which might pop up in the interview. Okay, so some generic questions like this. People normally do analysis on structured data, which is in rows and columns, but there might be cases when the data is not so well structured, and those places the data might be textual. For instance, in Twitter, right? If you're doing any sort of algorithms like sentiment analysis, quite commonly known algorithms. So in that case, the sentiment analysis could be for a brand, for an election campaign, or maybe something else around your product features and so on. So text analytics in its own are really large domain, and in Python as well as R, there are number of libraries. So in particular, R has libraries like TM, right? The text mining package. Python as well, we have packages like pandas, packages like the NumPy ones, right? And also packages like NLTK, which is built only for natural language processing. So it can deal with many different sort of text mining approaches or text analytics approaches. So in comparison, if you talk about, as I said, the robustness in Python is much more than in R, but in terms of features, both are powerful enough with the libraries and packages that it offers, right? One of the fundamental sort of starting place when you do any analysis. So when you are given a data set and you are asked to do some sort of basic analysis of what that data tells you, maybe typically of questions like, I am in a retail business and my sales in a particular region is going down. So this is an analysis that is expected out of you, and you need to dig through in understanding what really is the problem in the sales going down. So if this is sort of the data which is given to you, you might want to first look at the transactional data which is present in the system. Then you might also want to go to data outside of your network. Maybe you might get the sentiments of your customers from social media platforms and so on. So there will be different sources of data that you will collect. But oftentimes, collecting the data is not only the task, right? And not like only building a model or doing statistical analysis might like come very later in the stage. But what comes before that, after you have collected the data, is to make sure that the integrity of the data is maintained. You get rid of all the unwanted noise from the data, and then finally prepare the data for doing the sort of modeling exercise or doing descriptive analytics on top of it. So this cleaning and understanding the data, doing a lot of explorations with plot, in essence takes close to 70 to 80% of your time in any data analysis task. So if your company maintains the data in a very well structured way, this kind of heavy time which we spend on data analysis might be reduced, or the data cleaning might be reduced. Otherwise, you need to like take this up for any new project that you take up, for which the data is not available in a prior, or you don't have like any pipeline which do this cleaning. You have to write it down of your own. So very, very important. If you don't do the cleaning part and understanding the data well, the analysis or the models that you build might end up giving you a very, very bad performance. Right? So very important. As I said, 80% of the time people normally spend on this task. Right. And oftentimes when you are analyzing things like the example I told, my sales are going down, what do I do? It is not possible to come out with such answers to complex problems like this with just one variable, right? So you might also want sometimes to move beyond one variable and talk about, let's say, how to do multivariate or bivariate kind of analysis. So oftentimes this question comes up where you like asked to distinguish between this univariate, bivariate and multivariate analysis. And the idea is very simple. In any sort of analysis, it is not only one variable which kind of decides the end output of your analysis, but there are multiple factors involved. So when there are multiple factors involved, you might also want to look at things like correlation. There are multiple variables. You want to see if there is any correlation between these things. Sales are going down, but because of what? Is it because my sales representatives are not going to the market, or is it my products are bad, or is there some other reasons? So with all the variables in one place, you might want to go and dig deeper to see if there is any relationships coming in the variables or not. And when we collectively get all these variables together and do some sort of coherent analysis around the problem, you come out with a really crisp answers to what you are trying to analyze, right? And moving on, there is also times when people do some sort of grouping, right, with the data. You do a sampling, right? You get a data set in your system or in whichever servers you are doing the analysis. But in that, there might be many number of times when even the randomized sampling of getting the true representative from the population like that might not work well, right? So in those cases, you might want to do some sort of systematic sampling, or maybe a cluster-based sampling as well, wherein you might decide to say, I want to analyze the issue with only 5 regions in my mind, and with the 5 regions, I'm going to form different clusters. Or in the systematic sampling, you might also want to say that with the 5 regions that I have got, I might want to analyze only for one product, right, which is not doing that good in the sales. So these kind of sampling techniques, like the cluster-based one or the systematic sampling techniques, and there are different names for this, people might be able to give a very good interpretation of what really went wrong in whichever sort of analysis you're doing. So one example is like sales going down, but you can adapt this to other analysis as well. But the idea is instead of doing a randomized sampling by which we are not very sure which kind of data is coming in the data set which we want to use for analysis, but if you do it in a cluster basis, a cluster or a systematic sampling, you know exactly which clusters or which sort of regions in this example you are like analyzing, and in your end of the analysis you'll be very able to say this is not like a randomized sample that I have taken, but from these 5 regions. So there are many different ways of doing clustering, cluster or sort of the systematic sampling, which kind of helps in this particular final end results of your analysis, to put your end results in the right perspectives, right, instead of doing a randomized sampling. Okay, one more quite a useful sort of an idea, kind of widely borrowed from the field of linear algebra, and this is a bit related to what we earlier saw between moving from one variable to multiple variables, right? And eigenvalue and eigenvectors, kind of a concept borrowed from linear algebra, helps us to bring in some way a linear combination of different variables together. For instance, in some complex analysis, it might happen so that given a data set, it might have many columns, right? Let's assume you have a data set with 1 million rows, and let's assume 10,000 columns. So, and these 10,000 columns are some features. There are complex problems like that. But in most often, like most of the time, not all the 10,000 variables are useful, right? The input variables. So what we can do is we might want to transform this data set in a lower dimensional space, by which we mean this 10,000 columns can be reduced to, let's say, only 100 columns, right? So eigenvalue and eigenvectors are these ideas which helps us in this transformation. And the idea is, can this 100 variables be represented as some sort of linear combinations of the 10,000 variables? And if I'm able to do that, my dimensionality is reduced, the time I take to do the analysis is kind of also reduced, and the representability which will come with only 100 variables will go up, right? So quite a powerful idea, eigenvalues and the eigenvectors. And as I said, the eigenvectors is kind of that linear combinations of many kind of variables there. And this calculations around eigenvectors normally happens for a correlation or a covariance kind of a matrix, which, as you know, the measure correlation is also about how two variables are related, or how strongly two variables are correlated, right? So that's why we are also saying this eigenvectors can help us to compress the sort of data that we have, right? And that's because of one eigenvector can be representing 100 column, 100 variables together, right? So that's sort of how it works. Quite a powerful idea, and commonly used methods for reducing the dimensions of a large data set, like the PCA, principal component analysis, is actually based on eigenvalue and eigenvectors. So if somebody asks you about eigenvalue and eigenvectors in an interview, also talk about the PCA, principal component analysis, which is actually based on these two concepts. So that gives them a good idea to the interview. You know about eigenvalues and eigenvectors, and you are also able to think of its application, like in PCA, right? So we talked about this false positive and the false negative cases in our confusion matrix example. So this is exactly the same. We also talked about the type 1 and type 2 error. Okay, so but let's now also drill further and say examples or kind of scenarios when the false positives are important and scenarios where the false negatives are sort of important. And by the term importance, we mean, are we like allowed to do this mistake? If we are building a machine learning model, are we even allowed to do a mistake on either of the cases, the positive or the negatives? So for instance here, if I take an example in a medical domain, where we have, let's say, a process called chemotherapy, which is normally given to cancer patients, which is a radioactive kind of a therapy which kills the cancerous cells, right? So it is very focused sort of a therapy on the cancerous cells. So what will happen if you like predict, let's say you are building a model for detecting cancers, right, given a CT image, and this model would obviously not be 100% correct. All machine learning model has its limitations, but you are here required to predict this, whether a patient has cancer or not, and based on that, radiologists might decide that whether the chemotherapy is right for this patient or not. But imagine now, if you have predicted somebody to be positive for cancer, but the patient is actually not having the cancer cells there, right? So in those cases, you might end up saying, let's go ahead with the chemotherapy, but the side effects of chemotherapy are like very, very adverse, right? Because you're giving these therapies on the healthy cells if the patient is not having the cancers. So in these cases, sort of the false positives becomes a bit more important. So it will be absolutely fine if your model says the patient doesn't have cancer, even if there is like this slight possibility of cancer present in the cells of the patients. But in that case, you are not like exposing the patient with a chemotherapy there, right? Which is like more harmful than saying that the patient doesn't have the cancer, right? So in these cases, the false negative, though the false negative itself is not so good in this case, but at least with this particular example, the false positive gets the importance than the false negative. But both are bad, as you know, right, from the confusion matrix discussions. So in simple terms, it is better to not expose the patient with a false positive with a treatment like this, chemotherapy like treatment, then it is like much better than saying you don't have cancer. Okay. And a very similar example in some other context might also come up. So if you would like to think of some other examples in the same context. Okay, so where is the other case now, which is the false negative, right? So we talked about the false positives importance, but there might be also cases where false negative might become a bit more important there. And for examples like this, if you are, let's say, building a model where you want to convict a particular criminal basis all the records and the arguments which has happened in the code, right? And let's see what would happen if you make a criminal go free, right? Because your model says it's false negative. Though the person is actually a criminal, but because your model predicted based on all the evidences you had, the person is not a criminal, so you are letting a criminal like walk free in society. So that kind of is more harmful than convicting that person, and maybe for a prolonged period you might also want to get more evidences and build a stronger case. So it is fine to keep a suspect in behind the bars for a longer period than letting the suspect go free there when we like know that it might be a case of a criminal going free from the judicial systems there, right? So in these cases the other case becomes more important. So keep in mind, it is very easy to get yourself confused between this false negative and false positive, but if you keep an example in mind always, and like don't give any room for confusion there, though it is a confusion matrix based on which these two ideas comes in, you will be able at every time put these examples in front and talk from that. So if you start to explain what false negative is in terms of the formula, you might get confused, but if you take an example and then explain, things are much more clear for you as well as the person who is hearing that in the interview, right? And in cases when both are important, typically the one which relates to banking industry, you are building a model which will decide whether to give a loan to a person or not, basis many of the input attributes that around which you have like collected the application from the customer. But here you say, if the customer is really good and you are missing the opportunity there of not giving the loan, versus the customer is really bad in terms of his or her credit history and you are giving the loan. In both the cases, in one case you are losing the business, in the other cases you are taking a risk in which you will lose your money, right? So in this case, in this example, both kind of has an equal role. So if your positive or false negatives are in either of this is high, you will end up losing some chunk of your money there. Keep these three examples in mind, and every time you get to like hear false positive, false negatives, things should not be like confusing at all. Okay. So now let's also talk about building a machine learning model. So far we have discussed about what happens after building the model, right? But let's get one step back and see how do we normally build a machine learning model and what kind of processes we normally follow. So when we are like building a machine learning model, we know that we need to, given a data set, we need to divide it into different buckets or different parts. So the commonly known divisions that we like have is your training data, right? Then we also divide the data into something called test data, and sometimes people also divide or keep one portion of your large data set which is called the validation data. So oftentimes people confuse between the test data and the validation data, right? So what happens is in the training process there are certain models wherein while you are training you will use the training data obviously, but in the process of training you can also involve something like a validation step, right, which will make sure that during the process there is one part dedicatedly given for the validation of the model, and when the model is done you might see that the final model is well trained on the data, at the same time validated. But when the model is completely done, then only you get into a process that we call testing, right? So you can imagine like this, you have a data of 1000 records, you keep some 700 records for training, 100 records for validation, and the remaining 200 records for testing. So there are three splits, right? If I would like to explain this with an example, this is how it will happen. So there is a process called k-fold cross validation, in which k can be any number like between 5 and 10. Mostly there are like standards saying 5-fold cross validation or 10-fold cross validation. And the idea is when you are building your model, you will work with a training set, right, and a validation set, in which a small portion of the data you keep for validation and the rest you use for training. So what you see here, test set, can be like replaced with a validation set. right? And you can see that this is a rolling sort of subset, and you keep changing it in each fold. So you go for the first fold of the iteration, you keep one validation set, and the rest of it is the training set. And the next fold, you move this window to another subset, and the rest is training data, and so on. And when this model is done using this k-fold cross-validation approach, in the end you will get a model which you can then use on the testing data to see if the accuracies are good or not. So this kind of brings in a lot of performance improvements. People have also found validation set to be a really good way of tuning the parameters. In many machine learning models, as you might know, there are something called parameters, typically in the neural network models. And these parameters need to be tuned as the model is kind of proceeding. So we cannot use the testing data set for tuning these parameters. So validation set kind of comes very handy in those cases. Right? So we just talked about the cross validation. So when you keep moving this validation set in each of the fold, first fold, second fold, third fold, and the validation set is keep changing, you kind of do this process of cross validation, right? And the idea behind doing cross validation is to see how well is your final model generalizes to the data that you have. So independent of which data you use for training, your model should generalize. Because oftentimes it happens when you train a machine learning model, it works very good in the training part, but when it comes to the testing, the model does very bad. The same problem with the overfitting and the underfitting cases. So in this approach of cross-validation, you have made sure that your model has trained on various subsets of the data, right? And in the process, we also have this small validation set so that every stage of the cross-validation process, you are able to use a different subset. So that means you have trained your model very well. So irrespective of which data you use, your model is going to do well in the testing cases. So that's how cross-validation brings in the capabilities. So thanks a lot for listening to this session. Hope this helps. Hope you all get a really, really successful career in data science. Thank you.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!